Will you go ahead with the... do you want me to start the introduction of it? So what we're doing as food safety department, basically, when the request is coming, as I said, we're having few systems. So IRS is one system, smart inspection is another system that we're having, but we're having other systems along with that. We're having the notification system, which is kind of, I would say, partially manual for now, but we're planning to kind of go with fully integrated systems in the future and fully automated systems. And we're having also the food poisoning systems and the foodborne illnesses coming from the DHA, which is, again, not a fully, I would say, automated system and not fully, I would say, smart system. So we're working towards that. This is the first entry that we're having. So all of the requests coming to our department, food safety department, via few systems. Those systems are obviously received by the sampling unit that is falling under the studies section. Sampling unit will be planning for the visits, so we go and collect the samples either from the market or from the warehouses of the food products, or if it's like a notification case or a foodborne case, we do locate where is the problem and where is it happening. We collect the samples following the scientific methodological processes, also known, I would say, in the area of, I would say, statistics and so on and so forth. So the sample which is collected is supposed to be representative to the rest of the population of samples of the food products. After we're collecting the samples, we're delivering the samples to the laboratory, Dubai Central Laboratory. So the Dubai Central Laboratory will obviously have an internal system where they're receiving the samples. I guess that will take care of the rest of it.
It is the same labware system where we're using it to receive the sample and take all the information for the sample. The inspector will hand over the sample to the team of receiving sample, and there they will recheck that sample and with all data, temperature, the condition of the sample, all will be feeding in that labware system. That will reflect in the results when you will, the inspector receive the results.
Thank you. So if I may understand clearly, the Food Safety Department identifies and collects samples while Dubai Central Lab tests these samples and results inform actions. This is a great example of teamwork protecting public health. Let's now look at some real-life examples for your collaboration in action. Could you share your common practice for handling emergent cases and complaints and explain how your team typically responds?
So in food safety department, as I said, that we're receiving the, I would say, cases via so many channels. One channel that is coming repetitively, I would say, with the workers and I would say the low-income community. So those communities are usually having some practices that are causing them the buildup of foodborne illnesses. And obviously, we've got so many, I would say, positive cases when it comes to the workers with low income. Those people, they have a tendency to follow really bad practices in storing the food products, and they do have a tendency to kind of, because they don't want to keep buying food products and they don't want to kind of pay for the storage and under the good conditions, so they have a tendency to hide the food, like under the bed or somewhere, and they keep like eating it afterwards. So obviously we keep having some cases related to that, specifically from the workers' camps. Where they're like consuming, I would say, already spoiled products and already contaminated products with related microbial contaminants. So how we're kind of handling such cases and how we're receiving it and how we're delivering the right, I would say, approach in that system. So obviously our team, who's like the team which is taking care of the foodborne illnesses, we have a formed team in food safety department. They will be called even in the middle of the night. They will go and check basically the cause of the contamination and the foodborne illnesses. They will go and check with DHA all of the symptoms, the Dubai Healthcare Authority. They will check all of the symptoms coming to the cases, and they will link, obviously, the symptoms with the cause of the microbial cause. Most probably it's a microbial cause. So they will link all of the symptoms together. If it's like vomiting, diarrhea, and so on, they will link it with the related pathogen. And obviously, based on that, they will request from the Dubai Central Laboratory to do specific tests for specific food products for specific microbial contaminants. And if the results were obviously positive, we report back to DHA, telling them that we received such and such from the laboratory as confirmed case. And we report back to the workers, telling them that this is what you're facing, guys. You kept storing, for example, food under the bed, and this is the end of the story. So obviously, afterwards, we kind of transfer the case to our team, internal team, which is the awareness team. We do tell them to start educating the community that there is like a wrong practice that is happening in the I would say among such communities, and such practice or such awareness programs, we do see the benefit of them afterwards. So the training programs target specific things. Every now and then we start like targeting specific communities, specific contaminants, specific like cases that are appearing in the market, and obviously we do see the impact on the I would say consumers and the population. So such practice is reducing the foodborne illnesses cases and reduces the bad practices or wrong practices happening from I would say the low income as an example.
Adding on what Dr. Amal is saying, as they are alert 24 hours, there is also a team in lab waiting on call for any incidents, any emergencies, samples will come. So we have a team who will be serve this part of testing to do it and ready for that.
And what innovative tools or technologies help you detect these risk factors, and how do mobile labs or rapid testing campaigns contribute to safety at larger events?
Speaking about innovation, mobile lab was one of the innovations to solve this kind of incidents and to be on the spot. So mobile lab having advanced rapid testing technique on the spot where we covering the events and festival like Global Village. So there in festival normally there is ready-to-eat foods and different kind of cooking style. So there we'll need to check for any foodborne disease maybe will come out. So those rapid tests in mobile lab for microbiological tests normally will take by conventional testing around 3 to 5 days, but using rapid test technique, it is 48 hours. We can get good results to compare what or to prevent any incident can be happen.
Regarding the chemical section, of course, we have advanced chromatography spectrometer, LC-MS-MS, GC-MS-MS, which one we are using for the pesticides analysis. And like you know, we are analyzing around 450 compounds for pesticide in different commodity, and veterinary drugs 86 compounds also in the food and food supplements. Also, of course, we Dubai Central Lab have ICP-MS and ICP-MS with the HPLC for analyzing lead, cadmium, arsenic, and mercury. Of course, there is another also an instrument like small like NIR and HPLC, the small things.
Thank you. It's really impressive to see how proactive measures like mobile labs allow testing of hundreds of samples efficiently, highlighting how collaboration could extend beyond these office walls. Obviously, there is no system without any challenges, so let's discuss the obstacles you face and the opportunities ahead. What challenges do you face in detecting food hazards?
As microbiological testing, especially in pathogens like Salmonella, where we use conventional method and taking around, as I told, like 3 to 5 days to confirmation. Then when we start using advanced technique like PCR and ELISA or ELFA, all these things will give the results within 24 hours. So it is on a screening base, but still I have to look for to do the confirmation, because in microbiology we are looking for a live cell which affect on the samples, not the dead. So using advanced technique, only to detect it, only to detect the DNA, it is not enough. Still, we have to go to do the conventional method. So that will take, again, long time to confirmation. That's one of our microbiological challenges we are facing it.
Of course, in chemical complexity of the matrix, it is a big problem in the, of course, in the what you call chemical, because food contain multiple ingredients, food additives, and natural compound also. To interface this one with the detection, it make big challenges with us. But of course, in the Dubai Central Lab, we have a highly sensitive instrument like LC-MS-MS and GC-MS-MS, and this one is making it a little bit easy for us to detect this unknown compound. And of course, low level of concentration of some commodity, and this one to take out like arsenic or let's say in pesticide, new compound, it is every time, and it is adding in the food. This is making a little bit challenging for us.
Adding on, as you said, the new compound like this, every day there is a new items coming, like a novel food, we'll say. So those will challenging us in which parameter we have to conduct on it, in which phase maybe it can get contaminant, maybe from salmonella or clostridium, we don't know. So those new or novel foods need to put it under a new parameter, a new standard. This is one of the also challenging what we face in testing.
How do you overcome issues like resource limitation or emerging hazards?
Of course, for the resource, we have, I say, sensitive instrument, automation also, and use highly instrument like LC-MS, GC-MS-MS. And of course, the staff training, it should be there, the staff training, it will help for us, that one. And collaboration with the other laboratories and research center.
Looking forward, what opportunities exist for improving the collaboration of food safety outcomes?
When we're talking about the outcomes you're saying, from the, I would say, the food testing and the collaboration with the Dubai Central Laboratory, first I'd like to elaborate on what my colleagues just introduced. With all of the challenges and innovation that is needed in the, at this moment to be kind of fulfilled, I would say, when it comes to the area of food safety. So having all of the new technologies appearing in the market and having kind of, I would say, the level of speed that we need at this moment in time, with the level of accuracy and the level of kind of confidence on using such systems and introducing such systems to what we're doing as, I would say, to kind of increase the level of people's, I would say, appreciation even to food safety, I would say, and understanding the understanding from the community to what we're doing as, I would say, as a government is a lot of work, is really a lot of work. So when it comes to having all of the new technologies and kind of give everything a better understanding and introducing all of these terms and terminologies to the community is not a joke, I would say. So that is one aspect of the story. And then adding to what my colleagues also said, all of the challenges that we're facing at this moment is having a huge number of food products coming to the Emirate of Dubai and having kind of an increased number of populations. So that is kind of, by now is like, I would say, exceeds the capacity and all of the number of employees that we're having, also the, I would say, resources that we're having as a government. So I would say introducing innovation and introducing all of the AI tools and so on and so forth at this moment is not even a question. It's like a matter of time that all of the people will need to kind of start like learning more about it, will need to start kind of, I would say, not even understand it, but also follow it and kind of implement it and have it in place. Because such practices will change the dimension and the direction of where we're heading. And I do agree with what they're saying, that the speed is needed at this moment in time, and having kind of the speed is not supposed to jeopardize what we're doing. So we're not supposed kind of to speed also the process and kind of I would say, break the system of what we're doing of testing the right contaminants, doing the right risk assessment, and so on and so forth. Such, I would say, a level of thinking will change how we're doing stuff. This is what I believe in. Thank you.
So the key point is, while challenges exist, teamwork and innovation is keeping your organization ahead. This is very important for public health protection. I guess we're wrapping up early today. We now have some time for Q&A, so please, audience, if you have any question, kindly raise your hand and I will direct your question to the relevant panelist. Thank you. Yes, the microphone, please. Over here. Up front, first row. No problem.
السلام عليكم. أخوكم حسام العميرة من الهيئة العامة للغذاء والتغذية في دولة الكويت. نشكركم حقيقة على جهودكم. عندي سؤالين إذا تسمحوا لي. السؤال الأول، في الوقت الحالي الراهن الآن معروف أن المختبر عنده سعة معينة لاستقبال العينات، يعني لا يستطيع أن يتعداها. ما هو يعني النظام الحالي الموجود الموازنة بين العينات الروتينية اللي تجي أو العينات المسوحة التغذوية أو السيرفيز؟ يعني كيف يتم التنسيق بين المختبر يعني الأجهزة اللي في الموانئ أو التفتيش اللي تسحب العينات؟ هذا السؤال الأول. السؤال الثاني بالنسبة يمكن للأخ خالد، الآن من المتطلبات لأي عينة يعني شحنة تصل إلى الدولة أن يكون معها أوراق رسمية، ومن هذه أهم الأوراق طبعاً الشهادة الصحية وشهادة الحلال. هل هناك متطلب في القوانين في يعني الإمارة دبي أو على مستوى الاتحاد يتطلب أن الشهادة الصحية تكون يعني تاريخها صادر قبل مغادرة الشحنة الموانئ، أم يعني يكتفى بأنها تكون صادرة وموثقة؟ وجزاكم الله خير.
حياك الله أخوي أسامة. بخصوص سؤالك إن شاء الله تفضل فيه، أن الشهادة الصحية لازم تكون قبل تطلع الشحنة من بلد المنشأ، تكون مصدقة من جهة الحكومية الموجودة هناك أو المنظمة المعتمدة هناك قبل خروج الشحنة من بلد المنشأ. الله يسلمك.
The capacity.
Yeah. So I'm sorry about that, but I'll talk in Arabic for the people who would like me to translate later. I cannot translate as much as you need. بالنسبة للتعاون بيننا وبين مختبر دبي المركزي، وكيف نحن ندرس داخليا يعني الطاقة الاستيعابية، وكيف نحن نحط خلينا نقول مجالات تحديد مخاطر المنتجات الغذائية وخطر المنتجات الغذائية. في كل بداية سنة نحط خطة. هالخطة مقسمة لأقسام. القسم الأكبر فيها طبعاً العينات الروتينية، تأخذ تقريباً ما بين 40 ل 60%. البقية تظل خطط المسوحات وخطط الدراسات والأبحاث. بصراحة الحين احنا بمرحلة انتقالية تعتبر في التعاون مع الجامعات تحديداً، على أساس ناخذ هالعبء اللي كله حالياً على مختبر دبي المركزي في الفحوص في المجمل بالتنسيق مع الجامعات، والجامعات راح يكون عندهم الدور اللي قد يعني يوصل ل 20%. فهل 20% بتسبب يعني او خلينا نقول بتقلل عبء كبير واقع علينا ان احنا كحكومه حاليا، زائد راح تشرك يعني خلينا نقول القطاع الاكاديمي مع الحكومه. هذا جانب. الجانب الثاني اللي هو اشراك القطاع الخاص. بصراحه نحن يعني من تجارب متكرره لاحظنا ان فعلا دور القطاع الخاص وحتى الدور الاكاديمي مطلوب في مرحله من المراحل، وهالنوع من الشراكات ايضا مطلوب. يعني نحن كحكومة استحالة نقدر نؤدي الأدوار كلها بالطريقة المثلى أو الفضلة اللي نحن نطمح لها بدون أي يعني إشراك للقطاعات هاي. هذا من جانب. الجانب الثاني طبعا الاستفادة من الخبرات اللي جاية من برا الدولة. هل المؤتمر مثلا مناسبة كبيرة على أساس نحن يعني خلينا نقول نتحاور ويعني نرفع خلينا نقول توصيات معينة أو نطلع بدروس مستفادة كل حد يتعلم من الثاني، بحيث أن هالدروس تجمع في مكان واحد أو سلة واحدة. مقابل هالسلة نحن والله نبدأ نحط خططنا للسنة الجاية، كيف راح نتحرك، كيف راح يكون توجهنا المستقبلي. سابقا كنا نحط خطط سنويه، لكن المستقبل راح يكون مختلف. بنبدا نحط مثلا خطط على حسب المتطلب وعلى حسب خطوره المنتج، او على حسب خلينا نقول خطوره الكونتاميننت مش المنتج نفس خطوره الكونتاميننت، يعني الخطر اللي موجود في المنتج الغذائي سواء كان ميكروبي او كيميائي. انت لما تتكلم عن المخاطر الميكروبيه لها فتره معينه وتنتهي، يعني والله باتش منصاب. بس انت لما تتكلم عن كونتاميننس او خلينا نقول مثلا ملوثات كيميائيه، عادي تكون التربه اصلا مصابه فيها اللي اصلا مزروعه فيها المنتجات الغذائيه. فهالامور هاي كلها ما كانت محطوطه في تحت بند الداتا اناليسيس تحديدا اللي هو تحليل البيانات. فنحن حاليا بادين في ستيج تحليل بيانات بصراحه على مستوى جدا موسع. هل تحليل البيانات اللي بهالمستوى راح يعزز دور العمل الرقابي من ناحيه، راح يعزز ثقة المجتمع في العمل الرقابي من ناحية ثانية، راح يعزز قوة القرارات لما ناخذ قرارات على مستوى جدا عالي فيما يتعلق بالمنتجات الغذائية. هذا جانب. على الجانب الثاني دور الجانب التشريعي، لأن أنت تتكلم عن سؤال بسيط لكن الإجابة عليه صراحة يعني جدا معقدة، وفي لها أكثر من نموذج عمل، وفي لها أكثر من خلينا نقول آلية حتى في التنفيذ والتطبيق. لما نيجي للجزء التشريعي ودور مثلا وزارة التغير المناخي والبيئة في دولة الإمارات، وزارة التغير المناخي والبيئة دورهم جدا فعال ورئيسي في منع دخول بعض المنتجات الغذائية اللي نحن نشتبه في خطورتها على مستوى على الدولة، واستمرار أو خلينا نقول تكرار استيراد بعض المنتجات اللي فعلا فيها خطورة عالية وما في معالجة من الدولة اللي مصدرة لدولة الإمارات. ومستقبلا راح نرفع هالنقاش حتى على مستوى خليجي على أساس دول الخليج بعد تستفيد من هالتجارب، لأن فعلا هالتجارب تحكم العمل الرقابي بدرجة جدا عالية وتقلل حتى فرص الغش في المنتجات الغذائية، مش بس يعني التعاون مع مختبر دبي المركزي أو المختبرات في المجمل. بعض الحالات ما تحتاج حتى تتحول للمختبرات مباشرة، أنت تقول والله هالمنتجات أنا راح أطلعها من اللاين أوتوماتيكلي، ما راح أسمح لها تدخل أصلا الدولة من الأساس، لأنه والله المنتج لما أو خلينا نقول المستورد لما بغى يدخل المنتج ما احترم قوانين الدولة. وفي هالحالة أنا أتكلم حتى عن قوانين الخليج، لأن إحنا كخليج أصلا بيننا قوانين جدا مشتركة على مستوى جدا عالي. فهذا جانب تشريعي مهم، أو خلينا نقول جانب تنفيذي تشريعي مهم تقوم فيه الجهات اللي على مستوى اتحادي مش على مستوى محلي. نيجي للجانب كايند اوف الاخير، او خلينا نقول جزء بعد تشريعي مهم اللي هو جانب المواصفات. تكلموا عن هالموضوع خواتي، اللي هو جانب تحديث المواصفات بما يتوائم مع النوفل فود تحديدا اللي هي المنتجات المستحدثه. هالجانب بعد مش مغطى بطريقه جيده عندنا حاليا في منطقه الخليج بسبب كثره المنتجات اللي داخله كانها سوبر فود، يعني منتجات تعطي مثلا مواد مغذيه اعلى عن المنتجات الطبيعيه فيسمونها سوبر فود، بمعنى ان هي تستخدم استخدامات خاصه. فهالمنتجات نحن حاليا ما قدرنا نحصرها بطريقه جيده كإمارة دبي لكثرتها من ناحيه، ومن ناحيه ثانيه عدم توفر الفحوص المناسبه لها، من ناحيه ثالثه احنا ما عندنا بعد المعرفه الكافيه عن طبيعه خلينا نقول مثلا انتاجها، عن طبيعه يعني عمليه البروسيسنج اللي تتم عليها اللي هو الفود سبلاي تشين، من مرحله اللي هو الانتاج لو كانت يعني زراعه مثلا مرحله الزراعه استكمالا للمرحله الاخيره اللي هي مرحله الاستهلاك لما توصل للمستهلك الاخير. فهالعمل هذا كله خلال الرحله بالكامل يحتاج نوع من الدراسة ونوع من تحليل البيانات. فتحليل البيانات هذا أنت على كل مستوى تطلع خلينا نقول مخرج معين أو توصية معينة. التوصية هاي قد ترقى أنها تكون على مستوى تشريعي، قد لا ترقى، ممكن تكون فقط تنفيذية. فهذا اللي احنا شغالين عليه. إن شاء الله أكون جاوبتك.
Yes, over there.
صباح الخير جميعا. أنا بشكركم على الدعوة الكريمة لحضور المؤتمر. أنا مهندسة رضا، هيئة المواصفات والجودة المصرية. أنا شايفة الجامع كله عرب فأنا هتكلم باللغة العربية. فيما يتعلق بفترات الصلاحية، هل ليكم تشريعات خاصة بفترات الصلاحية؟ ولو المنتج صالح وهو مش مطابق للتشريعاتكم هل بتسمحوا بدخوله ولا لأ؟ دي النقطة الأولانية. النقطة الثانية فيما يتعلق بمتبقيات العقاقير والمبيدات، هل لو في عقار أو مبيد مسموح في بلد المنشأ ومش مطابق لتشريعاتكم هل بتدخلوه ولا ليكوا مثلا يعني إجراءات خاصة بهذه الخطوة؟ آخر سؤال بس معلش، أو تعليق بس على عملية السوبر فود. احنا في مصر الأغذية دي لازم تسجل في الجهات المعنية، ما ينفعش تخش مصر غير بخطوة استباقية وهي عملية التسجيل لدى الجهات الخاصة ووضع رقم التسجيل على المنتجات. فده ممكن يكون حل بسيط لمثل هذه المنتجات. شكرا.
بالنسبة للسؤال الأول الخاص بالمواصفات الخاصة بالشلف لايف تحديداً فترات صلاحية المنتجات، هو تحدي قائم أظني على مستوى الخليج بالكامل، وأظني قائم حتى على بعض دول العالم. بالنسبة للمواصفات اللي كانت صادرة الخاصة بفترات صلاحية المنتجات تعتبر مواصفات قديمة، ومع خلينا نقول التقنيات الجديدة في الصناعة صار يعني موضوع خلينا نقول الالتزام بالمواصفات أمر فيه تحدي جداً عالي. بالنسبه لدوله الامارات احنا عندنا مواصفتين خاصه بالشلف لايف، الاولى هي الالزاميه بالذات للبريشبل فودز اللي هي المنتجات خلينا نقول الطازجه او سريعه التلف. اني على الجزء الثاني للمواصفه اللي هو المواصفه الاختياريه، المواصفه الاختياريه طبعا هي مش الزاميه، فالتاجر له احقيه اختيار لو يلتزم فيها او ما يلتزم فيها حسب منتجه الغذائي. لكن الالزاميه نعم يلزم التاجر يعني الالتزام بالمواصفه بنسبه 100%. الجزء الخاص فينا نحن كبلديه دبي لما يعني تينا مثلا بعض المنتجات ونحن متاكدين انه والله الممارسه الخاصه بالمستورد والمصنع في بلد المنشا كانت له ممارسات تصنيعيه خاصه بتقنيات حديثه بطرق تمدد فتره صلاحيه المنتج، يعتد بها ويؤخذ بالدراسه، ونرفع الدراسه لوزاره الصناعه. وزاره الصناعه ممكن تاخذ براينا كجهه محليه وممكن ما تاخذ براينا، لكن كاماره دبي نعم تدرس هالمنتجات اللي طبيعتها بهالطريقه اللي تكلمت عنها، ويعني يعتد خلينا نقول الدراسه اللي المصنع في بلد المنشا شاركها مع الجهه الرقابيه، وبصراحه احنا نشوفها كانه يعني I would say effort، يعني هو جهد مبذول من المصنع، وفعلا هو حاب انه يوفر منتج صالح للاستهلاك الادمي باعلى درجات الجوده والاطول فتره صلاحيه ممكنه، فنعم يعتد بهالنمط من الدراسات. هذا الجزء الاول من السؤال. الجزء الثاني اتوقع سالتي عن شو كان؟ العقاقير اتوقع؟ لا العقاقير بالنسبه للعقاقير اذا كانت مسموح باستخدامها في بلد المنشأ، ونحن عندنا قوانين وتشريعات في دولة الإمارات وفي الخليج تمنع استخدام هالعقاقير، نلتزم بالمواصفة بما فيها مثلا على سبيل المثال المضافات الغذائية بنفس الطريقة، وبنفس الطريقة المواصفات الشبيهة. هالمواصفات نحن ما نقدر يعني كجهة محلية ما نقدر نتجاوزها، لأن فيه يعني هي مشتركة على مستوى الخليج، فالمنتج اللي يدخل دولة الإمارات مسموح له يدخل دول الخليج الأخرى بنفس المستوى. فهالمستوى من الشراكه مطلوب على مستوى الخليج، وسعيا منا نسهل العمل خلينا نقول الاقتصاد على مستوى الخليج. نحن ما نسمح بدخول منتجات مشابهه، لكن يرفع المقترح او ترفع التوصيه لوزاره الصناعه وتناقش على مستوى خليجي، ولما نطلع بتوصيات معينه قد يكون تحديث مواصفه، قد يكون استحداث تشريعي جديد، نعم يعني يعتد بالدراسه القادمه من المصنع، لكن تاخذ فتره طويله. يعني المستورد حتى لو وفر الدوكيومنتس عشان تمشي في اجراءات الموافقه تاخذ فتره طويله، تعتبر طويله، لان العمل التشريعي مختلف عن العمل الرقابي التنفيذي. العمل التشريعي بالعاده ياخذ وقت اطول. فهذا بالنسبه للسؤال الثاني. السؤال الثالث هو اللي كان عن السوبر فود. بالنسبه للسوبر فود نحن كفريق عمل داخلي في اداره سلامه الغذاء ندرس المنتجات ونسجل المنتجات، وحتى يعني خلينا نقول نراجع متطلبات البطاقه الغذائيه، يعني نلزم المنتجات في هالحاله بالالتزام بالمواصفه العامه الخاصه بالبطاقات الغذائيه. وتسجل المنتجات، لكن بعض الأحيان تدرس المنتجات حتى لو كانت لها خصائص طبية معينة ويرفض دخولها للدولة، لأن نحن مو بجهة الاختصاص بالنسبة للمنتجات الطبية اللي لها يعني سايد افكتس طبي.
Any questions? I think we have time for just one question. Yes.
السلام عليكم. أنا فيصل رشيدي من هيئة الغذاء من الكويت بعد. يمكن أبي أستكمل، بس لو في مثلا رقم معين على كم العينات اللي يوميا تروح للمختبر، هل في افريج يعني معين؟
هو مو بافريج كثر ما انه يعني اي وود سي حسب الخطه اللي معمول فيها حاليا، وعلى حسب كباسيتي المختبر، على حسب الطاقه الاستيعابيه للمختبر. فالطاقه الاستيعابيه للمختبر تحدد يعني كم عينه ممكن تدخل للمختبر. اتوقع خواتي من المختبر تبون تجاوبون على السؤال، وعندنا مديره المختبر مهندسه هند مهابه بعد ممكن تفيدك اكثر.
السلام عليكم ورحمة الله. هند وياك مديرة إدارة مختبر دبي المركزي. إحنا في مختبر دبي المركزي نستقبل تقريبا عينات سنوية بمقدار 3 مليون عينة سنوية، وليست فقط غذائية، لأن إحنا عملنا متنوع ما بين عينات غذائية وعينات استهلاكية وعينات مواد بنية تحتية وعينات أيضا مواد بناء وعينات أجهزة كهربائية. فالمختبر فيه تقريبا 5 مختبرات رئيسية، يتفرع منها 28 مختبر تخصصي. طبعا احنا عملنا الفترة اللي طافت على زيادة عدد المختبرات التخصصية التابعة للمختبر عشان نزيد عدد العينات بصورة يومية. طورنا التكنولوجيا المستخدمة من الطرق التقليدية إلى الطرق السريعة والطرق المتقدمة الأكثر تقدما عشان نستقبل عدد أكبر من العينات بصورة يومية. فأنا ما أقدر أقول اليوم إن نحن عندنا عدد محدد من العينة، بالعكس المختبر صار لنا أكثر من 10 سنوات نعمل بطريقة فليكسبل. احنا ما نستقبل فقط عينات من الجهات الرقابية، ولكن احنا بعد توصلنا عينات من الجهات الخاصة. وصلنا ما شاء الله في بعض الأجهزة إن نحن ما صرنا موجودين فقط في موقعنا، احنا نقدم خدمات خارج المختبر في دول الخليج، على مستوى الخليج ودول آسيا. إن صارت ما في اختبارات فقط تنحصر في داخل المختبرات التخصصية في المختبر، ولكن الخدمات أيضا تقدم خارج المختبر في الدول نفسها.
شكرا مهندسة.
عندي بس سؤال آخر إذا تكرمتوا. الحين بالنسبة للبلاغات الغذائية اللي توصل سواء شكوى محلية أو بلاغ خارجي، شلون تتعاملون معه؟ يعني شنو البروسيجر اللي تمشون فيه في التعامل مع البلاغ؟
يدخل في قناة خلينا نقول مدروسة ودراسة بصراحة جدا دقيقة وبصراحة صعبة بعد، مو بس دقيقة. السبب لأن كل منتج يدخل يعني يجينا بهيئة بلاغ سواء خليجي أو محلي وحتى عالمي، في بعض الأحيان توصلنا شكاوى حتى من جهات عالمية أنه والله في منتج معين عليه بلاغ معين، أو خلينا نسميه إخطار معين لسبب معين، كونتامينت معين سواء ميكروبي أو فيزيائي أو حتى كيميائي. فهالمنتجات مجرد ما نحن نتلقى عنها بلاغ ولو كان بلاغ غير مؤكد، يعني نحن نستلم البلاغات مؤكدة وغير مؤكدة، تدخل في مرحلة تصفية أولى. شو يعني مرحلة تصفية أولى؟ نبدأ نطابق المنتج اللي دخل وبياناته مع كل الأنظمة اللي موجودة عندنا في إدارة سلامة الغذاء بما فيهم حتى الفحوص المخبرية السابقة. فنبدا نشوف نظام الاستيراد اللي هو IRS، نبدا نشوف نظام السمارت انسبكشن لو في بيانات خاصه يعني بالمؤسسه الغذائيه، لان هالنظام اللي هو السمارت انسبكشن هو نظام لوكال يعتبر يعني محلي خاص باماره دبي وخاص فقط بالتفتيش على المؤسسات الغذائيه. فنبدا نجمع يعني خلينا نقول الكم الاكبر من المعلومات اللي ممكن تتوافق مع الحاله، ونبدا نسوي مثل الاينمنت، يعني مثل توصيل، عمليه توصيل. هل المنتج هذا او بياناته هاي اللي جتنا من مصدر خارجي او داخلي سواء خليجي محلي، هل هو متطابق مع اي من البيانات اللي موجوده عندنا في الانظمه؟ لو كان الجواب بنعم خلاص تؤخذ الكيس ككونفيرمد كيس، حاله مؤكده، ونبدا ندور عن الكيس في السوق. وبالنسبه للاستيراد، هل هو المنتج مستورد ومتى اخر شحنه تم استيرادها؟ مباشره ناخذ عينات، لو حصلنا المنتج موزع في السوق مباشره يدخل الفحص المخبري بعد ما نتاكد من ان المنتج سليم. وقبل ما نتاكد حتى من ان المنتج سليم يتم اتخاذ قرار اولي هل نسحب او ما نسحب، لان بعض الحالات السحب اجباري، فانت ما تقدر تقول والله الحالات عامه على الكل عدم سحب، ولا تقدر تقول في العموم هي سحب. فالقرار يكون قبل اخذ العينه هل في سحب او ما في سحب، ومباشره بعد القرار الاخير اللي هو سحب او عدم السحب ناخذ عينات لتاكيد الحاله بالكامل. هل الحاله confirmed كيس ازن يعني من نتائج التحري الاولي اللي هو بالبيانات الاولى، وبعدين التقصي الثاني اللي هو البيانات المتاحه حاليا، هل المنتج دخل او ما دخل، البطاقه الغذائيه متوافقه او غير متوافقه، وصولا لمرحله ان المنتج يستدعي السحب او لا يستدعي السحب. واخر نقطه اللي هي الكونفيرمد كيس، اغلاق الحاله يتم بالفحص المخبري بهالطريقه.
وهذا ما تسوون اعلان حق المستهلكين
على حسب الحاله
خلال فتره التقصي يعني؟
لا، على حسب الحالة. في بعض الحالات وزارة التغير المناخي والبيئة طلبوا منا أنه لازم يتم الإعلان عن الحالات، لكن نحن كجهة محلية كإمارة دبي ما عندنا صلاحية الإعلان المباشر بدون ما نعلم وزارة التغير المناخي والبيئة، وهم اللي يعلمون على مستوى الدولة، لأن الإعلام في هالحالة لازم يتم على مستوى يعني دولة الإمارات، مش على مستوى جهة محلية مثل إمارة دبي في هالحالة. فبعض الحالات نعم صارت، يعني مثلا كانت عندنا كيس قبل تقريبا 3 شهور يا أستاذ أحمد، كانت كيس خاصة بالدبي شوكليت، اظني سمعتوا عن حاله وايد انتشرت الكيس على مستوى العالم، فوصلتنا حتى ريكولز على مستوى عالمي ان كانت بعض المنتجات ملوثه بسالمونيلا، وبعض المنتجات كانت يعني قد تكون ما توافق مو متوافقه مع المواصفات لبعض الدول. فطلب منا ان نسحب المنتج في افلاتوكسين اتوقع بعد. فطلب منا نسحب المنتج. نحن مباشره اللي سويناه تحرينا عن كل المصنعين الموجودين في اماره دبي، اوبسلي بقيه الامارات بنفس الطريقه، تحروا عن المصنعين الموجودين عندهم محليا، شافوا نسب التلوث اللي موجود، حددوا مستوى الخطر. بعد تحديد مستوى الخطر نحن في اماره دبي بعض المنتجات اضطرينا نسحبها لان كان في منتجات بيستاشيو الفستق ملوثه بالافلاتوكسين. فطبيعي القرار يكون في هالحاله سحب المنتج من السوق، تصحيح العمل، خلينا نقول الممارسه الخاصه بالبريبريشن اللي هو تحضير الدبي شوكليت، وانتهاء بالفاينل برودكت وفحص الفاينل برودكت. وطبعا هالعمل كله تم بالتوافق مع مختبر دبي المركزي، وكنا ناخذ عينات طوال فترة عملية التقصي. يعني من الزيارة الأولى لبعض المصانع اللي كانت الحالات عندها فعلا مؤكدة، مباشرة أخذنا عينات من الرو ماتيريال ومن الفاينل برودكت، وبعد تصحيح العمل أخذنا عينات من الرو ماتيريال بعد من الفاينل برودكت على أساس نغلق الحالة بالطريقة السليمة. فلما أغلقنا الحالة طبعا رفعنا التقرير لوزارة التغير المناخي والبيئة، وزارة التغير المناخي والبيئة خلال عملية التحري نشروا على مستوى الدولة خبر صحفي بأن المنتج كان سليم، لأن المنتجات اللي احنا فحصناها على مستوى إمارة دبي وحتى على مستوى الدولة تم الفحص كانت سليمة، ما كان في عندنا منتجات ملوثة. والمنتج اللي كان ملوث كان جاينا من ألمانيا، كان ملوث بسبب شو اسمه خطأ في التخزين من عندهم هم، وما كان عندنا باتشز موجودة في الدولة. فبهالطريقه يتم التقصي عن الحالات المشابهه. بس اذا تبغي بفصل لك لحالات ثانيه، لان هالحاله يعني كايند اوف هاي ليفل وتمت بسرعه وتمت يعني خلينا نقول على عجاله، لان كان في ريسك عالي فيها من الافلاتوكسين، كانت نسب الافلاتوكسين جدا عاليه. فيعني هذا مش الكومن براكتس في كل الحالات.
Okay. Being pressured to end the session. Today, we have learned that collaboration between Dubai Central Lab and the Food Safety Department is very crucial for preventing the foodborne diseases. The process from sample collection, data analysis, data sharing, to regulatory action emphasizes the importance of teamwork protecting public health. From mobile labs to advanced testing technology, Dubai is setting an example for proactive food safety and public health protection. Thank you to our audience for sharing your expertise, and thank you, our panelists for sharing your expertise, and thank you to the audience for your engagement and insightful questions. Thank you.
Good morning, dear guests, and welcome to the session of Advancements in Laboratory Testing. This session showcases breakthrough innovations, transforming how laboratories detect, confirm, and respond to food-borne hazards, with a focus on speed, accuracy, and smarter decision-making. Attendees will gain insights into the challenges of Listeria detection, rapid enrichment-free salmonella solutions, and real-time tools for faster actions, and the expanding role of the next-generation sequencing. The session also highlights the importance of proficiency testing and the contributions of European Union reference laboratories to global food safety. Together, these perspectives offer a forward-looking view of how advanced laboratory capabilities are shaping a more resilient and responsive food system. He holds a doctorate in public veterinary health and a degree in veterinary medicine from the University of Milano, with over 30 years of experience in food microbiology and safety across Europe and Asia Pacific. He currently serves as the Director of Microbiology for Mirex NutriSciences in the Asia Pacific region. He also leads the Italian delegation to the iOS Technical Committee on Food Microbiology and contributes as an expert in several iOS working groups. Director of Microbiology APAC, Mirex NutriSciences, Dr. Stefano Colombo. Please welcome him on stage.
So, can you hear me right? Right, because I was having a echo from the back when I was sitting there. So first of all, good morning, everybody, and thanks for taking your time to be here. And let me heartily say thanks to the organization, not only for inviting me, but especially for everything they have been doing these days and nights at any time, especially those gentlemen at the bottom and everybody looking after the audio, the slides. They've been fantastic organization. Thank you very much on behalf of everybody, probably. So I'm supposed to tell you something about the new Listeria and the challenges in detection that they pose to the microbiology laboratories. As you have heard, Marine NutriSciences is a global network of laboratories, so we offer testing services to our clients across the globe. So we meet with Listeria multiple times in a day in multiple countries. When I was looking into the slides, which originally came from a work from my colleague, Catherine Carling. She's been in the US, and I have to say publicly thanks to Catherine for sharing the slides, the original slides. I was going to change the title, and the title was, What Do I Know About Listeria? Nothing. And then subtitle was, What Do I Know About Listeria monocytogenes? Even less than nothing, because it's so changing and so new that we will discover more about Listeria species and monocytogenes, not only as we go through the slides, but certainly in the next years. I'm supposed to use the pointer, and I hope I don't go wrong. That's the official cover, you know. The company says, yeah, you must use the logo. Okay. A very quick overview on the Listeria, key considerations, the challenge of the non-confirming results, which is the real core of the discussion today, and something about the so-called new Listeria species and the challenges they pose especially to their identification. Then more of a challenge is a question to the audience. Do we really need to confirm culturally every time today? In a time where everything is rushing, we're still relying on cultural confirmation. It takes days, and it's lengthy, and it's complicated, and it doesn't come to a clear identification, especially when we talk about Listerias nowadays. And the takeaways, hopefully there are some for any one of us. So, are you sure you have put up the latest slides? I'm talking to the people there because I sent the slides at 5 o'clock this morning. Normal. Okay, don't worry, we'll go on with these ones. Don't worry about it. Just one concept that I want to stress is that the discussion I'm doing and I'm sharing with you, because this is the experience coming from our benches. You know, it's really taken out of our laboratories and brought to you for food for thoughts, is that we should focus much more on Listeria species than on Listeria monocytogenes, and for the reasons that I'm going to highlight in my presentation. This is just a couple of slides about the importance of the environmental sampling to detect the presence of Listeria. I'm stating the obvious. You need to look for Listeria species eventually to suspect there is Listeria monocytogenes or Listeria monocytogenes-like organisms in your plant. From a food laboratory standpoint, we also look for Listeria species inside the laboratory to prevent contamination. But it's enough to say Listeria species. In a food plant, it's a bit more complex because they are exposed to a big variety of potential sources. Saying goes the same, little differences. Okay. Validation is a must. I think we all agree that if you want to apply a method and you want to rely, crossing fingers, on the performance of that method, it should be minimally validated. And I want to really stress the word minimally validated, because validation is just a starting point. However, we still have to be validated because we need to give legal validity to the results, right? So validation is a must in many different ways. So just to quote two, now there's Microval, there's AFNOR, AUAC performance test method, so AUAC-RI is the short name called for, and also the AUAC-OMA, which is in the next slides. You will see, when you think about all the matrices and all the possible different environment where Listeria can be harbored and stay and live very well for a very long time, and then you think of the validation scheme, it's only 20 plus 20 samples, high level, low level. It's very little, it's a very tiny window on the reality of the world of Listeria. So that's why we say, yes, validation is a must, but it's actually just a starting point for the discussion on Listeria detection. Not going to spend too much on this, but just think one thing. When we look at validations of method, and when they claim the method is validated on environmental samples, the way a validation is done is basically you take a tile or you take a little piece of steel or concrete, you paint some cultures of Listeria on, you let it dry, and then you recover it with a tool that is a swab or a sponge. But if you think within a food plant, the fact that you are swabbing floors or food contact surfaces, it's not like that piece of tile, it's not like that piece of concrete or plastic or steel. It's a much more complex world. There's no real comparison. We have the evidence that the system is recovering Listeria on those surfaces which are artificially contaminated, but the reality of the world is much tougher for us and for Listeria to be caught, to be captured, to be grown and become detectable on the plates or through an automated system. So I actually changed the slides this morning, but the point is when we think about the method, we need to select a method which is of course fit for purpose, so it must be validated for the environmental, but let's keep in mind, the higher the sophistication level goes in the method, the higher our own sophistication in the sense of fine understanding of the testing process with the risks, with the pros and the cons, has also to increase. Because PCR is very nice, it's very fast, it's simple to go, but the risk of contaminations are much higher than in classical cultural microbiology. So there must be a clear awareness that to that level of sophisticated methods, there's much more we need to learn to handle those methods in the most effective way, preventing cross-contamination by amplicons, which, when it happens, is a disaster because they are so volatile, they fill up your laboratory, and before you get rid of them, it takes weeks. When you have a listeria contamination, it doesn't fly, it stays there, you can catch it, you clean and sanitize, done. It doesn't stay in the air. Talking about sensitivity and specificity, of course, as you go through more evoluted technologies, it becomes much more specific. So the risk of false positive becomes a very rare event compared to previous technologies. However, the point is, I get more sensible, I can see very little numbers of listeria. It doesn't mean I can see them on the plate when I go to confirmation. And that's one of the major challenges. Besides the point of the new listeria and the identification problems, the point is there are so little people there, such a little quantity of listeria that the PCR sees it, but I'm not necessarily able to put it on the plate when I go to the classic cultural isolation and confirmation. Certainly, one of the things we have been facing in the laboratories is those positive, presumptive positive by PCR, which don't confirm, and the lab director gets desperate to say, I got a positive, I don't see the colonies, what do I do? What do I tell the customer? Is it presumptive? What is the customer going to do? Are they going to act upon a presumptive, or they want to see the little bug on the plate? And so this is really one of those difficult things. What everybody calls, free DNA. Free DNA should be the effect of often a very drastic production process, breaks the cells, free the DNA is there and it's captured by the PCR system. But it doesn't mean that those cells are alive, they're dead. But there's also another problem with the so-called free DNA. There are cells which are impaired, damaged, they're not viable, they may not respond to the system, or say the chemical reaction that we use nowadays to take the free DNA away. So you have a negative, but it doesn't mean that listeria is not there, even though you have cleaned up the potential presence of free DNA in your samples at the testing level. Today, there's basically, a still fashionable way of doing testing is real-time PCR, and some immunoenzymatic systems like the ELSA, like the ELISA, they're still pretty robust, right? So you can probably will see them around for another 10 years as the biomolecular methods continue their evolution. The freshest thing from the oven today is the so-called culture-free molecular methods. For the simplicity of the matrix, which is the environmental sample, basically it's like a metagenomic analysis. They call it quasi-metagenomic. They try to look for the specific DNA. You don't need an enrichment. If it is sensitive enough, you can see things there, but mind, we don't have the isolates. So we can come to a presumptive positive, but we don't have the isolates. So what? I still need to go back to the enrichment. For epidemiological reasons, I want to do maybe a WGS on the isolate. So we are in a gray zone where we want to go fully molecular, but at the same time, we still need the old school of having the bugs in the hands. Oh, one thing that also it's appropriate to consider, I want to set up my QC laboratory, or the testing laboratory needs to move to a new technology. One thing to consider is, of course, productivity, streamlining the process, being effective, rapid, responding to the customer expectations. I don't want to have two systems or two processes within one platform which are different for Listeria mono and Listeria species. So OnePlus is, for instance, looking for a protocol which encompasses both. So we want pre-enrichment, primary enrichment, or the only enrichment actually for PCR, I can get, we say, two birds with a stone. So there's one enrichment, and I can go out looking for Listeria species or Listeria mono. And that's an advantage, obviously, in terms of cost and in terms of operation and turnaround time. we set up a little template in the laboratories, when we want to evaluate method. I guess the slides will be distributed. This is just a very elementary example of how we try to classify the different methods, and then you can provide a ranking. It's free for use, of course, there's no copyright, and it's just a way to giving a score to the methods you are looking at and say, is the one I'm looking for, does it respond to my expectation? Does it respond to the customer expectation in terms of accuracy and turnaround time? And so you're able to give a sort of, good or bad or acceptable to the methods you're looking at, and that will help you select the methods that you want to deploy in the laboratory. Now, that's the hard stuff, the non-confirming, because the customer is waiting for the result. He's waiting. You can't simply say, this is a presumptive, it doesn't confirm. What does it mean it doesn't confirm? You are the laboratory, you're the expert, you got to tell me something. So I want to stress the point on the terminology, right? A presumptive positive, which doesn't confirm, is not a false positive until you prove the opposite. So when you have a positive PCR, considering the sensitivity, considering the specificity, the level of sophistication we mentioned before, you can't end up and just say, it doesn't confirm, it's negative. It's a false positive. No way. The laboratory must do the best in order to find if Listeria species or mono is there, you need to find it. In one way or the other, you need to pull it out and show it through your eyes before saying it's a false positive. Considering the method is validated, is fit for purpose, you also verify the method in your laboratory. There's a lot of studies, there's publication, this, that. It should be reliable, right? So before coming to saying it's a false positive, it's a long road. So there are true positive, actually. But maybe they don't confirm anyway. So this is one classic case, and I said it before. It's very sensitive, the method. It can see few cells, per se. They don't grow. They're unable to grow. They don't grow enough quick and fast to be within the method conditions, the cultural confirmation. You don't see them. Other flora may overgrow, and it's disturbing the growth of your target. And so what do you say? You're still there, and you have not resolved the point. You know very well that Listeria monocytogenes is never alone. It doesn't walk alone, sounds like a sort of a soccer rhythm. So there's always Listeria innocua, often Listeria innocua. There are other Listeria which are much faster growers, they overgrow, and so your mono stays there and become invisible to our eyes. Plus other classic gram-positive Bacillus enterococci, which can severely interfere with the growth and the detectability of Listeria in the plates. And of course, the non-viable. So it's a true positive, but those cells are not strong enough to grow. They've been damaged. So especially when you look at Listeria at the genus level confirmation, we're not talking about mono, but we're talking about the species. There's still a lot of subjectivity in the cultural method because you're looking at, those green bluish colonies, the aloha-like and the aloha media are very popular. We know there are interferent flora which can grow with a similar aspect. So there's still some human factor there that is playing in favor or against an accurate detection of Listeria on those plates. So you can try to isolate, re-isolate for 2-3 times, and then it gets a week and the customer is still waiting. And sometimes you're able, we have experienced sometimes 2 weeks of re-isolation until when those colonies popped up on the plates. You may not believe it, but it took 2 weeks before we got it. And we took it to prison. So the other day, one of my region laboratory called me and say, hey, we have a problem here because my PCR gave me a positive, and then when I isolate, I see green colonies, there's no halo. Did you run the hemolysis? Yes, it's hemolytic. There's no halo. No halo, nothing. Swirling motility. gram stain, classic, Coccobacilli. It's an atypical. But if the laboratory isn't aware enough that there are atypical colonies of rare but still possible, no halo Listeria monocytogenes, or sometimes even non-hemolytical Listeria monocytogenes, you lose it. Then the true positive becomes a false positive because we don't interpret those colonies correctly on the plates. That's the point I just mentioned about the monocytogenes, which can be atypical, and you will not catch it if you are not looking at the entire series of tests for confirmation. So let's start thinking, do I really need every time, not just because it's in the regulation, but because it's in the ISO standard, do I really need to go every time to cultural method when there are technologies which by far are more accurate and faster than the cultural confirmation? And I'm saying this, and I throw a stone in the pond saying ISO should be able to listen to the need of the food industries more than ever, because technologies allows much faster decision today, but we're still relying on the ISO, on the cultural method. Fine, but it's not enough. Yeah, the free NA, I think we already mentioned that. I just want to anticipate something. What happens? You have a suspect positive, you step back, you use some specific chemicals, it's like a dye, basically. It gets in, it stops the DNA from being multiplied, amplified. You rerun your sample, and you see that this time the screening is negative. However, some PCR manufacturing companies do recommend to continue confirmation even after DNA removal step, because you still might have some non-viable cells at that stage of your testing. The DNA dyeing or the DNA removal gets in, it gives you a false negative because you don't see the DNA, but those are still viable, just damaged. So the level of penetration of this dyeing, of these special chemicals, it's variable. Now, you know that when you get close to the 100% detection, it's an asymptotic curve. It gets closer and closer, but it never gets to the 100%, so it gets even more complex to find the real bad guys into the sample. So fine, this is helping. There are matrices like the dairy powders where Chronobacter is probably the best example. There's a lot of free DNA because it's a drastic thermal process to produce those powders, and Chronobacter is a common contaminant. Once you've taken the DNA away from your sample, then it becomes negative. That's true. We have seen it many, many times. So Listeria is not so easy. It's truly insidious. Let me go to the next one. Well, lab error. Nobody's perfect, right? And probably one of the most frequent lab error is the lab is contaminating the customer sample. To prevent this, there's quite a simple way to go. Now, even ISO, even if this has been out in the practices for the last 15 years or so, or even more, even ISO in 7218 has included the recommendation that laboratories should use unique strains. What does it mean? In our case, we use GFP-marked strains, so they are not only detectable in the enrichment, because a targeted PCR will find the GFP gene insertion at the enrichment level. So as you have a presumptive positive, you run that specific PCR, you can tell the customer, oh, sorry, we screwed the sample, we contaminated it, we need to start back again. Or you say, that's a presumptive positive, it's a wild contamination, we can go on. Even if you don't have a targeted PCR, those strains are UV positive, so take your plate, put it under a UV lamp, a classic 365 or 325 micrometers, that will fluoresce very strongly. If it's fluorescent, it is not a wild strain, it's your strain. You really contaminated the sample. And it's easy peasy to be done, and it protects the customer result very easily. When you handle strains, you contaminate your laboratories. Every laboratory should have a thorough, intense, accurate, well-targeted environmental monitoring plan to detect the possibility that what you have taken out of your sample has gone out to the surfaces, to the tools, the equipment, and then it's coming back in your process. So on the one hand, the detection of the control strain is easy. It's fluorescent. It responds to a specific PCR. But when you cross-contaminate between or among customer samples, that's a much harder task to be resolved. So you need to understand all the processes and control the processes, right? So that's another one of those errors that may make you suspect that that positive is not a real positive. Non-target, I think I have to say that, but it's truly a rare event when you look at the PCR. PCR is so specific, targeting unique pieces of the genomic sequences in the target organism that it's unthinkable. Let's not exclude it. Everything is possible in nature, but it's definitely a very rare event when you look at the accuracy of your PCR testing. Yeah, sometimes I've heard this, my plate was full of bacillus, I had a positive, and it's bacillus interfering. Are you sure of that? Yeah. Well, pick the colony. If you think the bacillus, which grows on the aloe and aloe-like, looking like an Ivanovi or a monocytogenes from time to time, you pick that, make a pure culture, put it back into the machine. If you really think it's interfering, it should give you one of the strongest positives you've ever seen in your life. And then it doesn't happen, so it's not there. It means that there is flora, it's interfering visually with your detection at the confirmation level, but there is monocytogenes or Listeria species somewhere in that sample. And you need to fight to find it. Well, technology issues, it means the platform is not working. There's something really wrong. It can be sometimes a mechanical problem, so bad reading of the tube in the PCR. It can be an issue with the kits. It's possible. High background noise. We have seen it. So you got very weak positive, and then you got nothing on the plate. That should ring a bell in the head, right? One thing is having a positive, and then you have flora. Something different is having a positive in a PCR, and then you go out and the plate is perfectly empty, crystal clear, like as you never streaked anything on it. Well, probably that's a key issue. There's a background noise which has gone up. You can't repair it. You have to call your provider. So you are a specialist of microbiology, but you're not necessarily a specialist of the equipment. So call your provider of the equipment as soon as you can to get it resolved. And try to think, is it on one test method? Is it on the kits? Is it across multiple laboratories using the same lot of kits? It's all about investigations. Now, you would say, okay, but where all this is about Listeria, but this is all about detecting Listeria and finding. And it's what we have faced or we are facing from time to time in the laboratory. So it's true experience that I'm trying to communicate to you. Now, the new Listerias, the so-called new Listerias, which really pose challenges at that point. Until last week, I thought there was like 20. No, actually there are, I can see that, 29 Listeria species. And I think you're familiar with the new sort of classification. It's two clades. Clades is like a branch in a tree. You think about the dendrograms. So 29 species. How many are they? 10 are for the sensu stricto. They are related to Listeria monocytogenes. The others are sensu lato. They relate to Listeria gray. You know that gray has always been slightly different from the other Listeria, even on the plates. It doesn't grow like any classic Listeria. It's standalone individual. So these two gray groups are those that now are challenging the detection system and the identification system. And by the way, if you look at the bottom of the slide, the taxonomic, so the systematic of Listeria is never finished. They are trying to arranging now new genuses, so we will see what comes up in the next 2026, 2027. Something that was Listeria before will disappear and will not be named anymore as Listeria, but something different. Now, at least 3 of them, like the Marthi, the Cossarzie, and the Swaminatani, are interfering with the cultural confirmation. And you would see those strange biochemical results and you would question the result. But we need to be aware that it could be that. The point is, in the existing biochemical test, there's nothing that tells you this could be Cossarti or Mazzi or the other one. So we need to question the result. Of course, if we can go biomolecular with a WGS or anything that is finer, we might be able to discriminate those strains, but that's not in the routine yet. So this is taking time and adding time for the customer that is waiting for the reply. This is just, I just want to remind that there are some innocua which are hemolytical. And if you think, just stop a second on the biochemical test, the galleries for listeria, there's in a couple of galleries, just one test which makes the difference. And then you look at the hemolysis. Now, you see that one test responds to innocua, and then is hemolytical. Sometimes one test doesn't match with monocytogenes, and it's not hemolytical. It's a great confusion under the sky, and it's possible, it's happening. So you don't know how you need to orientate your diagnostic at this point in time. It gets even more complex. Plus the fact that, as we said before, some Listeria mono are not providing halo or are not hemolytical. So this is just to remind what are the most common isolation that we question, monocytogenes, non-hemolytical, and then the other three that I mentioned, the sensu stricto that we happen to find in the samples. So just a couple of words, because I see 30 seconds left and I want to shorten it to the right end of it. It's not a provocation, but I think it's science-based. Why don't we have the possibility yet to use one PCR for screening and one PCR for confirmation? Two different PCRs targeting different sequences, which is one of the principles of the AFNOR validation. The confirmation method must be different in principle and in the mechanism of action from the screening method. With two PCRs, you'll be able to do it right away because they are specific, they're sensitive, you're working on something that is already positive. Of course, your second PCR can't be less sensitive than the first one, but that's the way we should go. And just to finish, I mentioned the quasi-metagenomics. Basically, this is the no-enrichment detection of Listeria. It's coming up. It's a metagenomics which is performed on the pre-enrichment, actually on the enrichment, the only one you have. But the point is, I don't have my isolate in my hands. So somebody would like to see it. Forensic, legal litigations. So you still need to get your isolate. That's fast. Because of the simplicity of the matrix, this has been validated already, but there will be experts speaking about it later this morning. It's on environmental samples. When you get into the food matrices, the pictures gets complicated. I'm at my takeaways. So select the method you need, but think about efficiency in the laboratories and accuracy of result. Validation is fine, but it doesn't give you the 100% assurance that you will be able to find every time Listeria species or Listeria monocytogenes. We said it's a starting point. Be careful with the non-confirming. We can't state it's false positive until when we really have the evidence. So we need to strive to get the Listerias out of that foggy area. And don't forget the new Listerias, which pose questions, especially on the biochemical confirmation. Hope it was not boring enough and that you enjoyed the discussion. And I'm happy to take any question if you have any. And despite the fact that confusion is big under the sun, as we say for Listeria nowadays. Thank you very much, ladies and gentlemen. Thank you. I have to leave the pointer otherwise. Any question? This gentleman had a question. I hope I can respond.
One reason to get a false positive is amplicon contamination.
I'm sorry,
That
gentlemen.
one of the most common reasons.
I can't hear you, I'm sorry.
You cannot hear me. one of the most common reasons to get a false positive is amplicon contamination in labs. I do not agree that we have a dead DNA problem when we are using enrichment. In order for dead DNA, for dead cells to give a signal, you have to have about 10 to the 5 per gram of the sample. Of that level of contamination, that does not happen. But amplicon contamination is very frequent. Next is that we need to have a culture for regulatory actions. So companies are not accepting that. What we have been doing, we talk to our clients when we use multiple molecular methods and we are getting signals and we cannot recover, we tell them that we cannot, it's molecularly confirmed, but culturally negative and it should not be released into the commerce. And so far they have been accepting that. So.
Thank you. I'm sorry, I really don't hear him, so I had to get close to this gentleman. Well, thanks for the point. I tend to overall agree, and I want to stress the point again about the regulatory. When you are an accredited laboratories, you have obligations in the way you report things. Then you can agree with the customer, the sense of what you report, that's another story. But there's still an obligation to report in one way or the other, unfortunately. As per the point he made about the DNA, I don't know. There's a whole industry that is working on the fact that there is detectable DNA. And I agree also on the fact that, as I stated at the beginning of the slides, PCR is wonderful, but the risk of cross-contamination of the amplicons is extremely high. Not free DNA, but certainly amplicons is a major risk. Thank you. That's why a laboratory should also look for amplicons in the environment as part of the environmental monitoring plan.
Thank you, Mr. Stefano. Our speaker has over 19 years of experience in food safety, specializing in molecular biology and data-driven microbiology, currently with Biomerex. He previously served as a senior microbiologist at the CDC Atlanta, holding a PhD in microbiology and veterinary medicine degree. He has published extensively, holds multiple patents, and advises international food safety organizations. Please welcome Dr. Vic Dutta. Thank you.
Thank you so much. Good morning, everyone. Can you hear me okay? All right. So, pleasure to be here. I am really glad to be listening to some of these ideas that we've been working on. I'm talking about on a broad perspective, and I'll get into that in a detail. But before that, I would like to thank the Dubai municipality and my dear friend Bobby Krishna for inviting me to this event. First time, and I'm very impressed with the crowd, the conversations, and I hear that this is an ongoing progression, so I look forward to where it goes from here. Here I am to give my piece of the contribution to the conference. So Bobby shared this title with me, Testing-Based Smarter, Faster, Accurate Decisions. Typically when I get a title, I tend to change them to fit my presentation. In this specific case, I decided to keep the title and fit my presentation to the title itself. And that was a challenge, and at the same time, an opportunity. And so what I'm trying to tell you is that throughout my presentation, my hope is for you to see not one technology, one idea, but a host of ideas, which is coming from our way of thinking about where the testing is going. I'm drawing upon the two words up here above my head, technology and innovation. And we are really trying to push the boundaries, and my hope is to be able to share some of those ideas with you. If some of those click with you along the way, please reach out to me. I'm happy to go into details. In other words, you will not see a detailed version of any one technology, but a host of ideas that I'm happy to debrief with you after the presentation. So testing, why do we test? My dear assistant AI helped me putting this slide, and I tend to agree with most of it. The bottom piece is my contribution to the slide, which is, does one size fits all? And I'm hoping to hang on to that thread throughout my presentation. How do we test? Sample collection, lab analysis, data, quality assurance integration, and then you look at the challenges, again, drawn by my assistant AI, and I tend to agree with most of them. But the part that I'm more interested in, because this is where we work, is the microbiology, lab analysis, data interpretation. That's where we spend majority of the time. So you'll see the rest of the presentation sort of through that lens, and I'm happy to, again, get into super details. This is another AI generator, and I promise this is the last slide. The classic answer, a microbiologist, anybody who's been to a school of medicine, you know, any question, the answer is, it depends. And this is sort of a cliche, but at the same time, fact. And we tend to live in that world. But having said that, you know, the complexity is not, complexity of a problem is not an excuse to not find a good solution. And that is where we're headed. So how do we think about problems at bMRU? It has to be comprehensive and very simple. Start with the why, grounded in the problem, science and data. The what is working and what is not working. You heard Stefano talk about the traditional methods, the PCRs, and a lot of the challenges that we already know exist. So, but at the same time, we can't just walk away from them, right? Because there's a lot of good things that come from these old technologies. And when I say old, I mean they're still working, right? So they're not irrelevant. So there are a lot of things that are working, and there are a lot of things that we can improve upon. And that's where we tend to focus our energy on. The how. Roadmap, the progress with focus on easy pickings first. There's a lot of opportunity in the world of microbiology diagnostics, and we are going with the bottom-up approach, going with the simple problems first. So let me start with protecting public health, again from the lens of microbiology and data challenges. So as the system exists today, there's some version of that, right? It's not absolute everywhere. We are here in Dubai. I heard the presentation this morning. They tend to be doing similar things. So it's mostly hazard-based and not risk-based. And we talk about risk interpretation and risk assessment, risk management, precisely because we are spending too much time in hazard-based testing. Process control data, which is the data that we are sort of already collecting around quality control indicators and so on and so forth. There's a lot of data there, but we're not utilizing it well, our approach. Indicators are based on prior microbiology knowledge. I'll get into that later in details. Data integrity remains a pain point. I've heard multiple times here and elsewhere. Just collecting the data and universalizing, you know, how we're collecting the data is a pain, let alone, you know, the integrity itself. And then the use of WGS remains contentious. This is been a boon for public health agencies, and technologically very exciting, you know, gold standard, best of the best. But we have also seen there's a lot of issues as far as adoption of WGS is concerned. So we have to think past that, our viewpoint. What does the future could look like? And I'll give you some examples. Risk-based testing could also, it could be a tiered testing, could be a risk-based testing, right? I'll show you an example what I mean by that. Indicators that can actually provide a better indication. We have kind of forgotten as microbiologists, we are always looking for indicators without realizing what are we looking for in terms of indication. Adaptive sampling is something we have developed in partnership with the industry. I'll show you a couple of examples, how we are keeping it nimble and creating risk-based decision-making. And then there are non-WGS typing technologies that are evolving. I'm sharing one here that we have developed, but there's a bunch of other technologies that have already come out in the marketplace. So you can do typing without WGS. In this specific case, I'm referring to GeneUp Typer. If you're interested, you can take a look at through the QR code. Okay. So this is the tiered testing, risk-based testing. So everything Stefano mentioned in the previous presentation, I would put that in the pathogen screening, the step number 1, which is we have a listeria, we have a salmonella, and we are looking for it, and that testing is not going anywhere. Now, we have heard multiple times you cannot test your way to food safety, but at the same time, the testing is here to stay. And so the question is, how do we make that more efficient? And I'll share that in a minute. And then the second piece to that is surveillance, which is, I'll give you an example. The quantification of salmonella in the US has emerged as a sort of way of doing the second tier testing in terms of quantification and providing some layered approach there. And then, of course, a root cause analysis, which is typically done by WGS, can also be expanded through other technologies. So 1, 2, and 3 can happen quite rapidly in the labs today. And of course, data integration and risk assessment tool, as we have heard a bazillion times, garbage in, garbage out. So the kind of quality of data that we are collecting will impact the kind of risk assessment tools that we can build. But at the end of the day, it's not just one thing. It is a combination of ideas that have to come together, the 360 view of addressing our issues with salmonella and listeria is what we believe where we should be going. Now here's an example of adaptive sampling. I think we can all appreciate that the rigor and the amount of sampling that happens in the processing plants is not always needed or not well understood. If we are sampling a certain location, we tend to fall into the classic buckets of we've been doing it for a while without realizing what is the larger context, what is the larger impact. And so we have taken on the idea of layering a risk scoring on top of the sampling procedures. And here's a couple of results as a result of our work with the customers. On the left side, you're looking at a frozen food company. And looking at their optimized sampling data plan allowed us them to do early detection on listeria in factory by 35 days on average. On the right-hand side, we've done a similar approach of adaptive sampling where we are looking at the percent improvement, which is the y-axis, against the number of tests. The curve that you see is the ideal curve based on what the simulations. And you'll see orange data point, which is the actual data point that the company is using. And I think we can all agree that there is a diminishing returns to if you keep sampling more and more, the amount of improvement you'll get. And so based on data simulations and some of the work that we have done in partnership with the companies, we were able to figure out about 17% improvement. It's a very specific example, but nonetheless, it highlights the adaptive sampling is one way to improve the overall microbiological testing, even though it's not in the lab. Okay, so ensuring quality and consistency. We hear from our customers all the time that they're flying blind. What I mean by that is what I said a minute ago, good indicator testing is not leading to better indication, and it is causing bigger economic implications for our customers. I'm talking about past food safety, and that spills into the raw material, ingredients, risk profiles. The food safety takes all the focus in the lab. Again, going back to this morning, and from experience working with my colleagues, we've all seen food safety takes the bulk of the conversation. The spoilage and the metagenomics and some of these other quality issues take a backseat as a result of it. And we feel that there's a bigger opportunity here to serve our customers from a holistic standpoint. And the reason I say that is because, again, this morning I heard that they're running out of resources here in Dubai municipality because of novel foods, and the bulk of samples are coming in the volumes, and they don't have enough people. So there's the efficiency to be gained on the food safety side. But if you are efficient there, you're probably able to maintain the shelf life and increase the economic implication of some of these products. And the last piece is classic microbiology is not enough. All methods are designed for monocultures And this is, I can't say this enough, it's a revelation for myself, having worked for 2 decades in microbiology. Every method that we work on today is, you're looking for that one needle in a haystack. You're trying to pull that one organism out by enrichment, by concentration, by whatever methods. And we feel that there's a whole lot more in that hay than to just go after that single organism. And it's biasing our approach towards especially quality testing. I don't have specific examples here to share with you, but that first bullet point, we are working with the industry hand in glove to find better indicators. And to our surprise, they're not always microbiology indicators, but since we're talking microbiology, I can tell you that, and this is just a simple sort of thing that we have run into. We know that the Salmonella and E. coli genomes are widely shared. They're cousins in sort of genomically speaking. And so we know that there is a lot of genes that are shared between the two organisms. And it is not impossible, this is our hypothesis, we haven't proven it yet, to find that one gene that would allow you to detect both of them and therefore provide, so you're not necessarily going after Salmonella, but you're also not necessarily going after E. coli. And that is a gene that could serve as an indicator for the presence of Salmonella. Very simplistic idea. There's other approaches to doing something like that as well, and we're exploring those right now. I don't have a result, but this is just an idea. Metagenomics-based microbiome and risk assessment tools. Metagenomics is a great idea. It's been an academic idea. It has not really taken root on a routine basis, and that is the problem we are trying to fix. I'll give you an example in a minute. And then the better EM tools. I think there's a lot of products like this. EnviroMap, for example, is a software that does sort of a mapping of your plant and then gives you an overlay of your sampling plans and then the detection of E. coli, Listeria, and so on and so forth. But again, improving overall environmental monitoring using EM tools is one opportunity. So here's what I was talking about, metagenomics, the work that we've been doing. We've acquired a company named NeoProspecta in Brazil, and we acquired them recently because this is the only company that we know that has taken metagenomics and actually made it viable, commercially viable, but also viable for the labs. From the result standpoint, it actually makes sense. What does that look like? You're doing metagenomics, which is, you've heard multiple times. I heard John Donahue talk about it from Nestle yesterday, and then Stefano mentioned quasi-metagenomics. You are doing a sequencing of entire microbiome, and then there's a black box there, which is very smart bioinformaticians and softwares. Again, we've simplified the whole process for you to see the actionable results. Let me get into details. What does that look like? So we are starting with understanding the microbiome, the distribution of organisms. And the idea is, I'll give you one thought. You have a spoiled product, and then you have a normal product. What does the microbiome between the two look like? Is there something to be learned there? Is there one organism or a group of organisms that could serve as an indicator? And that is what we are sort of trying to assess through this service, what we call it NeoBiome. And then not only just that, we are then able to take that information and overlay onto your plant, again, through similar ideas like EnviroMaps and whatnot. And the idea is to be able to monitor before and after. Are you seeing a difference as a result of this testing? And that is something we are able to now make it available to our customers. And this is the part which is my favorite as it relates to metagenomics. You can read a lot of papers on metagenomics around profiles of organisms, and it just gets jarring to like, okay, what are we getting out of it? This tool makes it practical. What this tool is, it's bringing functional genomics to life, a topic that is very near and dear to my heart. The idea here is you're connecting certain organisms to a phenotype which is meaningful to the food industry. Let's talk about biofilms. If you can detect certain organisms that have shown to make biofilms, and then you tend to detect them in our NeoBiome approach, then based on the literature available, we have created this tool that will allow you to then be able to say, there is a risk profile here, okay? Now, the problem is the literature is not exhaustive enough, right? But we're starting with what we have. And so the idea is to be able to provide some simpler indication from all this complex analysis for you to make decisions on a real-time basis. I can tell you I was skeptic at first when I first saw this because, again, data is not enough. There's not enough out there. But our customers are using it. And they're using it for sanitation, for shelf life, and hygiene. And you know what they tell us? This is the best we have. So let's go with what we have. And that's good enough for us. Now, having said that, this is an ongoing exercise, and we need to keep working at it to make sure that we can get to a place where we are comfortable. But for now, we have taken a stab through the neo-risk. Compliance and regulations. We do not think that lab testing is independent of the ecosystem that it operates in. And compliance and regulations is very much sort of important to that ecosystem. And so what does that look like today? Doing more is not doing good. Testing data is typically collected in the public health facilities and the industry, and then they tend to go head to head, and then there's sort of a resource scare on the industry side, there's a resource scare on the public health lab side, and above all, it's causing, it has caused and is continuing to add to the trust deficit between the public health agencies and the industry. And overall, what this leads to, and I can tell you from the US standpoint, the progress is stifled. This is all when organisms are not pausing. They're continuing to evolve, they're continuing to make our lives difficult, hence the constant recalls and outbreaks. So we, just like they're nimble in their sort of lifestyle, I think we need we think, and I agree with that, need to keep up with that as well. So what could this look like? Few ideas here. Sharing the testing burden. More than 90% of samples, most of the places, overwhelming number of samples tend to be negative, because if they're not, we don't have an efficient food production system. Why not release them faster? That gives us, the technology company, incentive to develop technologies that will allow you to do a quicker release of negative samples. So let's just say we take the bulk of the negatives out, make them quick so the industry can also benefit from it. And then how do we go about it? We recommend to rely on third-party labs or independent labs that could be closely monitored by the public health agencies to do this quick work. You can almost think of like a satellite labs that are clearing up samples, releasing the negatives faster. And then every time they see a positive, raise the flag, send it to the public health lab, and this is where the focus becomes more on a problem in hand. What I mean by that is, one of the reasons we found WGS is not adopted well across the industry is the cumbersome nature of it, right? The expertise that it required to run that thing. But if you concentrate the amount of work that needs to be done on WGS in public health labs, like in this case for the positive samples, you are making it more, you're connecting the cause and the effect, right? And then there's additional technologies that we are currently developing, which I'm not going to talk about today, allows the in-depth characterization of positive samples that is not just WGS, but beyond. And taking that to the industry, we have a very hard time convincing anyone to adopt those technologies. So our incentive is also sort of goes down to develop these technologies. But if we focus the positive sample characterization in public health labs, we could incentivize us as technology companies, the government, to dig deeper into issues that actually require public health assets, and then it releases and it frees up the industry from doing what they do best, right? And the last one is more US-based, but I think it does carry weight elsewhere, is more carrots, and what I mean by that is that trust deficit has to be filled up. The public health labs, as well as the industry, they need to come together to really solve the problem at hand. And that could happen more through incentivization than tend to be more punitive today. Not everywhere, but tend to be. And the last one is facilitating market access and trade. This is, we have seen sort of going upstream from the lab testing to what is the impact it is having on our customers. And I'm listing a few things that our customers have told us. No golden rule to assessing the efficacy of the testing plan. They don't know what the supply trends are when it relates to historical commodity and peer analyte. How's one company doing versus the other? And the gaps in the risk anticipation through cause and effect. We know climate change and geopolitics and many other factors are changing how the supplies are moving across the world. And so having a visibility, a wider industry-wide visibility is something our customers have asked for it. And auditing tries to provide some reprieve, but it's always a band-aid when it's done well. So in order to overcome that challenge, or we're trying, we have launched a program called Trusted Third Party. And the idea here is, on the picture you can see, we are taking the publicly available data, consolidating testing data, and then mixing it with our partners. And you can see the partners here. This list has now grown almost double. And the idea is we are pooling the data in an ecosystem which is confidential, secured, and the idea is to neutralize the sort of source of the data, but really try to understand what we can from the data as it's available. Leading to informed decision-making, strength risk management for food safety, improved supply chain transparency, and promotion of higher safety quality standards across the industry. These are all the sort of bullet points our customers have told us. So this is already going on for a year or so, and we are very happy with the progress so far. So, smarter, faster, accurate decision. Does one size fit all? The answer is obviously no. So we're leaving with the same answer. It all depends. These are the low-hanging fruits or the buttons that we are trying to push right now to fix the find solutions and trying to be more systems-oriented, more risk-based, and then try not to be myopic in our vision towards the future. So with that, I will finish my presentation. Happy to take any questions. Thank you. Okay. Thank you again.
Thank you, Mr. Vic. A marketing campaign manager, EMEA, for Biorat's Food Science Division, based in France, with a PhD in public health and molecular biology and over 8 years of field experience. He bridges science and strategy to promote innovative microbiological testing solutions. Passionate about science communication, he drives initiatives that connect research, technology, and industry to advance food safety and laboratory efficiency. Please welcome Dr. Victor Bandeli and alongside him, Ms. Matilda Formulas.
Thank you. I will just introduce me very quickly before we start. So I'm Mathilde Fournials. I'm the Channel Sales Manager for the Food Science Division at Biorat, and I'm covering a territory that is quite large, Middle East, Turkey, and Africa, as well as Pakistan. So I hold an engineering degree in biochemistry as well as an MBA. So we'll start today. Actually, I'm very happy to be here again, I should say. And I really thank Bobby for inviting Biorat to speak again this year. We have been speaking for the past several years here, and I'm really happy to see that there is more and more people attending the conference with a lot of different presentation, technical presentation, with really great subjects that are treated. So today we'll talk about Salmonella particularly, Just to change a little bit from Listeria, Salmonella is also an important pathogen to be taken care of. Well, Salmonella is actually composed of 3 different species. The main represented one would be Salmonella enteritica, with 6 different subspecies. Something that when we were preparing the presentation, we discovered, and we didn't really know, is that actually 100 millions of years ago, Salmonella was not Salmonella, it was E. coli, and it evolved, matured, transformed during the years, and actually become what Salmonella is today. Where can we find Salmonella? Well, everywhere, it's just ubiquitous. And it's very clever. It can host very different type of organism. Actually, Salmonella is composed of more than 2,500 serovars. Some of them prefer humans, some others like animals, and some are very open, actually. I think it's a trend today, maybe. But they can actually be cross-species. How does the contamination work? Well, human can be contaminated from the meat that will be consumed. That is coming directly from the animal contaminated. But it can also come from the water, the irrigation water that has been used to produce vegetables or fruits. It can also come from the utensils that are used to prepare ready-to-eat food. And of course, it can come from the feces of the contaminated animals. The food associated with Salmonella outbreak were the first, according to our research, the first food associated with Salmonella would be the poultry, then would come the eggs, and in 3rd position, a growing trend is with the vegetables, the produce. In fact, we have more and more healthy habits. We eat more and more raw and uncooked food, particularly produce, fruits, as well as vegetables. And ready to eat, they are sometimes pre-cut, and the risk of getting Salmonella from those are quite high. Of course, we live today in a global world with more and more large-scale agricultural practices. It also increases the risk. And the last point is that Salmonella is also still very clever, still evolving, and we found out that the persistence of Salmonella in water is actually increasing. Did you know that it could stay for 30 days in natural water, 120 days in cold water, and more than 5 years in a lab environment? It's very strong. And actually, the transmission of Salmonella in the environment is very interesting to look at. It's a closed system, and water natural resources really behave as a reservoir. So let's say that the animals would be contaminated, then the feces would come to the soil would actually bring the Salmonella into the reservoir, into the natural sources. Those natural water will be used for irrigation, and there we go again. We will contaminate the farms, the produce, the animals, and of course, at the end of the chain, human. So it's very important to consider. I went a little bit too quick here. It's very important to consider water as being an important source of Salmonella SPP transmission. If we look at the checklist in Europe or in the US of water testing, you wouldn't find very often Salmonella. But if you look at Africa or, well, the Middle East, we can really see that Salmonella is becoming more and more important in water. Actually, water is the new gold. So maybe this is really something that we should look into. Let's look a little bit of the epidemiology now. So Middle East and North Africa. It's interesting to see that there is a rising trend for the non-typhoid Salmonella. The prevalence is actually above 6.5%, with the highest representation in Morocco, Second place is in Tunisia, and the third place would be in Sudan. Interestingly also, there is a seasonality behind Salmonella. In Lebanon, for instance, there is a peak in the summer, and in Saudi Arabia, during Hajj season, there is also a big peak of prevalence of Salmonella. From the US, well, a report from CDC shows that more than 400 deaths, 420 to be specific, per year could be caused by Salmonella contamination. Salmonella is becoming, well, the non-typhoid Salmonella is becoming more and more antibiotic resistant, which is another concern and another increasing risk of getting Salmonella contamination. If we want to mention a couple of outbreaks, I wanted to highlight the one that actually didn't really originated from the US, but was a global outbreak and linked to a chocolate distributed globally. Also, as we talked about water earlier in the presentation, I just wanted to highlight the fact that there was a study about that considered 30 years, and during that study, 15 waterborne outbreaks were caused by Salmonella. And the last one would be the one on cucumbers. Maybe you heard about it. It was in June 2024, and there the growers used irrigation water that was untreated. Now, looking at Europe, well, salmonellosis is the second most common zoonotic disease, and Listeria is not the first one, actually. In this study, the first one that was reported was Campylobacter. Maybe Listeria is more deadly. But yeah, the second position comes with Salmonella. And what we see here is that the number of cases for the whole Europe reported each year would be around 45,000. But this is only the tip of the iceberg. In fact, that represents only 0.05% of the estimation of what the reality is. So the conclusion here is that we may not test enough for Salmonella, and we might need to have more techniques that are faster and maybe more performant. And my colleague Victor will describe a couple of those that have been developed by Bayer that are already on the market or are coming into it. Thank you.
Assalamu alaikum. So now I will continue to talk about the food and water detection methods, so evolution and revolution. So as you know, we can start by the common one, which is the standard references, which is regulatory compliance. It's a heavy workflow. We have a plating, we have multiple tests. We need enrichment, and time to result, it can be up to 5 days. So we have another kind of detection method, which is the chromogenic media. So the chromogenic media, it's an alternative method. The workflow, it's more plating, and then after we have like a visual interpretation. We need enrichment, and time to result, it's up to 48 hours. The third detection method, which is a real-time PCR, and the real-time PCR, it's an alternative method, easy workflow. It's divided in 2 steps, extraction and amplification. We need enrichment, and we have time to result is faster, so 24 hours. And the last one, and not the least, it's more, I'm going more and more in the evolution and revolution. So ddPCR, which is a medium workflow, which we will divide our sample into droplets, and we do the amplification on each droplet. I will go on through the workflow in my presentation. And here's the important point, that we don't need any enrichment. So it's enrichment-free workflow, and time to result can be in a few hours. So if I want to compare these different detection methods, so we can see the time to result, which changing between 5 days for the standard reference method, up to 24 hours for PCR and few hours for ddPCR. And sensibility, of course, we are more and more in sensibility. We are going for the PCR and the ddPCR. So now I will focalize a little bit on the PCR in food and water for Salmonella, and we will talk also about the ddPCR for Salmonella. So since 1988, so a few years after the first publication of Millis for the PCR, Bio-Rad developed and put in the market the first thermocycler, which is the PTC 100, and it changed, and now we have this FX Opus. So we have more than 35 years of experience in the field on the PCR, and on 1998 we had the first validation, AFNOR validation for PCR kits for Salmonella, and this kit was the evolution come, and we have IQ-Check PCR kits for food, which is a ready-to-use region. We have a common extraction workflow because we target different pathogen in the field, and no false positive, because when we talk about PCR, we talk about a specific gene, so we are targeting specific genes for this bacteria. So it means no false positive and no false negative also, because we have internal control, which is very important in our method. So the internal control will prove that we will not have any false negative and our amplification go well. So the workflow, it will be extraction, preparation of the mixed PCR, and go for amplification. And in the evolution of this kit, we launched a few months ago, the EasyCheck kit, which is divided in two parts. Now we have the EasyCheck lysis kit, which is a common kit, lysis kit for different pathogens, and the EasyCheck detection kit, which will be for Salmonella and Listeria and others. So what is the key advantage of this? It's the pre-dispensed regions. And so for the workflow, we have only 2 pipetting steps because all the regions are pre-dispensed, even also the mixed PCR, which is lyophilized. And of course, we keep the common extraction workflow and no false positive and no false negative. So here in the PCR in food, we have a fast time to result, which is 24 hours. So now we will go for the PCR in water and for Salmonella with Matthew.
Yeah, thank you, Victor. We wanted to show you what we recently did at our R&D level regarding detection of Salmonella in water. We wanted to evaluate the capacity of our IQ-Check Salmonella toolkit to detect Salmonella in particular river and pond water samples. So we established 2 different methods, one with a filtration step to start with, and the filter then is going to be put into, or added to the broth. Actually, the broth considered is buffer peptone water plus, which is a particular grade developed at Bio-Rad that is particularly nutritious, with a cocktail of antibiotic, and I will not disclose the formula here. And anyway, it has not particularly been shared with us. Then we go for an incubation of 16 hours at 37 degrees. The second method is very similar. We do not have filtration step at the beginning, and the broth is double concentrated. So it's still buffer peptone water plus, but double concentrated. So, what were the results obtained? We were pretty happy of what we obtained. Actually, I didn't mention it, but just referring to Dr. Colombo's presentation that talked about the molecular solutions, we are here, when we consider our IQ-Check Salmonella kit, we used what we call the free DNA removal solution, which is a specific product that we use at Bio-Rad. It's an enzyme, a nuclease that is actually used to remove or to mitigate the risk of having dead cells detected. And so, as you can see, we compared that molecular method with the ISO 19250, and actually the results were really good. So the negative result became negative, and the 7 positive samples were actually detected positive, both with the ISO and with the IQ check method. And for both different methods, so the one with the filtration step at the beginning and the other one just where we put the water directly into the broth. So in conclusion, we do have 2 methods that can be used for filterable and non-filterable water. The IQ Check kit is actually a very useful solution for routine water monitoring, but also in case of outbreak where it can be used as a screening method. Of course, we do recommend to still confirm using actually XLD and rapid salmonella, which is chromogenic media by Bio-Rad, after regrowth on RVS. I will let then Victor guide you through another experiment that was done at Bio-Rad R&D.
I will take the mic, it will be easy. So we will talk about now the droplet digital PCR. So what is a droplet digital PCR? We can imagine that we have our sample, and this sample contains 6 positive or 6 target pathogen that we are searching for. So this sample, we will divide it in a small droplet, in an oil droplet. And in this case, we will go and do the PCR in each droplet and then count the droplet positive and droplet negative. So this method, it's a free enriched step. So we don't enrich because we're going to have like a quantification absolute. So we will prepare our sample, and then we go, as you see, with the droplet generator, we will divide the sample in a small droplets, and then we go and do the amplification of the sample in each droplet with the CFX opus, and then we will read droplet by droplet, each positive and negative, and we will have the interpretation. So here I would like to show, it's a poster was shown at the AFP in USA. So it's an evaluate of an enrichment-free workflow was using a PatoTrack, which is a next generation extraction, plus the ddPCR for rapid, accurate salmonella quantification. So what was the method? We tested different multiply poultry matrices. We inoculate with salmonella, and then we did a separation and concentration of the bacteria with the NGE, so next generation extraction with PatoTrack. So the matrix, it will be put in a buffer, and then there's a pressure and like filtration, and we will concentrate the bacteria, and then we will go and mix with a mixed PCR. So we test on extracted and no extracted bacteria after the concentration. So when we do the ddPCR, we will put it in small droplets, and we will do the amplification, and then we will count positive and negative, and we will have the result directly without enrichment. And so the key result that we found that the whole cells ddPCR detected was 3 to 4 times more than the extracted DNA. We have a strong correlation with theoretical inoculation, and we the recovery rate were similar to the standard method, demonstrating the reliability and robustness of the workflow, and it's comparable to plating. So in the summary, 96 sample processed in 6 hours. We are able to do it, which is the faster till now in the market, and it's without enrichment. And it's we reduce inhibition, and we have more robustness. So in the summary of this presentation, we know that we have like underestimated Salmonella SPP testing. So we are able to go on a traditional method, which is reliable but slow. And but we are also have like the next generation, which is a molecular method, PCR and ddPCR, which can have a rapid, sensitive, and also with the ddPCR, absolute quantitative without enrichment. So Biorad has a solution for food, water, for Salmonella and other pathogens. And so we can provide you a full solution from enrichment to the confirmation, passing by the PCR, chromogenic media, automation, ddPCR. And remember that we provide solution and not just the products. Thank you for your attention. And I don't know if you have any question. Thank you. No. Thank you. Oh, okay.
I don't know if you can go back to the slide where the very last one, where you compare the chicken and the sample and the dPCR. Can you go back and just show it? Because
can I have access, please, to the presentation again?
we had your 325 grams chicken and the 1 to 50 CFU, just to understand, and just spend a couple of minutes if they can. Otherwise, we can speak later.
It's not a comparison. We did a comparison. The most important, the aim of this poster, it was to show that we are able to quantify easily with a free enrichment, without enrichment, quantify, and in 6 hours. But during the method, we saw that we was wondering if we extract or we don't extract, if we have the same result or not, and which is a better, and we found that it's best without extraction, which we will encapsulate the bacteria and do the job of amplification on each droplet, which contain one bacteria. Any, oh.
Hello. Is it possible to detect the heat stress salmonella, especially in low moisture foods, using this technology? Heat stress cells of salmonella.
What is? I didn't understand. What is it? Sorry.
Heat stress means.
Okay, so in ours, when we do the job, it's always that we try to be at the similar on a wheel in the field. So it means that we stressed our bacteria when we go for the technical part. So our bacteria inoculated was not a fresh colony here. It's really stressed, under stressed. So to be comparing with the field, like when you have any contaminated food in the market. Is it?
But the dormant cells that are in the inactive stage, is it in low counts, is it possible to detect?
So we can talk after if you want, because to understand better what you want to, only if I advance. Oh, okay. So I don't have a lot of information about this kind of bacteria. So in this study, But we can talk after if you want. We can share what we did as stress and other things on our testing, inoculation.
Okay, thank you.
It will be better.
Yeah.
We are in the R12, if you want, in the booth, or now after we can talk. With pleasure.
The articles that we presented are available. It's public information, so if anybody would be interested, just come to the booth that we have with our partner in the UAE, Zarawi Group. It's R12. Thank you, and see you there.
Sorry. The system for the PCR also can detect it for the dead cells?
Yeah, very, very good question. So maybe I can handle that one. So when we did the test actually with the salmonella in water, I mentioned that we used the free DNA removal solution. This is a particular product that Bio-Rad developed mainly for Legionella testing. I heard some discussions also before. When we work with food samples, with food matrices, usually we have an enrichment step, right? This is, as we follow ISO or AOAC. During the enrichment, we don't have the ability to revid bacteria that are dead. So this is definitely a way for us to make sure that when we do our PCR, we do not detect dead cells. Bio-Rad has been in the PCR world for many, many years, as Victor explained in the history line. And we just used the free DNA removal solution recently. As I said, we introduced it for Legionella testing. Why? Because with Legionella, there is absolutely no enrichment. We are in water matrices there. We use filtration, and as we filter, of course, we have bacteria that can be opened, that are charged negatively and positively, and they create agglomerates. So whenever you filter, then you have a risk of retaining the agglomerates of dead cells. And that's why we put that particular product into the market. And we managed to have our validation on, AFNOR validation on Legionella IQ check testing. Once we've done that, which was a couple of years ago, we found out that it could be also useful for food matrices when it comes to products that are very sensible, that have been preheated, for instance, ready to eat, or processed food, or maybe swabs. So the free DNA removal solution in Bio-Rad portfolio would really be used only for samples that have been through particular stress, so where the bacteria have been stressed, and that can contain high level of dead cells. I don't know if I answered your question. Thank you.
Thank you. She joined Neogen's professional services team in April 2024 to provide technical support across the Middle East and Africa, focusing on driving operational excellence for customers. With over 12 years of experience in commercial laboratories, including a role as Group Quality Manager at Eurofins UK. She brings deep expertise in food and water microbiology, food chemistry, and the implementation of new analytical systems and process standardization. Please welcome Michelle Clemens.
Okay, great. Hi, everyone. It's nice to be back at TIFSC and seeing the same people that I saw last year. I think I was in the same group as you last year as well. Okay, so I'm going back to Listeria. I'm basically here to introduce Listeria right now, which is a product that Neogen have had in our portfolio for a number of years, but we've had it on a different platform. We've moved it to a new platform. It's not really used that much in this region. I don't think many of our customers in this region are familiar with it. So this is essentially an opportunity to relaunch that. But I also do want to focus on the empowering faster decisions. So why is a product such as Listeria right now necessary in the first place? And why does it matter to the decision-making process, or why does that decision-making process matter? So starting with things like the annual epidemiological report for 2023 for Listeria, in the EU and EEA, number of confirmed listeriosis cases reported per year is increasing. If we move to the US, we see that, well, we haven't got the same upwards trend officially, but we haven't got a decrease either. We've got maintaining stability against the federal goal baseline. So as a couple of our earlier speakers mentioned, these are not definitive numbers. These are only going to be invasive listeriosis cases where hospitalization is necessary, usually. So it won't be things like the food contact or mild cases which don't involve hospitalization. They won't be included in these numbers. So the overall total burden is higher. But nevertheless, it shows that everything that we're already doing in our facilities to try and control listeria, to try and prevent it getting in, to try and get rid of it, we are not necessarily winning. So we're managing to contain listeria rather than realistically reduce the risk from it. And that's for a number of reasons. Listeria remains a concern for us for many reasons. And first up is that nature of listeria. It is ubiquitous. We find it everywhere. Air, soil, water, plants, animal material. We'll find it in our retail environment. We do occasionally find it in our laboratory and production environments. And it is resilient. So we know that it can grow quite happily, albeit slowly, from about -2 up to about 45 degrees. It can survive in products with high salinity, in products with low water activity. So it's a nice, resilient organism. Whole genome sequencing and everything's been mentioned this morning a couple of times, but our detection and surveillance, the way we look at outbreaks, the way we look for listeria, that's all changed over the years. So we do more environmental sampling now than we ever did, and we've got developments in things like whole genome sequencing, so when we do get cases of listeriosis, they can be linked more easily, and we are looking for it more often. So some of our trends that we see are not necessarily because there's more listeria out there, but just because we are looking for it more frequently. We're finding it because we're looking for it, and we're able to link cases together. This is the one that I'm most interested in, is our consumer patterns, because as humans, I think we are a bit naturally lazy. We like convenience. So we've got that increased preference for the ready-to-eat and processed foods. And it's in these foods that Listeria monocytogenes can pose a unique threat. So if you take a look at the type of products that have been recalled this year due to Listeria, we're looking at things like pre-cooked pasta meals, sandwiches, beef pepperoni, roast beef. So these types of foods typically fall under those ready-to-eat or processed foods. And for those of you who worked in the UK in 2018, you'll remember all the drama around frozen vegetables in 2018. Environment and handling, we've made changes there as well. So changes in climate, changes in the amount of rainfall, in extreme weather events, all of those don't necessarily add to the number of cases of listeriosis or the prevalence of listeria, but it can change where we find it. So we end up with some surprises in our food chain. And I know I've spoken to customers previously where we go, but we've never had listeria in this product before. Well, no, but if you're using a new supplier, you're using a supplier from a different country, those changes in agriculture can be significant for some producers, some manufacturers. And also our supply chain. So with our ready-to-eat products that we mentioned, listeria is quite a unique risk in those. There's no final kill step with our ready-to-eat products. So if we have listeria in our environment and we introduce it during slicing or packaging or even storage, then it will survive. And yes, it will grow slowly at refrigeration temperatures, but some of our ready-to-eat products all our processed foods have got really long shelf lives on them. So that allows Listeria ample opportunity to grow up to those harmful levels. And because our supply chains have now expanded, they are broader, they are longer than they were previously, that allows Listeria that opportunity to grow up to those harmful levels, even if our per unit contamination remains the same. And last on my list is obviously our target population. So Listeria disproportionately affects immunocompromised people, the elderly, pregnant women, etc. So again, even a tiny increase in the amount of exposure could have some quite significant effects. So if we look at prevalence of listeriosis against, problems that we've had associated with Salmonella or E. coli, yeah, occurrences are less frequent. Cases of listeriosis are far lower than they are than for Salmonella or E. coli, but listeriosis remains one of the gives us one of the highest fatality rates in Europe, just because, well, partly because of its target population. And while this may not be as big a concern for this region at the moment, because the elderly population hasn't grown to the extent that it has in Europe, where I think we're just over 21% of people in Europe are over age 65, which we don't have in this region yet, but it's potentially coming. So Listeria could be a bigger threat to us in this region in future. And we know that Listeria is still a concern, and we know it's on everybody's radars because we've got these things like the new EU regulations that become enforceable next year. So, for example, EU Regulation 2024-2895 becomes enforceable in July. And that could have an impact on food manufacturers. So if you are manufacturing products, ready-to-eat products that are being exported into Europe, this could impact you quite significantly. So you need to be able to demonstrate that foods in which Listeria monocytogenes can grow will not exceed that 100 CFU per gram limit throughout the product shelf life. So this is now putting more accountability onto the retail and distribution chains. If you cannot demonstrate that your product doesn't allow Listeria mono to grow to those levels, your criteria for absence in 25 grams becomes stricter. So while I think most food producers are now aware of this, it still could have a significant impact on some of us. It may involve more challenge testing. You may need to invest more in predictive modeling. We may even need to do more routine Listeria testing. It depends on what you're doing at the moment. As someone said earlier, it depends. There's a further regulation that comes in next year as well that doesn't necessarily hit the manufacturers and producers. But if you do have something that's responsible for a foodborne outbreak, then the whole genome sequencing of bacteria becomes mandatory, and that's enforceable from August. So we know that Listeria is still on everybody's radar. And as I said, Listeria is ubiquitous. We can find it pretty much everywhere. So everybody has plans for it by now, I think. So the risk identification, the risk assessment, finding out where your weak points are or your points of risk are within your facility, your environment, associated with your people or your equipment. Managing and measuring all of that through the sanitation processes and your maintenance activities. Locating those growth niches via your investigation. So I talk to people a lot about environmental monitoring and growth niches. So yes, we definitely should be finding out where our growth niches are and trying to eliminate Listeria from those harborage sites. So we'll obviously physically eliminate our risk wherever possible, and then optimize our sanitation practices to eliminate those pre-operational failures as well. So not all sites necessarily need cleaning equally. Some need more attention than others. And then our ongoing monitoring, our ongoing testing of our pathways of movement, of our surfaces, of our products, that's all part of that verification process to make sure that we have accurately identified our points of risk and taken the correct actions. And then I guess where things like Biorad's technology, our technology comes in, is through that continuous improvement. Yes, there should be regular review of data to further identify test points, see if your risk has moved, because as soon as you tackle listeria in one part of your facility, it can happily pop up in another. So that continuous data analysis and reviewing what we're doing, and not just testing for the sake of testing, but actually doing targeted risk-based testing, is part of that continuous improvement flow. But also, so is embracing the new technologies, the new ideas. So whether that is investing in equipment that is easier to clean because you've got something that nicely harbors listeria, whether it's investing in the staff education so that your staff understand the nature of the organisms that could potentially be in the facility and why cleaning, why testing is important, or whether it's investing in the newer technologies, the newer testing, more rapid testing. All falls under that continuous improvement banner. And I know from working with customers for years, as I'm sure you all know, that at some point listeria is probably going to get into either your lab or your facility in some form. And that's where our swabathons come in. And the vector swabbing in the starburst pattern is the way that we usually talk to, or I at Neogen usually talk to customers about it. I know some people have different ways of approaching it, but you know, finding the site of your original positive sample, then swabbing outwards from there as part of your root cause analysis. That's where these rapid technologies, I think, really come into their own. Because yes, we can use the rapid testing technologies as part of the routine testing. And as the seller, obviously, that's what we recommend. But it's through the root cause analysis side of it that I think these rapid technologies really become important, and that's where you find the true use of them. So, listeria right now, I mentioned right at the beginning, and I'd like to just come back to it. So it's designed to be, well, it is an environmental testing process. So it's not designed for food products, it is just designed for environmental swabs. And the intention is to give you a result in about 2 hours, so under 2 hours, from the point of swabbing. So it's enrichment-free. And just a quick snapshot of how it compares against other products. So I've used examples from the Neogen range. So if you're doing your typical listeria swabbing, your routine swabbing of your facility, you are usually waiting, 24 to 48 hours potentially for your listeria result to come back. Even with the current rapid methods, so we've taken here our molecular detection system, MDS, because we've got a listeria assay for that. I always say pre-incubation, I mean enrichment for that is 24 to 30 hours. So even from our rapid method, listeria right now is a significant improvement. And if you're working in a facility where your listeria results really do matter to you, this could be a great benefit. So just as a quick run through the root cause analysis process, day 0, I'm swabbing my facility, I'm just doing my routine testing. I've obviously got to enrich my sample, typically overnight. Day 1, I will get my result. If it's a positive result, great. If it's a negative result, great. If it's a positive result, then we obviously have to go through our process of re-cleaning, retesting, and then we have to wait another overnight enrichment period to get our second result. So however many times you need to clean down and retest, we're looking at about a day each time, and that's on a rapid method. If we're using things like the BAM method, we'll be looking at 10 days for this process. With the ISO method, about 13, 14 days. So with listeria right now and the non-enrichment methods, we can do all of this in one day. So being able to do your initial testing, get a positive result, re-clean, retest, and again get a result 2 hours later, and do that multiple times within the same shift if needed, could really be a benefit. And I know I say this about production environments and manufacturing environments, but actually from the commercial lab side as well, this would have saved us a lot of headache. So it is applicable to multiple facilities. And I'd just like to talk about the platform that it's run on. Because when I speak to people about MDS, typically I get, oh, it's Neogen's PCR platform. And it's not PCR. Yes, there are similarities, but there are some significant differences as well. So this is a LAMP platform. so loop-mediated isothermal amplification. As I said, very similar to PCR in the fact that it's got primers and polymerase, but there are some key differences that I would just like to highlight. So the MDS is a platform that Neogen have had for a while. You'll see here our very established range now, so qualitative pathogen testing for Salmonella, Listeria, Coronabacter, Campylobacter, you know, the usual suspects. If you were here last year, you might have heard me talk about the quantitative Salmonella kit that we've got on MDS, and now we've introduced Listeria right now to it. So it's a platform that we're continuously working on and bringing new tests to. But it is LAMP rather than PCR. So LAMP offers really specific, sensitive, robust testing. The polymerase that we are using is derived from a Bacillus stereothermophilus, so BEST polymerase is the shorthand for it. And LAMP works at a constant temperature of 60 to 65 degrees, and we can do that at one temperature just because of this polymerase that we're using. So unlike things like TAC, where we need to temperature cycle because we need that high temperature for DNA denaturation, we don't need that with LAMP because BEST polymerase is a strand displacing polymerase. So it can happily displace the top strand of DNA as it polymerizes. So we don't need that high temperature for denaturation. It says we have 6 primers. It depends on the kit, but typically 6 primers recognizing 8 distinct regions of target DNA. And then we've got a couple of loop primers as well. And it's those loop primers that will allow us to form these dumbbell structures. So they don't always form these sorts of structures. They can form different branches. They can form long chains, but it forms because of the loop primers. And the loop primers and those loop structures also give us self-priming sites and auto-amplification as well, which makes this a really rapid way of amplifying DNA. And it means we've got continuous amplification of the DNA as well. And this is where it differs from PCR, where you're producing single-sized amplicons. Here, we're creating chains of repeated sequences that can be hundreds of times longer than the target DNA sequence, and it is continuous. The LAMP is really tolerant to common PCR inhibitors, again, mostly down to the choice of polymerase. It's really, what's the word I'm looking for? Really resistant to inhibitors. And then if you couple that with the chemistry that we've got in our lysis solution as well, that also helps strip out some of the inhibition problems. So, as I said, LAMP, very similar to PCR, but some key differences, giving us a really specific, sensitive, and robust platform. The MDS assays work on this principle. So we have our LAMP, our isothermal amplification. During that process, a waste material is given off. That's our pyrophosphate ion. This is converted to ATP within the reagent tube. We've got a couple of enzymes in there, one of which is ATP sulfurylase, and the other one is luciferase. So when our newly generated ATP comes into contact with our luciferase, that generates light, and it's light that the MDS instrument is detecting. So we're working on detecting the waste material rather than the DNA itself. And I've mentioned DNA throughout this, but this is where our Listeria Right Now assay differs from the other assays because we're working with RNA. So we are looking for ribosomal RNA in the Listeria Right Now assay. And this is why we can get away with. This is why we don't require the enrichment step. Because the ribosomal RNA in Listeria is already there, it's already present in really high copy numbers, so we don't need that enrichment step to get our target up to detectable levels. The rest of the assays work on DNA, though, which is why all my slides are about DNA. So onto the test kit itself. The Listeria Right Now test kit comes with everything complete in the box, so you don't need anything outside of what appears in the test kit. The swabs, which I've highlighted, have been designed to be resistant to typical sanitizers and their inhibitive actions. So whether you're using an acid-based or a hypochlorite or what's the other word I'm looking for? well, mine's gone blank, but any of your typical sanitizers, the swabs are designed to be resistant to their effects. And with my last 30 seconds, the workflow, because I think there's sometimes a perception that a rapid method becomes more complicated. But with Listeria right now, all we do, first of all, open up our swab, get rid of the excess broth, swab your surface, return the swab to the tube, and then add the lysis after we've reconstituted it, vortex, transfer to a cluster tube, go through the lysis step, heating for 10 minutes, cooling for 5 minutes, and then just transfer that to the reaction tubes. And the reaction tubes contain everything that you need for the reaction. So all of the enzymes, the primers, the polymerase, all present within that reagent tube. Transfer everything to the MDS instrument, close the lid. Your positives are reported in real time. Negative results appear after 45 minutes. So it gives you a nice, rapid workflow. I say 2 hours, just because it depends on how many swabs you're processing. If you're taking one swab, then you'll probably, from swabbing to getting your final result, will be about 1 hour and 10 minutes. But if you're doing multiple swabs, it'll take you closer to that 2-hour mark. So that is the introduction to Listeria right now. And the true benefit to it, I believe, is being able to reclean, retest multiple times within your same shift. So while it is designed to be part of the part of your routine environmental monitoring, it's perfect for root cause analysis. I think that's where its strength, I personally think that's where its strengths lie, because you don't have to wait those 24 to 48 hours for your reclean results. You can get your results in 2 hours. So it enables you to make those faster decisions about whether you hold lines, whether you carry on making products, or that you may potentially have to dispose of or process further at a later date. It really does enable you to make those decisions that much quicker. That's our brief introduction. Please do come see us. We are just at stand G44, literally as you walk through the other side of the theatre. You can't miss us. We're right in the way. So yeah, if you do have any questions, please feel free to ask now or come and see us.
Thank you, Ms. Michelle. He is the principal and founder of IEH Laboratories and Consulting Group, a leading global network for analytical and consulting services in food safety and quality assurance, with BS, MS, and PhD degrees in microbiology from the University of Washington. He is a world-renowned expert in foodborne pathogens, outbreak investigation, and preventative food safety system, driving modern food safety practices across the supply chain for over 2 decades. Please welcome Dr. Mansoor Samadapur.
Thank you. Can you hear me? Okay. So we're going to talk about whole genome sequencing. Currently, these are the platforms that are available for whole genome sequencing. Illumina, Oxford, PCB, and Ion Torrent. The leader in the field at this point is Illumina. There are a couple of other platforms that are coming into play. Roche, I think, just announced one, and then there are a few more that are being developed. In the US, the regulatory agencies are mostly using Illumina. And in our lab, we use both Illumina and Oxford Nanopore for different purposes. Oxford has a problem in base calling. It has improved tremendously, but still is not as accurate as Illumina. So we cannot use that for SNP analysis. But it does have its uses. Extremely fast time to result. We use it for sometimes for metagenomics if we have a rush for samples. The uses of next generation sequencing in food industry with an eye to food safety. These are the, we can do ingredient authentication, detect GMOs, detection of allergens, most of the allergens, not all. Optimizing fermentations, monitoring fermentations, studying microbiome, microbial profiling. We use it in development of novel foods. A lot of companies that are using tissue culture, to make meat, and in all the earliest stages, we use next generation sequencing. Microbial identification, using 16S and then longer reads. Cause of spoilage analysis is probably one of the best uses of the technology in the food industry. In 2 days, max 3 days, we can identify more than 100,000 microbes in a spoiled sample. Where classical methods is going to take us just to have an answer that may not even be accurate, it's going to take 2 to 3 weeks. Characterization of probiotics of production strains, distinguishing virulent versus avirulent strains. Virulence profiling on microbial isolates. We've had situations where we have Vibrio cholera in a sample, and then we do whole genome sequencing, and it turns out to be a non-virulent, but taxonomic-wise, it's a Vibrio cholera. Outbreak investigation is one of the most common uses of whole genome sequencing. I'll show you some examples of that. High-resolution typing of microbial strains. In many ways, we are not doing, we've stopped doing serotyping. We just do whole genome sequencing. We have all the information in front of us and more. Lab contamination investigation. In the US, we are often called upon to examine lab contamination. And probably in about 60–70% of the cases, we find the lab strain to be the cause of the contamination. But these are situations where the sample is not a likely sample to be positive. So we don't do that for poultry samples. We do it for places where, like, cooked in a bag food has tested positive. So where it's highly unlikely and the client has a high grade of confidence that it's lab contamination. We just had one situation that we had to tell the client that no, it really was not a lab contamination. So they accepted it. So. Microbial community profiling for shelf life extension, understanding fermentation dynamics, so on and so forth. Environmental monitoring, we are using that to characterize all the environmental isolates for some food companies. And increasingly, more and more are moving to whole genome sequencing, despite the fear that is, a lot of companies have a fear of whole genome sequencing, but once you sit down and educate them that is really baseless, they make a switch. Antimicrobial resistance profiling, and these are just some of the uses of the methodology. Metagenomics, people have talked about that. So instead of sequencing the entire genome of a microbe, we sequence selected targets in a sample. And we use it a lot in cause of spoilage analysis. And I told you we can do 10,000 to 100,000 strain identification very fast and economically. So this is an example of a spoiled product that came to the lab. There are two types of spoilage that we do analysis. One is for aseptically filled, and another one for fresh foods. So if we suspect that the food, or if the food has a microbiome, we always get non-spoiled and spoiled, and we do the metagenomics on both. And here you see the difference between the non-spoiled portion from the same lot versus the spoiled portion. They just jumped that this was the cause. This is another example where we amplified both bacteria and fungi. This was a spoiled veggie puree, and no molds or no yeast and mold in the non-spoiled, and then in spoiled, we have the cause. So this is really powerful, and it's one of the most common uses for us in the lab. In one situation, we had a company that had issued a recall. It was based on a lab identifying mesophilic spore formers, Clostridium botulinum specifically. After the recall, they still were doing investigation. They sent us the samples. We purified the organism, did whole genome sequencing. It was not Clostridium botulinum. And it was a Clostridium that had not been identified before. We characterized it, we published it as Clostridium tapidium. So one of the really easy ways to identify organisms is just to do whole genome sequencing. So there are people who are just naming organisms right and left, just having this technology. Shelf life extension is another use, where you have microbial spoilage of the product. You can identify the good flora, enhance their potentials for growth. You can identify the bad products, the bad flora. We did one experiment that it took us months to do that, but we identified the microbial flora for sprouts. And after 6 months, the product was still fresh. I just got tired of it and tossed it away at that point. But these things actually do work, and that's one of the uses. As I told you, we don't do serotyping anymore. There are some of our colleagues continue to do that, but we stopped doing that. We just go to whole genome sequencing. It's much faster, and it gives us a lot more data. The example that I gave you is Vibrio. We have seen it multiple times, actually. We get it in seafood coming from both Southeast Asia and South America. And they are avirulent. It has been very handy, too. Antibiotic resistance. This is a very, again, easy way to determine the entire antibiotic resistance profile. We have an emergence of sanitizer of Listeria and Salmonella that are resistant to sanitizers. So we can use whole genome sequencing, or we actually have developed probes, PCR, to detect them at this point. In environmental monitoring, it's a snapshot of one of our clients. Green are negative samples, reds are positive samples. So remove the greens, you still have a lot of positives. With whole genome sequencing, you can track each one of the clones. And this has really helped the infant formula industry. In the US, they have all moved to whole genome sequencing, and they are monitoring Coronabacter Sakazaki like that. So let's go to outbreak investigation. By the time you get a call and you're linked to an outbreak, so it's either a product has tested positive, someone grabbed a sample in market. They do that in the US. Departments of Agriculture get assignments from FDA, and they continue taking some samples from the field and test them. One of your customers may have tested the product. In the US, FDA and USDA do go to facilities and take environmental samples and product samples. So if they test positive and they get linked by whole genome sequencing to a cluster. And sometimes we see they find a match to a cluster that happened 5 years ago, 6 years ago. It's not an active cluster, but we still, whole genome sequencing matches them. And we have another category that you can also get implicated in an outbreak if epidemiologically you are linked. This is in the absence of having a positive from your sample. Some of you may know right now we have an outbreak of infant botulism in the US. Since August, we have had 84 cases of infant botulism. 35 of them have had a history of infant formula, and 23 of the 35 have used one brand, which is only 1% of the market share in the US. So statistically, at most they should have had one case. They have had 23. So this is a situation that even in the absence of any positive, the company gets linked, and the data is overwhelming. They did isolate, they found the Clostridium botulinum in one of the open cans in one of the patient's homes. Fortunately, all the kids are okay, they have survived, so we haven't had death in this cluster. So let's go through some of the outbreaks that were interesting. This is an ice cream brand. There were cases in the clinical database. So Center for Disease Control has a database of all the clinical cases. State health departments do whole genome sequencing. They get deposited, and then they deposit that in NCBI database. This is an international database at this point. It just happened that FDA had gone to that facility. They isolated exactly the same whole genome sequence with a couple of SNP differences from both environment and the product. This one, inspired peanut butter, was a really interesting case. This was the first time that FDA used whole genome sequencing to match a company to a cluster of cases. So FDA had gone to the facility, they had isolated salmonella. They whole genome sequenced, it matched a cluster of patients. And that was sufficient, they issued a recall. And then they had to expand the recall a couple of times, but that's a different story. So FDA has used this method very frequently. One of the things that they do when they go to a facility, they take, under investigation, they take a lot of samples. And they have been able to link several companies by whole genome sequencing to previously unknown clusters of patients. So these are the clinical isolates and environmental, which are just falling within. And they're all within about 2-3 SNPs of each other. In this particular case, there were 16 illnesses. And 17 clinical. And that was sufficient to identify the company. So again, one of the things that they do, they get the epidemiological history, and once a food gets implicated, at that point, they don't need to find it in the product. I'll go over another example of this. This was a very interesting situation. To make a long story short, there's a cluster of patients, and they could not identify the source. FDA had a positive from boiled eggs, from Greencore, and from their salad, egg salad. And that positive was not, that product was not used by any of the patients. So they had the positive, they had no idea what to do with it. So they did not implicate the company. A year later, one of our clients had a positive in their egg salad. And we found it to be exactly the same as that outbreak. So we informed the client, they informed FDA, and FDA found that both Greencore and our client had the same supplier of eggs. They went to the facility, they found it in both product and in the environment. So once you have a database and you're analyzing the data and you're doing whole genome sequencing, a lot of these type of things happen. So this is at the end, these are all of our positives, and as you see, they're very closely related to each other. We recently had an outbreak. This was a company that was buying ready-to-eat products, formulating them without any cooking, sending the trays to the market as ready-to-eat foods. 5 people had died, several hospitalized, many cases. It has grown to more than 20 cases now. And we worked with that company, looking at their environmental and the epi data. Cases were associated with 3 different facilities in 3 different states. So we reasoned that this is not an environmental issue and it's an ingredient. So we continued testing the ingredients, and we found that the pasta, cooked pasta they were procuring was the source. And then that company was sourcing to others, selling to others. So that resulted in a huge recall in the US. That's the name of the pasta producer. There are many cases where we cannot identify the source of our clusters of outbreaks, despite the fact that they're matching, because there are not enough epi resources to investigate them. We are running out of time. The Chronobacter in infant formula is a really good example. This is where the entire industry is using whole genome sequencing. And because of that, and the data is shared with FDA, FDA has really calmed down, and before the moment they had a positive, they would tell them to shut down the line, this, that. And now with the whole genome sequencing data, they understand that we are looking, we are trying to find, we are finding, and in majority of cases, it's not implicating the product, it's not impacting the product. So let's stop here. I'm out of time, correct? If you have any questions. Thank you.
Thank you, Mr. Mansour. He is the head of global business development for proficiency testing at LGC Standards, leading global strategy, partnerships, and growth initiatives that strengthen laboratory quality assurance worldwide. With over 18 years of experience in analytical standards, biosciences, and quality systems, he has been instrumental in expanding LGS's footprint across food, pharmaceutical, forensic, and industrial sectors. Before rejoining LGC, he led biosciences, innovation, and commercial development at Randox. Please welcome Patrick Henry.
Good morning. Good morning, everybody. So today I'm going to talk about proficiency testing, and there's some similarities between my presentation and Dr. Mansour's earlier on. I thought that was very fascinating, and it's not an overly technical presentation from me today. It's more about using proficiency testing as a tool to support early detection and improve the quality of analytical measurements. And there are many considerations for laboratories, there's many considerations for brand owners when it comes to proficiency testing, but it impacts the entire organization. And really, sitting at the center of all of that is consumer protection, brand loyalty, and trust. Proficiency testing, and I'll talk a little bit more about proficiency testing as I move my presentation forward, impacts all aspects of food safety culture. It impacts behaviors, it has a direct influence in regulatory and accreditation and compliance. It impacts the supply chain and has a strong influence on company values and practices. And proficiency testing sits centrally to that. As we heard from Dr. Mansour's presentation earlier on, there are many risks to food and drink manufacturing, and they can be categorized as modern AI-related security. Inflation has played a significant role in food safety. Labor and staff retention, geopolitical issues. But sitting, I think, front and center for brand owners is food recalls. Dr. Mansour brought up several slides in terms of how this impacts organizations, it impacts society, illnesses. Just one slide from me, just to give you an overall holistic viewpoint as to how food recalls impact an organization. It's not just organization, it's the person who is sick, sadly the person who dies, but also the brand owner, and it's not just the brand owner, but it's associated brand owners and those involved in the food safety supply. So you can see how this compromised chili powder, Sudan 1, had impacted many different organizations, impacted recalls and warnings, and led to a significant financial impact to organizations and organizations as a whole. In terms of issues, recent data shows us the number of food recalls the increase in hospitalizations and deaths, and 45% of those are due to labeling errors. Undeclared allergens played a significant role, over a quarter, and 40% or 39% related to pathogens. So what are the testing and quality challenges for brand owners? Well, depending on the range of tests, whether using pathogens as an example, there are over 2,500 types of salmonella. And within the laboratory environment, there can be a lack of familiarity in terms of the potential strains, isolating those strains. So there's no size-fits-all technique for identifying those. So what is PT? PT is the evaluation of participant performance against pre-established criteria by means of inter-laboratory comparisons. And it's there to provide the infrastructure for laboratories to monitor and improve the quality of their results. It's part of a bag of tools. Shouldn't be the only tool, but it's certainly a very valuable and impactful tool when it comes to improving the quality of analytical results. PT is the only external validation of this process. PT is part of a set of QC measures that can take place, and they could be quality control materials, amongst others. But in terms of looking at the outcomes within the testing environment, PT is one of the few tools, if not the only tool, that monitors the quality of the external results. So what are the benefits of PT? Well, PT or proficiency testing is contained within many GFSI requirements, making it front and center in many ways, or complementary to testing requirements within the food and beverage industry. PT reflects the actual quality of the laboratory, and it enables laboratories to monitor and improve the quality of its measurements. But it's most effective when used in combination with other quality measures, and it can bring many benefits. Those benefits include accreditation, fulfilling accreditation requirements, demonstrating a laboratory or a brand owner's quality to its own customers, and it allows laboratories to compare their results with other laboratories running the same tests globally. It's a very strong educational and training tool, and it helps verify methods and instrumentation. But a particularly strong tool, it manages risk, it identifies risk early. So how to make the most of PT participation? Well, causes of unsatisfactory performance, of which proficiency testing can identify, can be broken down between analytical errors and non-analytical errors. So analytical could be calibration, instrument problems, methods, analysts themselves, whereas non-analytical methods can be calculation, transcription errors, units, etc. We did a survey, and it showed that the majority of those issues came from non-analytical issues, so human error, sample preparation, and equipment problems. And where human error was identified as the primary reason, number one was transcription errors, and then interpretation errors, and lack of experience. So it can be something as simple as that. I think it can cause a failure of a PT test. Proficiency testing also allows the use of trending. So the benefit of trending is looking at results over a period of time. Often, well, always, one PT result will give you a snapshot of where you are at that particular time that you ran that particular test. But looking at that over time allows you to identify risk and manage risk. So you can see in this example, we have a laboratory that results fall within the acceptable area, that identified in green. But you can see that it identifies that there's a warning sign after 5 results and action required after 9 results, simply because all the results identified show a positive bias to the mean. The next graph, we see that there's a warning sign after 1 questionable result. So questionable result sits between an acceptable and an unsatisfactory result. 2 consecutive questionable results requires action and investigation. So the important message is to investigate all unsatisfactory results, 2 questionable results for the same analyte, or 9 successive results showing a bias to the assigned value. The value of trending is clear. It's an early warning system alerting to issues prior to results being out of specification. It can help a lab identify an issue versus a retraining need. It can also identify collusion if that is an issue. So how do we make the most of proficiency testing participation? Treat the PT items with the proficiency test samples in exactly the same way as the laboratory would treat a normal day-to-day sample that presents itself in the laboratory. Vary the analyst and vary the test instrument, if possible, used for the test items. As a PT provider, we don't see ourselves as police. The police, we see ourselves as teachers. So when a result, irrespective of what that result is, those results should be used openly, transparently, and constructively. It's there to be honest, and it's education, not regulation. That concludes my presentation. If anybody would like to ask a question, I'd be pleased to answer any question. Okay.
Thank you. A PhD in food microbiology from Agro-Paris Tech serves as Deputy Scientific Director at the French Agency for Food, Occupational Health and Safety since 2014. He has led the Staphylococci, Bacillus, and Clostridium unit and currently directs the European Union Reference Laboratory for Coagulous positive staphylococci, while serving as deputy head of France's National Reference Laboratory for the same. A leading expert in foodborne pathogens and toxin detection. He has authored over 50 publications, contributed to ISO standardization through ISO TC 34/SC9, and recently organized the first international symposium on foodborne bacterial toxins, bringing together global experts in food safety, science, and policy. Please welcome Jacques-Antoine Henneken.
Good morning. Good morning, everybody. Thanks for being here today, all brave and courageous attendees at this time slot just before the lunch break. I would like, first of all, as all the speakers, to thank the organizing committee for providing me the opportunity to explain how we can contribute to food safety and our way of working in Europe. Before jumping into details, I would like first of all to present the Agency for Food, Health, Occupational Health and Safety. It's a governmental agency under the responsibilities of 4 ministries: Ministry of Health, Agriculture, Environment and Labor, so it can be considered that the One Health agency, I would say. And it's divided in 4 departments. The first one is the general one, focusing on resources, so both financial and human. The second one is for the regulated products. The third one is dedicated to expertise and risk assessment. And the fourth one is the one which have all the laboratories inside, especially the laboratory for food safety in which I'm working for. So in this lab, we are working on food hazards, both microbiological and chemical ones, in order to produce through scientific project the knowledge necessary to improve, prevent, control, and perform risk assessment for all the hazards covered by the food chain. In this lab, we are mainly focusing on 4 topics. So reference, I will give you a few words about reference activities, research, expertise, and at least surveillance. And today, I will make a focus on reference, research, and expertise activities. So I will now jump into a little bit boring, I would say, regulation. And it's a very tight framework, legal framework, but we have to do with it. And in Europe, we have what we can call general food law, with a lot of regulation, and the basis is the regulation 178 from 2002, dedicated by the European Parliament. And in this one, you lay down all the general principles and the requirements of the food law. So there is the creation of the European Food Safety Authority and other documentation dealing with the creation of the European Union reference labs. So that's under the regulation 625 of 2017. Basically, the aim of the general food law is clearly to have a better traceability, better transparency, and to enhance the responsibility of food business operators. In this general food law, you can also see the creation of a RASF, Rapid System for Food and Feed Alert, in case of food poisoning outbreaks between member states. And I will give you an examples with listeriosis in a few slides. So that's the general frame of the food law, but we also have our bedside book, and this bedside book is the regulation 2073-2005, dedicated on microbiological criteria for foodstuff. So in this regulation, you have microbiological criteria for certain microorganisms, not all, because member states have to agree on the food microorganism they would like to put in this regulation. For example, there is nothing dealing with Clostridium botulinum or toxins coming from Bacillus cereus in this regulation, even if it's important as food poisoning outbreaks. Anyway, that's like this. And it laid down the microbiological criteria and all the rules that must be followed by food business operators. And the purpose is clearly to provide objective and reference point to manage and monitor the safety of food. So key points, we have two types of microbiological criteria with which food business operator must comply. A process hygiene criteria, okay, basically coagulase positive staphylococcus in raw milk cheeses, and food safety criteria. We spoke about Listeria monocytogenes, but we can mention also Salmonella and Staphylococcal enterotoxins. And food business operator must base all their analysis based on risk analysis principle. On this slide, you have an example of this regulation and food microbiological criteria. So in the green one, it's the food hygiene criteria. So you have the food to be tested, the target, so coagulase positive staphylococcus, the sampling plan, the maximum threshold, okay, so the criterion, the method to be used, the moment at which you have to perform the analysis, and the measure you have to take into account in case of unsatisfactory result. So that's for food hygiene criteria. And for food safety criteria, it's the same thing, okay? You have the food category, the target, the criteria, and the method to be used. You can just note on this slide that at the beginning, the method was the European screening method developed by the Eurofins Reference Lab. It was in 2005, and in 2005, there was no international standard dealing with staph toxins. This one was published in 2017, and there was an amendment of the regulation taking into account the new ISO standard to put this one in the regulation. As mentioned before by Michel, we have the same thing for Listeria, but there are also new criteria in the regulation, and there will be a new one with a new regulation which will enter into force on the July 2026, dealing with ready-to-eat without safe life study for Listeria monocytogenes. Okay, so that was the background, I would say. Regarding our function of URL for coagulase positive staphylococcus or Listeria monocytogenes, we have core function. First of all, we have to manage a national reference laboratory network. Each member state has to nominate a national reference lab on each process hygiene criteria or food safety criteria of their regulation. And as EURL, we are here to clearly manage this network of national reference lab. We can also perform confirmatory analysis for other member states, and I will give you an example in a few slides. We, of course, develop, validate analytical methods. We organize a training session, and in order to check if National Reference Lab clearly understood what we trained, we organized PT trials, proficiency testing trials, in order to see if they can comply with the EU regulation and if they can maintain their national reference mandate. So that's for the core function. We can also provide in yellow scientific support to member states, of course, DG Santé, so European Commission, and EFSA and ECDC. Basically, we take part in the zoonosis report every year. We can take part in the modification of the EU regulation and something like that. Because we are deeply involved in characterization of food poisoning outbreak, we also develop typing methods. So mainly WGS or MinION, so short read and long read technology, Illumina and Nanopore, for both Listeria mono and coagulase positive staphylococcus. In the CPS world, we also developed methods for staphylococcal enterotoxin using both ELISA-based method and mass spectrometry-based method. So we are really at the border between microbiology and analytical chemistry. So we will see that we need complementary skills. And because we need to have to maintain a high level in reference activities, we need to be clearly active in standardization development. And currently, we take part in numerous CEN or ISO working groups on the pathogen mentioned, so Listeria monocytogenes for 290 part 1 and 2, for staph toxin 19 or 20, more general methods. We also proposed PWI, so preliminary work item, especially on the development of a standard for mass spectrometry for staphylococcal enterotoxins. Because we are here to help member states, we also develop quality assurance tools. So we developed certified reference material with the Joint Research Center of the European Commission. We have strain databases, DNA databases, a lot of naturally contaminated samples used when we develop methods in order to check their real performance in a real life situation. And yeah, that's our main duty. But the legal framework is very tight, and moreover, the prerequisite is the quality assurance. Of course, because we provide results to decision makers, to the member states, we need to be sure that the results are reliable, they can be trusted. So we have accreditation for analysis according to ISO 17025, but also as a PT organizer according to ISO 17043. That's very important to ensure to the member states that we organize the PT and we based their, I would say their good or bad results on a real, clearly defined PT scheme. Okay, so in order to have some fresh air after this very, very tight legal framework, we need to develop research and development project in order to maintain high level of expertise especially for when we develop analytical methods. So the idea is clearly to develop knowledge regarding pathogen virulence, contaminant toxicity, bioaccessibility, exposure, persistent resistance, and so on. And we have also to improve control methods on emerging, re-emerging hazards, so mainly Chronobacter, I would say, but also on hazard identification, characterization, and novel food, because we have a lot of standards currently for CPS enumeration, Listeria monocytogenes detection, but they have been developed and validated according to different food categories, and nothing dealing with novel food, I would say. So we have to work on it, and we work on it. And we also develop methods to improve surveillance, epidemiological monitoring for Listeria monocytogenes, with, of course, molecular characterization tools, mainly WGS, but also DNA chips for staph toxins. So we have a lot of partnerships in France and outside France, especially in Europe. So you can see the partners. There are only 2 outside Europe, FDA, USDA, but nobody outside Europe. So we are fully open for collaboration with new friends outside Europe. So if you want to play with us, don't hesitate. Of course, all this research lead to publication, so that could be publication based on the standard development for Listeria, for staff, bioinformatic tools, this one, comparative analysis of different methods, development of methods for staph toxin using ELISA or mass spec, or simply development of writing of the zoonosis report every year with the EFSA and the ECDC. We are also deeply involved in expertise and surveillance in method development, as I told you before. So we are actively take part in ISO standardization bodies, especially the SC9, Subcommittee 9 in charge of food microbiology. So we are in different working group, general ones, such as public website, or more dedicated, such as, I don't know, coagulate staff, maybe for PCR, project leader in PCR, or convener for the development of a new standard using mass spectrometry. It's very important to be clearly involved in standardization bodies, to be clearly in link with the next step and the new method that would be into the regulation. Regarding now our role into foodborne outbreaks investigation in Europe, so that's the example of listeriosis outbreak. So you can see there are different domains, a public one with clinical sample, and vet one, I would say, with food samples. So you have different sector, the public health sector and the food sector, and these two ones have to communicate a lot at the different level. At the member state level first, where strains are collected by clinical labs, and for the food sectors, strains are collected by national reference laboratory, okay? And this one perform WGS analysis and transfer all the data to the EFSA One Health WGS system, okay? And in parallel, at the public health side, there is a database containing all human isolates, epipels, and there is a clear link between EFSA and ECDC, thanks to an advisory board with EFSA, ECDC, EURL. And as I told you at the beginning, there is also the RASF, a Rapid Alert System of Food and Feed, in order to prevent some other outbreaks in other EU member states. And finally, you have a notification on the EFSA website on the official reports, and that's the cases of listeriosis due to frozen corn in Poland 2 or 3 years ago. Regarding staph toxins, so I used to take spectacular outbreaks when I speak about staphylococcal enterotoxin. So by spectacular, I would say children, weddings, or aircraft, because in an aircraft, you can imagine how that could happen in an aircraft if everybody is vomiting, diarrhea, with only few toilets in the cabin. So this one occurred 10 years ago with an aircraft from Ireland to US with 44 cases, and the suspected food with a strawberry crumble mousse. And we performed the analysis because the Irish competent authority asked the support of the URL for CPS. And the epidemiological study and the symptomatology was clearly in favor of staphylococcal food poisoning outbreaks. So we performed the analysis using the available methods. So we detected coagulase positive staphylococci, we detected toxins, we can also quantify these toxins, And we perform PCR and PFG because 10 years ago, PFG was the gold standard and we did not use yet the WGS in 10 years ago. So for our point of view, the SFPO was confirmed because we clearly detected and quantified staphylococcal enterotoxin type A, but molecular biology tools also highlighted the presence of genes encoding H, G, I, Q, E, and P. And unfortunately, at this time, we had not all the relevant tools to detect this toxin. Anyway, from an epidemiological point of view, this staphylococcal food poisoning has a causative agent, the staph enterotoxins. Today, we developed a toolbox for staphylococcal enterotoxins with, first of all, Staph aureus enumeration and characterization using ISO standards, using WGS, of course, but also PCR, because not all national reference labs have access to WGS analysis, so we have to keep the PCR tool available. And regarding staph toxins, 10 years ago, we only focused on toxin type A to E, so 5 toxins over the 33 detected in the literature. And we added some new toxins, mainly based on their, I would say, prevalence in all the study we performed in food poisoning outbreaks. So we developed ELISA-based method, but also mass spectrometry-based methods. So to conclude, takeaway message. So reference, research, and expertise are highly interconnected. Reference is clearly the backbone of research activities as research uses reference to highlight gaps and opportunities. And reference and research outcomes feed expertise. Detect contaminants in food is like looking a needle in a haystack. Remember, currently there is a large outbreak due to a very rare E. coli 045H2 in Germany, more than 380 cases, 3 diseases. We did not find the causative, the food vehicle currently. We don't know what it is. So that could be a little bit tricky, even if you have a lot of methods and something like that. In order to fully characterize food poisoning outbreaks, there is clearly a need to develop a toolbox with complementary approaches. So from classical microbiology to molecular biology, including also, if you work on toxins, MS-based approaches. And for all these methods, they must be sensitive, specific, and of course validated in order to provide an unambiguous result to your decision maker. And for that, you can develop characterized calibrants or certified reference material if you need to perform quantitation in the case of risk assessment analysis. I just would like to acknowledge the URL for CPS staff, the URL for Lister monocytogen staff, our support activity for bioinformatics and administrative affairs, and thanks for your attention. Lunchtime.
next session, our first session after lunch, is going to be looking at the critical topic of microbial safety in the dairy industry, with a special focus on baby and infant formulations. To guide us through this emerging and the re-emerging challenges also that we're facing, please could you welcome François Bourdichon, who is the chair of the Standing Committee on Food Hygiene at the International Dairy Federation. So please give him a hand of applause. Thank you very much, François.
Welcome, everyone. So I don't need to introduce myself, François Bourdichon. You can hear from the name and the way I speak. I'm French. And I'm going to talk today on behalf of the Fédération Internationale du Lait, International Dairy Federation. There will be a more extensive presentation of the IDF tomorrow morning. But today it's going to be a little more technical. It's about the emerging and re-emerging microbial threats for the dairy industry. The good thing with microbiology is that what Louis Pasteur shown more than 150 years ago, there is no spontaneous generation, which means that per se, apart from ESTEC, we cannot really speak about emerging microbial threats. It's more that they come and go depending on the episodes. So the Standing Committee on Food Hygiene is one of the scientific entities of the field IDF. I'm presently the chair, and my deputy chair, Lukas Weiser from Germany. We have a representation of what we call the Scientific Program Coordination Committee from Aditya from India, and Nick Gardner from the US. We have the object of monitoring, reviewing, and reporting on food hygiene globally, which means that we also try to have a look what's going on in the respective countries of the IDF, which means that more than 50 countries. And we have twice a year a meeting. One is virtual, one is physical during the business meeting of the World Dairy Summit. And we have a program of work. It's not only fun, it's also a lot of work. And one of them is about the surveillance of relevant information and reporting emerging hazards with milk and milk products. So twice a year, we ask every country to provide information in what's going on in their countries. And out of the discussion, which lasts every time from 1 hour and a half to 2 hours, we take a point of concern which we believe we should focus on and do some further work. So these are the ongoing priority items for 2025-2026 that we decided to work on the Standing Committee on Food Hygiene. One is about the guidelines of the use and reuse of water. So there is a work already done by the FAO GEMRA about the use and reuse of water. There are two specific reports, one for dairy, one for the fish industry. Recently, there was a guidelines adopted by the Codex Committee on Food Hygiene about the use and reuse of water. And we decided to take a global perspective on the use and reuse of water at the IDF, considering also environment, considering the technical purposes of this. The two other topics are about processing environment monitoring. So I'm French, which means that I'm very strict with the words I'm trying to use, even so English is not my mother language. I don't like environmental monitoring, because for the microbiologists, when you say environmental monitoring, it means it's in the factories. For the chemist, it means it's outside. So I prefer to use the wording processing environment, which you saw also in the EU regulation since 2005. And another topic, which will not be debated today, is about the regulatory status of food cultures. So 1/3 of the food intake is fermented. Having said that, we don't have a clear status about cultures, which means that every time from Europe we try to export blue cheeses or camembert or whatever soft type cheeses, local authority tells us, interesting, you've got filamentous fungi with mycotoxin genes. Yes, but it's safe. So that's why we try to work on. Now, what about infant and baby formulation, which is part of the dairy surveillance we do have? One thing you need to know that when it comes to infant formulation, we are dealing with usually big batches of product. So classically, a batch of milk powder will rank between 20 to 80 tons. So it's not something you do in the kitchen. You need specific facilities for it. And second point is you deal with a very sensitive population. So basically, you're looking for a haystack for a needle in a haystack, and it's very complicated. And this is a report that you have from the 2005 Salmonella agona outbreak we had in France. And in the conclusions, they already mentioned that routine macrobiological controls are not sufficient to detect a low-grade contamination. Which means that personally, when I hear that something's going on and people say, we should test, say, fine, please do. But if you don't have the right stringency of your sampling scheme, you're just wasting time and money. So finished product testing is not the holy grail, it's not the answer to everything. I don't say it's needless, but be careful. It depends what you're looking for. Per se, this is not something new. So this is an extract, apologies for the poor quality, from an Abraken study from 1986. Whenever we're dealing with infant formulation and powder, we always refer to this publication, which is very complicated to get because it's not electronically available. And in the introduction, the Abraken was already mentioning that per se, microbial testing on finished product has a huge lack of reliability. And in the reference, one goes back to 1931. So if you're a microbiologist, you should know that finished product testing is not helping. It's reactive, it's limited by the number of samples you take, and also in timing-wise, it's complicated to do, which means that we need to anticipate. What is important for infant food? We had recently in Europe a Salmonella agona episode in 2017. That was the same strain that in 2005. We had 2 years after a Salmonella puna outbreak. That was the same strain as in 2011. Back then, the initial discussion with some authorities were that it was a coincidence. It was the same serotype, but basically these two episodes were not related. This is where we had an issue in terms of knowledge between authorities and industry, that we know for quite a while that there is persistence and survival of microorganisms in the processing environment, and it's already embedded in the EU regulations since 2005. So concerning specifically infant food, from the Codex perspective, they do fall in the category of low water activity foods. So you don't have per se of code of hygienic practice for infant food, but you have a code of hygienic practice for low moisture food. And we had an initial work with ILSI some years ago, and there was another one early 2020, where we asked ourselves if we were looking or not for the right microorganisms in the food processing environment. And when we made this publication from the monitoring the processing environment, one of the things we've seen is that it was very complicated to find reference about persistence of Salmonella. You had reference of persistence of Listeria. There was an old publication, reference publication from Tomkin from 2002 about persistence of Listeria in the environment. But there was no per se many publication available either for the persistence of Chronobacter or for the persistence of Salmonella in low moisture food environment. And this is where we have now this very interesting publication from the EFSA biohazard panel, which clearly established the persistence of microbial hazards in food and feed production and processing environment. What does it mean? It means that this article is really an official position from authorities that we do not work in sterile processing environment. When you deal with Listeria and you present a Listeria presentation during a World Dairy Summit and people come to you and say, Listeria is not a concern for me, I'm working with pasteurized milk, you know you were not clear. So we had to work on this. And now it's very important to have in mind and that your environment is not sterile, that you can have harborage sites where strains can persist for years, decades, and basically you never get rid of them. which is also important because when we had the 2017 outbreaks, we have some consumer associations that say, we want salmonella-free factories. And the point was, if you want salmonella-free factories, you won't have many factories and they won't stay for long. Because it's microbial ecology, you have to deal with it. Now, it's not because they can persist in the environment that you need to accept it. You need to fight for this, and that's what you often find in US publication where they mention the seek and destroy. But what you seek is the presence of the microorganisms. What you want to destroy is the arborigenation. So sometimes you see a lot of corrective action that they found salmonella, we clean, and then we get rid of this, it will come back again. You need to be proactive. If you have salmonella in your environment, it means that the environment is fit for purpose, it can survive there, so you need to change the ecology of your facility. And persistence is known for quite a while. It was not straightforward established, but it was written in the EU regulation. So this is an update from the regulations 2073/2005, and this is an update from 27 that mentions that you do not have a clear correlation between Enterobacteriaceae and Salmonella. And back then, they mentioned that you could eventually have a correlation between Enterobacteriaceae and Chronobacter spp. I say Chronobacter spp, it's not written Chronobacter spp, but the nomenclature has changed. Now we know that there is no correlation. So it poses another issue that we do have. You have hygiene indicator on one side, you've got pathogen of concern on the others, and both provide you different answers. Yet the level of sensitivity is not the same, the cost is not the same, the throughput is not the same. So hygiene indicators are indeed very relevant. They are very helpful, but they do not make it all. Which means that this was a mistake that we had in the first version of the regulation in Europe. They mentioned that you should be looking for Enterobacteriaceae, and if you had a detection, then you should look for Salmonella. Don't do this. This is what Abbott used to do. You need to check for Enterobacteriaceae for hygiene. It's an enumeration technique which has a low sensitivity, and you need to make the detection on Chronobacter spp and Salmonella spp in other points, and the sensitivity is completely different. So food and feed processing, as mentioned, it's more than 30 years. So this is the oldest reference I could find. It's from the ICMSF. From Tomkin. I don't think you have older than this, but already you see that it was published in 2002 with a focus on Listeria, and the recognition official by the authorities come in 2024. So it just took 20 years to clearly establish, yes, food processing environment are not sterile, and we should look for it. And now, let's say it, food processing environment is a new black. Every time something happens, well, you should look in the environment. You've got STEC in your product, you should look in the food processing environment. No, food processing environment provides a clear answer for pathogen of concern like Listeria monocytogenes, Salmonella, and Chronobacter, but not for all the bugs. Because sometimes it still can come from the process, from the raw materials. And that's something we do have embedded in the update 1441/2007 of the regulation, where you should look for presentive Bacillus cereus in infant formula. And then it's an improvement of your production hygiene and selection of the raw materials. Which means that sometimes, if you have a contamination on your product, if you have a heat step in place after, yes, there is high chances that it will come from the environment, having said that, there are still some bugs that can go through the heat process and that they do come from the raw materials. In infant food formulation, the key topic of concern for this is what we call the HRS, the highly resistant spores. And this is where my presentation should have ended if we were last Wednesday. In between, something happened, which I need to talk about. It's about CBOT in infant formulation. So CBOT formulation is a long story debated because infant formulation are kept in cans without oxygen. They have a long shelf life. So the ecology should be perfect for CBOT. Just one point, it's dry, it's low moisture food, so it's not growing. Having said that, again, we are working with a very sensitive population who suffers gut immaturity. And there are now, in terms of risk assessment, new proposal from the FAO to consider the gut microbiota of the host in your microbial risk assessment. Depending on the maturity is not the same. We already know, for example, that Listeria below 5 years has a huge impact. It's in questions of gut microbiota maturity and also botulinum. Very few labs can do it, and it's between 600 euro to 800 euro. Now, if you want to make a testing on your infant batch and you want to have the same sensitivity efficacy of sampling as for Salmonella, that's 60 samples, which means that for each batch, you've got 12,000 euro test just for CBOT. It's not possible. Your margin is there. So it means that economically, technically, it's not going to work. And also it does not make sense because the prevalence is very low. In this paper from the ICMSF, which is 11 pages, but still worth going for, they're mentioning the 2005 episode where it was believed and documented that CBOT was related to infant formula. In fact, in this episode, there was infant botulism, but the strain found in the gut of the neonate was not the same as the strain found in the product. So yes, you can have CBOT in your infant formula. It's usually at very low level below as an acceptable risk. And if you have infant botulism, which is going on with the present outbreak, what you need to do is clear epidemiological source. Now for this time, from the ongoing episode going on in the US, there are high chances still that it's still coming from this infant formula. So why can we say this? What's important to know is that, so the point is, I was asked recently from one attendant, you have the last figure is changing every day. So this is the numbers from Sunday, which has changed already because now it's not 15 babies, it's 23. In the California Department of Public Health, they've seen that they had ongoing 80 cases of infant botulism. So that was mentioned by Mansour before. And that 37 were exposed to infant powder, and out of this 74, 25 have taken by earth formulation. And by earth represents only 1%, which means that 1% of the population, you should not have a lot of cases. The fact that you have many cases is an indication that something going on with the formula. You don't have any tests, and you don't need any tests at this level. If you have epidemiological evidence, it's enough to conclude. So they decided to make the recall. How do we know that we could consider that the biological evidence is reasonable enough? Because the distribution of the cases is not local, it's global around the US, which means that eventually, if it's local, you can say that there is one habit, there is another food that could be implicated, but not in 12 states. So 23 cases in 12 states from a very low represented formula, that's enough to consider that there is correlation between the consumption of the formulation and the ongoing outbreak. Where's the button? Here. So it's still going on. This is the last figure from 23. What is important is the position from by Hertz, that they mentioned that yes, indeed, there is no regulation to test for CBOT. Yes, indeed, the CBOT that was found in the product was found in an open can. Usually, when you're testing with an open can, you try to be cautious because you cannot eliminate cross-contamination. The point is valid for yeast and mold. The point is valid for Enterobacteriaceae. The point is not really valid for CBOT. It's not ubiquitous in the kitchen. So Salmonella, Chronobacter, sometimes we deal with cases that indeed it's coming from poor hygiene in the kitchen, and it's documented. Now with CBOT, you really have a lot of hygiene issues to have a kitchen which is naturally contaminated by CBOT. So for the moment, everything is under investigation from the California Department of Public Health. We are waiting for the confirmation of the suspicious colony. And have in mind that for the moment, they have a suspicious colony that needs to be confirmed. And this is the issue where, in terms of screening with CBOT, it takes weeks. So it's not only expensive and difficult to do, it's very time consuming. So for the moment, unless we have a better screening technique, and also if we see that in the risk assessment it makes sense to test, there is no reason to change the approach, which is currently proposed to use a screening with hygienic indicators with Clostridium sulfitoreducing. Have in mind, the new name is Clostridium sulfitoreducing and not anaerobic sulfitoreducing. The name changed from the ISO standard 15213.1 in 2023 publication. It's a lot of numbers and acronyms, but that's microbiology. And infant botulism is on the rise in the US. In Europe, listeria is a concern. And in one of the publications that was about the case, it's interesting to say that one of the experts was concerned that people were a lot ignoring the guidance and that there were other sources that could be given. I'm not saying that this could be an escape road for buyers, but this is one of the points I want to conclude on the presentation. One of the key issues we do have now for infant formulation, but also for food generally in new microbial risk, does not come per se from the production process. It comes from misbelief from the consumer, but also from some food operators. So belief is not science, and I take this example from a recent publication about the fact that plant-based is believed to be safe by design. Its plant is safe. No, if you want to trace the romaine lettuce, I'm not so sure. Why? I don't know for Asia, but in Western countries, historically, food safety was handled by the veterinarian, which means that we have a lot of regulation, we have a lot of surveillance system for meat-based feed. We have a specific regulation in Europe, 183/2004, specifically for food of animal origin. We don't have the equivalence for food of plant origin. So there are a lot of things going on in terms of new food business where people believe that because it's natural, because it's animal-free, it should be safe. No, it's not. It's other risk. So it's the same point if you give Ayurvedic and you need to make sure that it's fit for purpose for the right population. It's be used for millennia, centuries in specific countries. That means it's fit for your countries. Have in mind that food is based on culture and the culture is different from one country to another. Now, as a concluding remark, because I want to keep on time for the next session, I'm already over 1 minute. I don't want Mariam to be angry against me. What we have clearly right now as a key concern for infant food globally is the lack of clear manufacturing guidelines. I will just give you the example in France. In France, every food industry, if you want to be in agreement with the Ministry of Agriculture, has a guide of good hygienic practices. We have a guide of good hygienic practices for milk and milk products. We do not have, still in France, in 2025, we do not have a guide of hygienic practices for infant formulation. Which means that for the time being, even in France, if you want to work in infant food formulation, that's based on your own assessment. You don't have clear industry guidelines. And that's the case in many, many countries. When it comes to processing environment monitoring, it's important to know that finished product testing won't help because of the cost of the implementation, but also of the relevance. And in the present case, which is going on in the US, particularly when you're working with dry milk formulation, it's important that's a sentence I say to a factory I've been consulting some years ago, and they still mention me this sentence almost 10 years after. You are as good as the worst of your supplier. And this is exactly what happened with this manufacturer in US. He is as good as his worst of the supplier. Now, if he didn't make the proper assessment, even if he's doing his job right, and apparently it does not, he cannot make it better, because with dry mix, you take what you have in your product. And this comes, last point, to the specificity of infant food. Because of the high sensitivity of the product, of the consumer, and because of the surveillance that you have, failure is not an option. Now, if something is wrong, don't fight against it, and collaborate as soon as possible with the authorities. And voila, 3 minutes. Okay, And I make some advertisement from the field IDF. Oh, no, it's closed. Damn it. It's going to be for tomorrow. So if you want to join the field IDF, I'm welcome. I can make the VIP as well. Do you have any questions, or do I leave the floor to the IFP special session?
Hello, everyone. My name is Marco. I will be the moderator for the next session. But thank you so much. Merci beaucoup, Francois. Get any questions for Francois? Or we're good to go? All right, once again, let's give a round of applause to Sir Francois. Merci beaucoup. So it's all ago. My name is Marco Quisaya, your engineer host, moderator for the IAFP Symposium. So let me introduce to you the next session. This symposium explores how scientific evidence, risk assessment, and practical decision-making intersect to drive effective food safety management. Speakers will unpack key concepts from risk assessment methods to the transition into risk management, while highlighting the real-world applications in the industry. Together, these insights will help bridge knowledge gaps and strengthen risk-based approaches across the food sector. And to introduce the IFAP Symposium, Mind the Gap, Bridging Science, Risk Assessment, and Decision-Making in the Food Industry. Let's give a round of applause to adjunct professor at the University of Queensland in Melbourne, Dion Money.
Good afternoon, everybody. We're aware that the sound is not coming through that clearly. Can you hear me clearly enough? Great, thank you. Mind the gap. Press the right button. Correct. And as just mentioned, this is an International Association for Food Protection Symposium, IAFP, Mind the Gap. And I'll start out with the term mind the gap, which is not, I think most people are familiar with the term. It's been translated into many, many different languages. It's interesting that it's a safety warning that originated on the London Underground in 1968-69. I think it's probably an early form of risk communication. And this was about trains on curved platforms and the distance between the train and the platform and avoiding the hazard of people falling down between the rails. And it's a very stock phrase that we use when we think about bridging disparities. And to some extent, that's what we're talking about this afternoon when we talk about risk assessment and risk management. Now, I'll just highlight that in terms of developing this program, this is really very much risk assessment, risk management 101. So we're not going to be diving deep into theoretical aspects of risk assessment or into anything like quantitative risk assessment. This is 101 to leave people with some ideas and some thoughts about what we need to do to manage food safety risks in the food industry, and hopefully give you some ideas and questions on moving forward. So this is just a brief overview. We're trying to bridge that gap between scientific data, the science, the risk assessment, and the risk management. We have three of us are speaking in this team, and just a plug, we also have a workshop, a one-day workshop tomorrow in this venue. So we'll be talking in much more detail about some of the concepts that we're talking about this afternoon. So our plan is to tackle that relationship between scientific knowledge, objective knowledge, turning that into risk assessments and risk management. The program is slightly different than was scheduled in the app. We've turned some of the timings around, so we're going to have 4 more detailed presentations and then a question and answer session at the end. I'd just like to say that we attended the session yesterday afternoon with Rahif Hanifa from the Dubai municipality, and he talked about variance and HACCP plans and really highlighted from a practical sense the challenge that they face when they're seeking to vary a requirement under the food safety legislation in Dubai and the need for a risk assessment. So it dovetails very nicely with what we're planning to talk about this afternoon. So I'll now hand over to Dipon, and we'll start proceedings.
Good afternoon, everyone. As Dion mentioned, this is Risk Assessment 101. So, and especially in the next 20 minutes, I'm definitely not going to make you expert risk assessors. We're barely going to scratch the surface, but the whole point of it is to make you curious, aware, and we've got an entire day workshop tomorrow to explore these concepts more. There's expert risk assessors in this crowd that you can direct some of your questions to if you don't want to ask us the questions. So yeah. Do I need to point it somewhere? All right. So yeah, let's start off. The first of the talks is basically highlighting the theories and the basics of risk assessment, the Codex 4-step model. My name is Deepan Sarkar. I am a risk consultant based in Sydney, Australia. So if I ask you, or if anyone asks you, what are the chances of rain today? And you go like, nah, you just did a risk assessment. Very qualitative one. That is a risk assessment. The hazard in this case was rain, and you just assessed the chances of that happening or not. If you whipped up your phone and showed this graph and told 10% chance of 0.1 mil rain, that's a very quantitative risk assessment. But the idea is that we are doing risk assessments every day. We are doing risk assessments about whenever we're crossing the road. But the concepts are similar, but the whole point of doing the frameworks are made to make a science-based, repeatable decision-making tool that aims to provide us the framework to be able to assume what the likelihood or the consequence of an hazard is. Risk assessment in totality falls under the risk analysis framework. It's one part of the whole gamut of risk analysis. It works, you assess the risk, then you manage it, and in all of it, you need to communicate it. If you're assessing a risk and you're managing a risk and you're not communicating well, you're not doing a very good job. According to the Codex steps, there's 4 very distinct steps when it comes to risk assessment: hazard ID, hazard characterization, exposure assessment, and risk characterization. We'll be talking again very briefly about each of these steps, just to give you an idea what they mean. Hazard ID, as the name suggests, it's pretty intuitive. We know a hazard, then we try to figure out what about the hazard should we care about. So the main objective, the main purpose of a hazard identification process is to know more about the hazard that we are talking about. There's this triad that we speak about: host, pathogen, and the matrix. In the case of matrix, in the case of food, the food industry, the matrix is always food. So we want to know more about this triad. We use the main purpose of hazard identification is to identify the hazard found in the food and figure out what the causes can be and what the adverse health outcomes can be. So the type of data that we use in hazard identification is epidemiological data, prevalence, and concentrations. So Francois' presentation was very useful as a precursor to this. We understand early warning. We understand what kind of hazard is out there in our food industry. Now, sorry, another disclaimer that I should have given is all 3 of us presenting here are microbiologists. So this is a very microbiology-focused risk assessment session. But the concepts are very similar for chemical or allergen. But yeah, we are microbiologists, so we are very biased here. Hence, I've even mentioned microbiological hazards. So important considerations when we are doing hazard identification is: what is the hazard of concern? What is the pathogen of concern? Is the pathogen of concern a big public health threat? What is the population at risk from a public health standpoint? Do we have epidemiological evidence out there that can point us towards what's happening? When people are getting sick from this pathogen, what is happening? What are the adverse health effects? And how common are the exposure pathways? So is it an airborne? Is it a contact transmission? So these are the type of things that we really need to know more about a hazard before we dive deep into an assessment. That brings us to the next step, characterization. So it's the description of the effect. So if you are exposed to the hazard, what is the effect that you will find? So this includes things like dose response modeling, understand what the dose exposure and the response would be. So when we think about what we need to do for a hazard characterization, again, it can be a qualitative or a quantitative description, depending on what level of detail you can go to or you want to go to. The outcomes that we are trying to achieve is to understand things like population of interest, who is this pathogen going to affect, the clinical forms, the duration of the illness, if there is going to be an illness, the severity, the secondary transmission, if there is one, and the probability to cause adverse health effect, which is the dose response modeling. So this can be done in a very qualitative manner by adding qualitative statements against each of these intended outcomes, or it can be done in a very quantitative manner, which is the gold standard, where we attach very quantitative measures of each of these outcomes. Now, all of this is kind of a precursor so that we can actually dive deep into exposure. And now, as the name suggests, exposure assessment is the evaluation of the quantity of the pathogen that you will be exposed to at the end of the pathway. Again, it can be a very qualitative description, low, medium, high, or various versions of that, or it can be a quantitative description. The outcomes that we are intending at this process is to figure out frequency of the exposure and the amount of ingested dose. Now, this equation is like the central framework for exposure assessment, where we're basically saying that the initial concentration that is inherently present in your food product, then that food product goes through the supply chain, and there's probably an amount of growth or an amount of inactivation. That's the G. Then if we process the food, if we heat it, if we subject it to high pressure processing, there's going to be some sort of decrease. That's the R. And at the end of all of that, while it goes through the supply chain, after all the increase and the decrease, the resultant of that is what the consumer is being exposed to. So the idea is to follow the pathogen along the entire supply chain, figure out whether it's increasing, it's decreasing, and at the end, figure out what's the final concentration. You can do this in a qualitative assessment, again, high, medium, low, very high, whatever that means. Or you can do it in a semi-quantitative pathway by adding certain numbers against these qualitative description. Or you can go down the fully quantitative pathway, where we start with an initial concentration that we either assume or we know through epidemiological data. We follow the pathogen along the supply chain through, again, epidemiological data or modeling. And at the end of the supply chain, we through time temperature relationships, knowing time temperature relationships, we figure out what is the end pathogen amount. So this whole qualitative, quantitative, as you saw, there's each and every step can be done in a qualitative way or a quantitative way. Quantitative is the gold standard, but quantitative is also very resource heavy, time heavy, data heavy. We do not have that much amount of time all the time. So we do qualitative risk assessments all the time. After finishing a PhD 3 years ago, I've been working in the food industry as a risk assessor, and I have yet to see a single quantitative risk assessment at a food industry level. I've seen it at a regulatory level, but not at a food industry level. that is the reality, and there's a reason for that because of the amount of data and time required to do a quantitative risk assessment. So at the end of an exposure assessment, that's step 3. At the end of exposure assessment, we know our pathogen very well. We are best friends with it. We know where it grows, what it does. If we get sick, what's going to happen to us. We know what's happening to it in the supply chain or in our food, whether it's increasing, it's decreasing at the end of the whole shelf life. What amount of pathogen can we be exposed to, or at least a probability of it. We know all of that, but that is still not the risk. Knowing amount of pathogen ingesting is not giving you an indication of whether it's a risky thing or not. That's why we need to go to this final step, which is called risk characterization, where and this is the process of determining the qualitative, again, the qualitative or a quantitative estimation of what will happen when you get exposed to all these, the pathogen. Now, this can be a description of the characterization of the severity of the illness, how much probability you have of being exposed, and what are these adverse health effects can be. So the whole funnel of 3 steps that we go through this is the final step of actually characterizing the risk. Again, can be qualitative, can be quantitative, or can be a mix of both, which is semi-quantitative. There is a table missing here because of my last-minute editing. Apologies for that. But that is a table that you're probably all aware of. Imagine a classic 3x3 or a 5x5 with the colored green to red. Everyone's seen that, right? So that table should have been here. Just imagine that, please. So that is a classic qualitative risk matrix, where we plot our risk against high, medium, low of consequence, and similarly of likelihood. And again, this kind of a, is there a laser here? No. This kind of a table is used to describe those risks again. So as you see, none, very low, low, medium, very high. This is a very detailed likelihood descriptor. It kind of gives definition of probability of exposure and severity categories that we use to characterize the risk. Moving on from there, adding a bit more detail to it. It's a semi-quantitative method where we start adding a few numbers with these descriptions. This is often called a risk scoring or a semi-quantitative risk characterization process, where there is some quantitative descriptions of the terms that we are using. As you can see, very low means a probability range of 10 to the power minus 4. How you determine that is a $1 million question. But if you've not gone down the quantitative way, the whole pathway, how at the end you can determine whether the probability is less than 10 to the minus 4 is, I don't know how to do that. But we do use these kind of descriptions to characterize our risk. Similarly, it can be used for consequence of describing how bad the consequence would be. Would it be very high, adverse, catastrophic, leading to death? And altogether, we plot it, again, take all of that information and plot it in a 5x5 or a 3x3 matrix, as you can see in the top left, top right. Then there is the gold standard, which is a fully quantitative measure of risk. It can be measures like DALY or a monetary measure like cost of illness, cost of disease burden. And from a quantitative measure, what really helps us is to determine relative risk or risk reduction. Because ultimately, we are doing all of this to assess risk and also assess mitigation strategies. So if you have a quantitative risk characterization, it's much easier to do a relative risk or a risk reduction calculation at the end of the day. The graph here is not to make you experts of DALYs, but this just to show you this is the kind of measure that we use. The other measures are things like this, the probability of illness for a given dose, all of which can lead to things like cost of illness, monetary approach to risk. There's cost-benefit analysis, these can all be measures of risk. Now, where does all of this take us? It's very good frameworks that we have available. All of this, and this is probably my favorite graph out there. I think it's from ICMSF 2007, 2003. And it just shows you that this level of risk, the risk assessment ultimately ends in risk matrices, risks matrix that we use all along the supply chain to ensure that we are either compliant or we are trying to achieve the level of protection that we require. So these are all risk-based metrics that we use in our food safety management system. So we've already touched upon this, but this is just for a comparison of what the outputs can look like for a qualitative or versus a quantitative risk assessment. As you can see, a quantitative risk assessment is quite complicated to interpret. It is complicated to do it, so of course the final interpretation is also pretty complicated, whereas a qualitative risk assessment will ultimately lead you to high, medium, low. There can be some descriptions of what that high is, what that low is, whereas in a fully quantitative risk assessment, you will get that description as a probability of illness, a probability of regulatory failure, a probability of whatever you're trying to characterize. That's really up to you to design the model in that way. Whereas in a semi-quantitative risk assessment, the output often looks like this. Semi-quantitative risk assessments are very, very useful when you're trying to compare a vast variety of measures or risk mitigation strategies or, for example, raw materials. You do not have a lot of data, but you do have some data, and you're trying to convert your qualitative descriptions into a score and put it in a matrix like this to be able to quickly compare. Some quality assurance, like everything, there is quality assurance required when you're doing a risk assessment. Data evaluation is definitely one, garbage in, garbage out. So we need to ensure that that's not the case. Data collection, sorting, data collection methods that have been used. The final model, whatever you make, whether it's qualitative, quantitative, or semi-quantitative, has to be verified. The uncertainty and the variability, which will always be there, needs to be talked about. And validation. We can make a fancy model, but does that model actually work? Does that actually say the truth or anything close to the truth? Needs to be validated with real-life data. And definitely extrapolations and robustness needs to be tested. We can't just take a model that was developed for some other purpose and use it for a different purpose and say, voila, here we go, we have a great risk assessment done. And documenting a risk assessment. I personally think a risk assessment is as good as you document it. If you've done a great process, but you haven't documented it at the end of the day, then sorry. And there are a couple of things that is required to be documented pretty well. The references of the data sources that you've used, the data that you've used, the scenarios that you've evaluated, the model that you've used, the analysis methods, the justification of your choices, because we are assuming a lot of things whenever we don't have data, the assumptions that we've made, and at the end of the day, the verification and the calibrations that we are doing. So all of this ends up, this is just a simple table to document what we've talked about, what the four steps were, and at the end, you could use a table like this to document your risk assessment too. Oftentimes, why there is a highlight around the hazard ID and the hazard characterization is because oftentimes, when we are doing it in a food processing environment, we already know what the hazard is. We are doing a risk assessment because we've got a salmonella positive somewhere, and someone's told us to do a risk assessment, hence we are doing it. So we know the hazard. We also know the hazard characterization. It's not as if we have to go out and collect the data. There's great resources out there that we'll talk about later that already has done all the hazard characterization for you. So we are not, oftentimes at a food processing environment, we are not doing these two steps in detail. We are, though, focusing on the exposure assessment and the risk characterization. Thank you. I think I've stuck to time. With this introduction to 101, I'll hand back the podium to Dion for further diving into risk-based food safety management. Thank you.
Thanks, Dipon. So Dipon has handed a risk assessment. It could be qualitative, semi-quantitative, quantitative, to me as the risk manager. Now, I remember when I first started out many years ago on this path, I can remember an eminent risk assessor asking the question of an audience such as this, why are risk managers so dumb? And having done risk assessments, it's something that resonated with me for quite some time, because we often, a really important part of the whole risk analysis framework is risk communication, which is both internal, across the process of doing risk assessment, risk management, and of course communicating with the public. So I'm going to tackle this talk on the path from risk assessment to risk management. And we'll start out with the definition. The Codex definition for risk management is on the screen there. It's quite a complex definition. The process, distinct from risk assessment, of weighing policy alternatives in consultation with all interested parties, considering risk assessment and other factors relevant for the health protection of consumers and for the promotion of fair trade practices, and if needed, selecting appropriate prevention and control options. So it's a really complicated term, and when we're talking certainly in the food processing environment, people's eyes glaze over when they see a definition such as this. It's also important that risk management is fully documented, it's consistent, and it's transparent. So I think of more a plain English version of that definition, which is food safety risk management is a systematic approach that identifies, evaluates and controls potential hazards as defined by the risk assessment as identified, and to ensure the safety of food products and protect public health. And what that means is that the things that guide the management of an identified and quantified, qualitatively identified risk, prevalence of adverse health effects, that clearly is a motivation for us to do risk management. It looks at production, storage and handling practices along the food chain. It looks at the economic considerations, cost-benefit analyses, certainly at a national level when it comes to risk management, need to be supported by cost-benefit analyses and clearly positive benefit to cost analyses. The feasibility of enforcement requirements, regulatory requirements to manage particular hazards need to be able to be feasible and enforceable, and we need to identify the methods that we're going to use to do that. So if I look at the national level, where you might have a national body setting food standards based on the based on the outputs of a risk assessment, at a national level, national bodies, they establish standards, they set enforcement processes, they might develop guidance documents to support companies and underpin them with things like good agricultural practices, good manufacturing practices, good hygienic practices. Establish control measures at certain points along the food supply chain, require import certification, and in places such as the Emirates, where so much food is coming in, an important risk management strategy is to have those import certificates, those certificates of analysis for products coming in. Now, Francois mentioned the failures of final product testing, but in the absence of good information about the way a food is produced, the very least is the value of an import certificate, which has microbiological and chemical and analytical data which supports the safety of that consignment. And the other thing that at a national level is promoting awareness of risks, promoting awareness of the hazards and then the risks that they present to groups such as the elderly or the very young or pregnant or immunocompromised. For the regulatory authority, such as the Dubai municipality, risk management approaches are different. They're not setting, typically regulatory authorities are not setting the standards, they're set at a national level. But so risk management at that level is about things such as enforcement activity, inspections, audits, sampling of products and testing products in the marketplace. That sort of approach is risk management, as is review of control measures along the food supply chain, examination of import certificates, development of educational resources. But for us, the important one here is what the food industry does and what risk management looks like for a food processing company, a food service company, a major catering outfit, anyone that's involved in the production of food for consumers. The food industry risk management is things such as inspection of incoming raw materials, certificates of analysis again, reviewing those and requiring those when supplies are being provided by third parties, control and prevention of contamination or introduction of hazards, particularly with incoming raw materials, particularly the highly perishable ones, the correct processing of food, so adherence to things such as temperature control over the pasteurisation of a product such as milk, using high temperature short time, 72 degrees Celsius for 15 seconds, risk management to control the identified vegetative hazards that might be present in that raw milk. Correct labelling of food is a form of risk management, particularly for consumers that need advice on things such as allergens. And the importance of developing and testing out things such as withdrawal and recall procedures for unsafe food. In terms of the support for the food industry, there's a lot of resources out there, and I go always to the support that's provided by entities such as the World Health Organization and the Food and Agriculture Organization of the United Nations. The WHO Global Strategy, which was released a second time, the strategy for food safety emphasises the importance of coordinated governance, adequate infrastructure and evidence-based, people-centric systems that look at those hazards that we might identify along the food supply chain. And there's a whole lot of resources out there that support risk managers when it comes to identifying or deciding what you're going to do with a risk assessment and how you're going to manage those risks, bridging that gap, minding that gap between the scientific objective data provided by the risk assessment and turning it into something which is practical, enforceable, cost-effective for managing food safety. So the Codex standards provide comprehensive information, and of course when it goes wrong there's another support, which is the International Food Safety Authorities Network, InfoSan, which reports globally on incidents which cross national boundaries. Now I want to quickly go into a couple of little examples of how risk management might look like, and this aligns very nicely with Francois's presentation earlier before this session. And this is about the risk assessment work that was undertaken by the World Health Organization and FAO in the early days when Enterobacter sakazaki, Chronobacter species were identified as a problem. So this was a number of years ago, but it gives an important example of how a risk assessment, or risk conversations at that time, I should say, informed risk management. So, as was highlighted earlier today, powdered infant formula, PIF, is not a sterile product. This low-level contamination is potentially possible by not only Salmonella, but by Chronobacter species, despite the best efforts and the best intentions by the manufacturers. It can be in the processing of the raw milk or skim milk into skim milk powder, but it can also be in the formulation of the dry mixing of the other ingredients that go into powdered infant formula. And at the time we were seeing a real jump up increase in numbers of particularly neonates of low birth weight, immunocompromised neonates, and low birth weight neonates with quite severe infection and death as a result of infection by Chronobacter species, resulting in death and, for many young children, sequelae that were long life-lasting injuries to these children. The important thing here is that the organism can't grow in powdered infant formula in its powdered form. It's got a really low water activity and it doesn't grow. But of course, once you reconstitute the infant formula, then you've got the potential the organism can grow. And given that we provide milk to neonates at temperatures around body temperature, perfect conditions for an organism such as Chronobacter to grow and survive. So that risk assessment was then looked at by risk managers, and they came up with a number of strategies, and as flawed as was discussed earlier on, the importance of final product testing. They did develop microbiological criteria, which are used today, and it was 30 samples to be tested, and the C was 0. No sample was to detect Chronobacter species in 10 grams of product. But importantly, there was other support there, recognising the failure or the inadequacy of final product testing. The two other things were the guidance on preparation of the milk and guidance on consumption. And as I said earlier, the particular subpopulation that we're most concerned about are those low birth weight, premature babies and babies which are immunocompromised, avoidance of providing powdered infant formula as a support, a dietary support, rather to use a processed product which has been sterilised. But then there was the guidance on the manufacturer of this product. And so Codex Code of Hygienic Practice for Powdered Infant Formula was developed, and it gave detailed information for manufacturers on how to produce this product safely, and the importance for that adherence to those good hygienic practices. Let's now move to the food processing environment. I'll just quickly go through a couple of examples here of how a risk assessment can be used to guide what a risk manager, and often in a food processing environment, the risk assessor is actually the risk manager as well. You know, we're talking about quality assurance people, production people that are assessing a potential risk, and as Dipon highlighted, they're not doing a hazard identification or a hazard characterisation. They're looking at exposures, they're looking at data on the number of organisms or the presence of a chemical hazard or potential for an allergen to be present in a food which is not going to be declared on a label, and making decisions in real time, quickly and in real time. They can't spend 6 months going away and studying the actual issue. They need to come up with answers very quickly. So let's look at a scenario here where we've got Listeria monocytogenes is detected in a food that won't support the growth of pathogens. So you get a test result back. You've sampled 5 by 25 grams, and you've got a positive result in a food that won't support the growth of Listeria. So a risk assessor would then go away and say, well, what are the actual levels? So it probably requires some further testing to quantify rather than just have a positive or negative detection. What is the shelf life of this product? Most food standards have a requirement that if food has got less than 5 days shelf life, then it's not considered to be a food that doesn't support the growth of Listeria. Is the food consumed by at-risk people? Is it going to an aged care facility? Is it going to a creche, etc.? How is it packaged and labelled? Can it be temperature abused? The risk assessors, though, have come up with an answer that says this is a low-risk product. So then a lot of questions then, and this is where the gap comes in. What is that risk manager going to do with that information? There's a pathogen potentially in that product, or in that product, determined to be in that product.
Hello, everyone. The sound is really weird in this room. So I hope you had a good introduction. I'm sure you had a good introduction to the topic with the previous speakers. I'm Marie Melouz. I'm the corporate microbiologist at Ferrero, and we are going to deep dive a little bit more into the topic. So I'm going to talk to you about risk-based approaches to food safety management. This is the agenda of our presentation. But before going into more details, I would like to know from the audience. So please raise your hands if you have ever done a risk-based assessment. Okay, please keep your hand raised if you have done a quantitative risk assessment. Wow, I'm impressed. And raise your hands if you are only doing qualitative-based risk assessments. Don't be shy. Okay. So thank you for this feedback. I can tell you that from the previous time that I did this exercise, I'm very happy to see that the number of hands raised actually increased. And the reason why I think this number has increased is because we had a trigger. And according to my analysis, you might tell me if you think I'm wrong, is that we were triggered to do that because of food safety and quality management systems. So I think we all know what quality and food safety and quality management systems are, but I would like to take you for a brief history to see our relationship to food, because we are not so rational when it comes to food. We tend to be very emotional, in fact. So we were not there, but we were told that in the Middle Age, food was scarce, but not only was it scarce, it was also dangerous. So eating was a dangerous activity because you could die out of it. So today, we don't have this tolerance to this risk anymore, even though you might argue, I'm French, we do eat tartare, and we tolerate it. So our relationship to this risk that we take when we eat food has evolved over time. So if we look at the second step of this slide, you can see that as we were developing more and more our food producing systems, we arrived at an age where convenience was important. What does it mean, convenience? By more and more people needing to work more hours at the factories, we started to have the need to have ready-to-eat foods. But guess what? This came with new challenges and with new situations that we did not used to have in the past. We have now to store the food longer, and this is something that is not coming without additional risk. Hopefully, this was also the time where we started to see scientific discoveries that were going to help us in this journey. So I'm referring here to Louis Pasteur, and I am also referring to this famous botulinum cook that helped us a lot by improving our way to do food safety. But this was not enough when men decided to send astronauts to space, because guess what? We were still having food poisoning, and I think they realized that it's not such a good idea to have a food poisoning out in space. So NASA worked with the Pittsburgh company and incident and had to recall its product because of not a microbiological issue, but a physical hazard. It was glass present in this product, that they started to apply HACCP into their operations. So even though the same company developed this concept for out of space, they did not apply it to their own operations. And the question here would be why? Well, they did not have an incentive to before they had this recall. And then, as you know, after in our 20th century, we have been exposed to a number of incidents and tragic incidents. This list does not want to be exhaustive. It's just there to remind us that these things happened. I mean, before the Jack-in-the-Box incident, nobody knew about E. coli and all the harmful effect it could have on infants, for example. Now, I would like to look at this as a trigger again, because these incidents helped us improve. So this is the good sign that we are learning from our mistakes and not, at least hopefully, trying to learn from them and not repeating the same mistakes again and again. And here, it would be really a pity to look at these incidents and just say that we are sorry and that we are not doing very well. But for me, a positive way would be to learn from those mistakes and to move on. In the past, we used to think that regulation was enough. What these incidents told us is that regulation is good, but it's not enough. So when you comply with a number of requirements, this is the bare minimum. But no way that the person who is setting the policy is going to know everything that could go wrong in that very facility that is producing a certain food. Guess what? The food safety and quality manager is the person who is the most knowledgeable about what could go wrong there. So why don't we ask these people and empower them to tell us what to do? So when we had the food safety and quality management systems, they started by putting the baselines, and HACCP definitely was one of the concepts that were introduced there. But we were missing something because it was basically based on hazards, and don't get me wrong, HACCP is a very good framework, but it needed to be supported by specific tools. And recently, we saw a change in the requirements. We saw more and more risk-based approaches and risk-based requirement being introduced there. And to be honest, this is where I could see the first bridge that was done between the concept of risk assessment and the operationalization. That's a difficult word to say for me. So how do we do it? To tell you this, I need to tell you a story. Some time ago, when I was still doing my PhD, I was at the same time overwhelmed and excited to do this risk assessment. So think about it, you have a fantastic tool to incorporate all the complexity that you can even think about into a model that is going to be like doing magic and giving you some output. In fact, it is not magic. It's very sound science translated into mathematical equations that can relate the output. So for those of you who are interested, this is like using techniques like Monte Carlo 2D to be able to input the variability that can come from the food product, from the strains, from the supply chain, and even the uncertainty that you have on the parameters that are characterizing those parameters, and putting all of this through to get a distribution of output about how many people can get sick out of the food. And if you don't want to go that far, you could also focus on how many units will exceed a certain microcriteria. So I was very excited about it, and I did that in my PhD, and I did publications out of it, even talked into conferences. And then I finished the PhD. And as an engineer, my first choice was not to stay in academia, but to go to the food industry. And I was very excited to take this knowledge and go and apply it. Guess what? When I was going that path, in fact, I realized that this is not so simple. Why? Because of two things. The first thing was that I changed from academia to the industry. So when I went to conferences and talked to people, I was not expected to give scientific insights on risk assessments anymore. That was very strange to me. I was more asked about compliance and about testing of finished products and what would be the best testing scheme. And I found it so weird because I did not change. I was the same person able of doing this again. But all of a sudden, I was not required by the ecosystem to do it this way. The second thing that I have observed is that I was now confronted to risk managers, both at the industry level and also in our food safety and quality ecosystem. And I could start to experience the gap that Deon was talking to us about. Risk assessment as a science goes very far and very fast, and it's very complex. However, we don't have risk management tools in order to be able to absorb the complexity that is coming from this distribution or the complexity that is coming and telling us what to do in order to take the decision when we have 10% of the products that are not potentially compliant with this micro criteria. So this comes to an individual decision, and it's not that easy. So having said that, where does it bring us? So we are in this situation where we have two shores. On the left-hand side, you have the business operators who are applying HACCP and trying to conform with these requirements. And they are told that the number of illnesses is far too high. So they need to translate this into actions that they need to put in place into their own factories in terms of processing environment monitoring, in terms of finished product testing, in terms of validations to be done. But how to put all of this in practice and all of this together is up to them. On the other side, we have the inspectors that can tell us about the probability that can be high, low, etc., but they rarely talk to each other. When I say that there are no risk management tools, this is partially correct, because the ICMSF has proposed such tools. And in fact, there is a bridge between the two shores. And when we had the first food safety objective for listeria, it was, at least for me, a breakthrough information, because now we had something to be able to trace back to what we can do at the level of a factory in terms of process objective in order to meet the appropriate level of protection for listeria. The problem is that not all of us went through this path. And even though the bridge is there, today we continue to see HACCP as the simple, qualitative, general, and focused hazard and operational tool. And we continue to see the risk assessment as complex, quantitative, specific, because oftentimes it's about one hazard in a specific commodity, and focused on risks and scientific. So the whole thing that we need to do together is to go from the risk assessment framework and apply it to the food safety management system. Now you are going to tell me, okay, but Mariam, how? You are telling us blah, blah things that we already know, but how do we do that? Well, it's not an easy question and it's not an easy answer, but for me, the capability building is the answer. And there is no AI that is going to transform this, because even if it's generative AI, and maybe you have seen some of the breakthrough examples on this, you might have seen the example of the AI that was not able to differentiate between a chihuahua and a muffin with some chocolate inclusion, but that's an easy thing because then you can spot it. You can see that the AI is wrong. How do you know if an AI is wrong or right when they give you outputs of a risk assessment for food safety? You need to be a very good risk assessor yourself to spot it out. So this is the first thing. We need to bring capabilities, and we don't want to oversimplify the problem, because if you oversimplify it, then it becomes wrong. And this is the gap that we would like you to close. So with this, I thank you, and we will go to the next presentation. So the next presentation is going to be a shared presentation between me and Deepon. So I thought it's good that you stand also here so that I can pass it over to you. And we are going to talk to you about risk appetite. So we talked a lot about risk assessment, what it can be and how you can apply it, but we also said that in order to make a good risk management decision, you are not taking only this risk assessment input. This is something that you do in knowing other inputs. And these inputs can be put in the organizational risk governance and also in the framework of operational decision making. And here there is another gap because these are interconnected and nobody's telling you how to make the link between them. So we are going to deep dive now into the concept of acceptable risk and risk appetite. As I told you, food is very emotional, and we don't want to think that we are taking risks when we are eating foods. But in reality, we do risky activities other than eating in our daily lives. We cross roads. I don't know if you try to go to the metro, for example, and if you think about the road here, for me, it's impossible to cross it, but maybe some other people would do, or maybe at night when there is less traffic. So we are doing these risk evaluations all the time. If we think about skiing, some people would go off slope and will find it very natural. This was, for example, when I was in Switzerland, something very popular, but I would have never done it. My children did it because they loved that and they were raised doing that. I would have never done it. So you see, our perception to risk is really something specific. So before we start, I would like you to take this quiz. We have two situations when, for example, for Listeria monocytogenes, we have either the criteria of non-detection in 25 grams or the criteria of 100 CFU at the end of the shelf life. So just by raising your hands, can you tell me if you think that the non-detection in 25 grams is safe? No? No one? 1, 2, 3. Okay. And who from you thinks that 100 CFU per gram at the end of the shelf life is safe? 1, 2, 3, 4. Right. This is a wrong question because I did not give you the same level of information when it comes to the first one. I did not tell you at which stage this applies. And also, there is a way to formulate the question so that you can have enough answers. So, for this example, I wanted to go back to a document that is quite old now, 21 years old, but to me is critical to understanding this topic because it's not about what is the right criterion. It's to understand the work to be done and in which situation we are. So in this quite heavy document, there was a question about understanding between these two limits, what would be the one that is providing a higher level of safety. And I mean, I invite you all to read it if you didn't do before. But here, what is saying is, of course, if we are going to compare for the same product, a limit of absence in 25 grams or non-detection in 25 grams and 100 CFU per gram, of course, for the same sample at the same application time, there is no maths to be done here. We understand that the non-detection would be safer. But guess what? In microbiology, it's not like this. You know that testing 1 or 5 or 30 or even 60 samples is not representative of what you have in your batch. You can only know the result of the one sample that you tested. So here comes the work to be done within this framework. So if you focus your work only on the finished product testing and don't do anything else upfront, you might not be in such an easy situation or in such a safe situation. And here comes the concept of the defect rate. So if you are doing work preventively, and I will show you that in a minute, that will allow you to be prepared to avoid having a pathogen in your product, you are better off because you will decrease the defect rate in your production. If you're not doing more than the basic minimum, and relying on the finished product testing, then your defect rate, even if it's not seen because you have no positive results, is going to be higher. Now, considering this concept of the defect rate, this work shows that you are better off if you are targeting 100 CFU per gram at the end of the shelf life compared to when you are targeting non-detection in 25 grams at end of production. So, very quickly, how do we know that a product is not supporting the growth? Because I often hear, but this product is not supporting the growth, so I should not be worried about this particular organism because it will not grow. But what if it's there? If it's there and not growing, it's also an issue. So there are a number of situations that would allow you to answer these questions, and you can also justify it through scientific studies. I'm not going to go too much into the details of that. There is also some, maybe this is a heavy chart, but just to let you know that here what we can see is that there is a path that starts with the characterization of the product. So your knowledge about the product is your main source of information. Then, based on that, you might have to do challenge test study or predictive microbiology studies to get to know if the product is supportive of the growth. And if the answer is yes, then you need to do an intervention so that your product is safe by design. Also, if you are doing only finished product testing, it matters how many tests you are doing. If you are going for n equal to 1, which I have seen in some situations, or n equal to 5, it makes a big difference. This is from ICMSF, I think you know the tool, and you can see that if you are doing only on 1 sample, it's not the same result as you are doing in 5 samples, so please don't do that. I talked about safety by design, and that's a concept that is very close to my heart, because this is how you should think about the problem of listeria, for example. From the beginning, you should design your product as not supporting the growth, not relying only on the shelf life or not relying only on the time temperature that you can have throughout the distribution chain. Because if that fails and your product is not supporting growth, this will help you. And of course, that does not prevent you from doing all the prerequisites and the preventive actions to avoid contamination from happening in the first place. But you need to have this additional level of protection, I would say, on top, so that if it happens, you still have a margin to protect the consumer. How far you go in this food safety by design concept is linked to your risk appetite. And this is where I pass it over to Deepa. Thank you. Sorry.
So Mariam's already introduced the concepts of risk tolerance and risk appetite. I'm trained as a microbiologist, but nowadays I do a lot of enterprise risk work and risk governance work. And I've been introduced to these topics of risk appetite at a board level or at an organizational level. As a microbiologist, this is way beyond my expertise. It's something that has really stretched my mind. I'm not an expert, but I think us as quality or food safety people, we have a bit of catching up to do in order to find our place in the boardroom. If you look at an organization, risk is not siloed. Food safety is not siloed. Food safety is one of the many risks that exists in an organization. Even in a food company, food safety is one of the many risks, such as sustainability, cyber, safety, occupational health and safety, information technology, supply chain risks. So if you're a board member, if you're an executive, you're looking at risks at a broad level, at an enterprise level, all these risks in one go. Food safety is just one of them. So we need to start using the same language, I think, to be able to influence boards at a level that needs influencing. Because I don't know many boards where there's a microbiologist sitting in the boardroom going, yep, I see that certificate of analysis, I have read the risk assessment that goes with it, and I can make an informed decision. So there is common language available. There are ISO standards for enterprise-wide risk assessment and management. For the management bit, it's ISO 31000. There are similar ISO standards for risk assessment too. So at an enterprise level, risk is often assessed against consequence descriptors that are safety, occupational health and safety related, financial related, food safety, stakeholder reputation or brand reputation related, and organization objectives related. So each and every risk is being assessed against these consequence descriptors. And here we come back to our favorite 5x5 matrix. It's a qualitative matrix. It has its limitation, but it also has its place. Because a risk map, an organization-wide risk map like this, lets you compare risks. That's what a board looks at an organizational level to see what are my risks as an organization. Where does cyber sit in relation to food safety? Now, you can challenge that assessment. You can challenge whether food safety is more important than cyber safety or vice versa. But at least this is what is being used, and I think it really has its place because it allows an aggregation of all the risks in one matrix and the comparison. And this is where risk appetite and risk tolerance really come into as concepts. Now, risk appetite at a board level or at an organizational level is the amount of risk that the board or the leaders is willing to accept or retain in order to achieve the agency objectives. It's an internal comfort zone that is set by leadership, and it's often almost exclusively qualitative statements. It'll be, for an example, the company commits to zero, that's a typo. Company commits to zero positive micro tests in finished product. It's a very qualitative term. We need to translate these qualitative terms at a board level into an operational, into something that is doable. And that's where risk tolerance comes into play. It's how much of a deviation we are willing to accept before we escalate or before we flag. It's supposed to be very operational, measurable, and actionable. For examples, if we are talking about a zone 3 Listeria testing, how many positive tests are we willing to accept before we escalate this issue? Before we take it to a board level, we talk about a plant shutdown. To get clearance of a plant shutdown and a deep clean, you have to go to the board. But what is the level that we are talking about that we have set as a risk tolerance level? Now, appetite to tolerance to monitoring, this is the risk governance framework, and it needs to talk to each other. If the board has set an aim like zero appetite for consumer harm from food products, well, that should be the minimum aim for every food company, and I'm pretty sure that is the minimum aim. But how do we achieve that? If a board sees a positive result for a product, do they just call for a recall of the whole batch? Well, that's where risk tolerance concepts come into play, I think. We set very measurable targets for risk tolerances before we start escalating and taking big risk management measures. And monitoring is also monitoring or reporting in the form of KPIs is something very essential. If we do not educate the board from the very beginning in terms of a crisis, in the form of a crisis, that is not the time for education. And education of a board from the very beginning starts with meaningful KPI reporting. KPI reporting that at the end, when there is a crisis, when there is a deviation, actually gives indication to the board that, yep, there is a problem and we need to do something. Let's talk recall, let's talk plant shutdown, and we don't wait. So if we define scientifically acceptable risk, that's one thing. Then there's the acceptable risk for the board. There's the acceptable risk as a safety manager, as a food safety manager. There's an acceptable risk for us at every level, whether we cross the road or whether we take the plane, whether we paraglide or we jump down an airplane. If you say to someone that, what did you do this weekend? I went up into the air and jumped from a plane with a parachute. That might be beyond the acceptable risk tolerance for a lot of people, but people are doing this as a hobby every single weekend. Similarly, once we define acceptable risk, that is not where the game ends. We really need to transfer that to the acceptable risk at a board level to maintain food safety objectives from an organizational level, and then to extend that to achieve the allowable level of protection at a society level. And that's where the gap exists still. as I said from the beginning, like I am a microbiologist. This is definitely not my area of expertise, but it is something that I've been exposed to a lot in the past 3 years, and I feel like a lot of food safety professionals, we can up our game here, align our languages a bit more to ISO standards that are being used at a board level, just for our education and the board's education. Thank you. So with that comes to an end of our organized session, and I think we have time for question and answer.
Yes, we do have. So thank you so much, Dipon Sarkar. And may we call back on stage Dion, Moni, and Marian Alus for the question and answer. So now, once again, this is your IAFP Symposium, Mind the Gap, Bridging Science, Risk Assessment and Decision Making in the Food Industry. So questions for the three of them. So, okay, we have one here. Thank you.
My name is Haytham. I have a question regarding this risk assessment report. I have seen Listeria monocytogenes risk assessment, which has been released in 2004. But if I need to know what are the updates, like in your case at the government level, you are doing regular risk assessment for different pathogens or chemicals. But if I need to know the results or the reports, how the risk assessment has been documented, the latest one, and how this has been communicated to the risk manager to make the decision, and what is the decision? Where is the source? How can I know the whole cycle? Yeah. I hope that my question is clear.
Thank you for the question. So you are right, that was the one from 2004. I would like to update the audience that there was one just released about the same pathogen, and I would like you to also review that one. The reason why I was talking about this, it was to highlight that back in the day, so 21 years ago, we already knew this information, but still today, we are still debating on what is best. So that was the intent. Now, to your question, I'm not I'm not a regulatory person, so I work in a food company. I can only tell you that when such risk assessments are released, of course, we read them carefully and we try to apply them to our context. And this is where the difficulty is, because these are time-consuming, they require a lot of data, and most often they do not represent exactly our products. So we need to adapt them, but with our own I would say tools. And then we need to communicate the result of these assessments to our managers. And our managers would say, like, what do you mean this could lead to one illness? This is not acceptable. So we need to somehow inform the decision, but in a simplified way, so trying already to look at interventions that would make this risk tolerable in a way that it is accepted, because otherwise we cannot proceed. So here is the gap also in terms of risk communication, because when we hear things like zero tolerance does not mean there is a risk of zero, because this mathematically or statistically simply does not exist. As long as you have pathogens out there and we are not consuming sterile food, even canned food come with a risk. So this is our journey, that we need to all be aware of the risks that are out there and that we are trying to minimize them. But it's not possible to completely get rid of them. Don't know if you want to complete or to add something.
I think your question also was around the source of information. So the reports that were shown were GEMRA reports, and if you go on WHO website, you can see updated reports. As far as I know, the new GEMRA reports were published last week in Foods. It's a journal. But yes, these reports that were shown, the screenshots that were shown, are all publicly available reports that are available on WHO website if you go and look for them.
And there was work by GEMRA, the Joint Expert Meeting on Microbiological Risk Assessment, around 2022-23. So there are some more recent publications, but they were risk assessments, very qualitative. They didn't result in any change to the risk management advice that's out there in terms of changes in microbiological criteria. That hasn't changed, but there has been some updating of that information.
Any more questions? Yes, please.
This looks like trouble.
Let's see. Let me reformulate so I can make it harder for you guys. Thanks for your talks. Very informative. So my name is Byron Chavez from the University of Nebraska-Lincoln in the US. So I'm a very fortunate academic in the sense that I get to work at the intersection of risk assessment and risk management, and then I get to communicate that with industry. And I'm really curious to know your opinion about, when we work with small companies that may be providing or producing a specific ingredient or that have specific process, it's very difficult to assess the risk, of course, for those companies, and then to manage the risk, right? They may not have the resources, they may not have the expertise, and that's typically where I come in. But most of these people are underestimating the severity of the hazards and overestimating the probability of finding the hazard in their product and process. Right, so how do you guys, especially maybe from a corporate perspective, how do you guys work with suppliers to help them navigate that kind of risk assessment and management of within their operations?
Yeah, that's for you, Mariam.
So thank you, Byron, for the question. It was said earlier today that in fact, the level of safety and quality of the product that you are manufacturing can be only as good as the level of your worst supplier. So I don't have a lot to add to that. I mean, this is critical. And I agree with you that oftentimes this is underestimated. So we say, it's their responsibility. But at the end of the day, if they have a failure, we are impacted too. And then without going too much into the details, it would also depend what type of products you are manufacturing. If you need to source so-called ready-to-eat ingredients, and then you don't have any kill step in-house, then you need to be more stringent in the way that you are doing your audits, in the way that you are setting up your incoming, in the way that you are looking and trending your certificate of analysis and not the certificate of conformities, for example. So there are a number of things that need to be done and that are known to, in fact, in the corporate world that needs to be done. Now, back to your question, how do small business operators do? It's unfortunate that each and every FBO needs to do the job, because I agree with you, this is something that should be available to everybody out there. And this is how we could enhance food safety for all of us. The reality that it is not like this. Even if we wanted to think about a database, for example, you talked about severity and likelihood in raw materials, why isn't this available to everybody? Like a database that everybody can refer to and go and source information. I know that there are a number of resources out there, but if you wanted to do the sourcing risk assessment for raw materials, this should be something available to all of us. But it's not. At the end of the day, each FBO needs to do it based on what is available, but they need to, and yeah, I don't have an answer for small scale. Maybe you would like to add something?
Yeah, I can't answer the direct question in terms of the suppliers, but I'll give you an example of an approach that's been adopted in Australia. Up until 2 years ago, there was no standard for the horticulture industry, and there was a lot of discussion about what sectors, because there are multiple sectors in the horticulture industry, but based on guidance from WHO and FAO, they focused on leafy vegetables or leafy greens, berries, because of incidents with hepatitis A with berries, and with melons. And we had notable incidents with rock melons, cantaloupe, with listeria and salmonella in the past. So much to the industry's, production industry's disagreement, standards were introduced. And there was about a 30-month period of implementation. Now, at the time when the standard was being developed, no one had any idea, because none of these businesses that were producing melons, berries, or leafy vegetables were licensed or registered with authorities. And in fact, many of them move in and out of products depending on demand and price returns. You know, they'll produce berries one year and they'll produce a different crop another year. So these standards were introduced. They've been in effect for 2 years. There was a lot of pushback and a lot of disagreement, but the benefit cost analysis proved that the cost of not regulating far exceeded the cost of regulating these industries. So now they need to be registered, and they have different requirements. Some of them require practically a food safety program, but they have basic things in terms of recording information about not only micro, but we're talking about use of chemicals, etc. But what the industry did, the peak industry bodies for these companies, they supported them with training programs. The state and territory regulators in Australia, which 6 states, 2 territories, provided a whole lot of, and they worked together, which was unusual for states to work together in our federation. They worked together to produce consistent material, published material, stuff that was on YouTube and on social media, to promote to the industry the need to address food safety. So it's bigger than what we're talking about here with risk assessment and risk management. It's about broad risk communication and putting in place simple procedures and advice on how they could conform with the requirement, and putting, you know, safe berries into the marketplace or safe leafy vegetables. So
Yeah,
that's a long-winded answer, but it's, you know, it's about a number of players, whether it's regulators, industry, peak industry bodies, educators such as yourself, to support that.
Yeah, no, I love that idea. I don't think it's going to happen in the US, right? Because it's the scale, and people don't really talk to each other, and there's this freedom that every company can do, can assess their product and process differently and however they like, right? But I love that. Yeah, thanks.
You got any more? As Mariam take us back a little bit, history and evolution of food safety and risk assessment. So what major shift will redefine risk assessment in the next 5 years? So that is for all the 3 of you.
Well, that's interesting, because I started work with WHO at the time when microbiological risk assessment was starting to take effect, and there was all that work that was done with poultry, with seafood products. And we were basically focused on micro risk assessment. Chemical risk assessment has been going on for many years through JECFA, etc., and they had quite consistent practices. Then we started to do nutritional risk assessments, and more recently in the work that WHO and FAO has done with allergens and risk assessment for allergens. So there's an evolution as we move through the various hazards that we face in our food supply. But I don't know. We're always constrained by data. Risk assessments will be much better if we had more data. Getting the food industry to provide data would be really useful. They do, but not enough. There's a wealth of information out there from industry that would better inform us in terms of fine-tuning our risk assessments and getting to the crux of a problem in order to then address risk management. But and then the risk management, it's about the tools, what we have in our toolbox in terms of how we can manage the risks. We've got limited instruments, and we probably don't use risk communication enough, partly because it costs so much to communicate. I don't mean risk communication in the context of the risk analysis process, but communicating to the public better and more efficiently. It's very difficult to tell immunocompromised people, one, to even find them, target them, to tell them you shouldn't be eating, raw cheese or raw milk cheese or smoked salmon products and other high-risk foods for that subpopulation. It's really difficult to get advice and guidance to those people.
Something that I think everyone's already seeing the impact of generative AI in risk assessment, and I don't mean in a good way. It is an incredible tool, but it is a tool. It's only as good as the user. So just because you're using AI that's producing information at much faster rate than if you did, I did a PhD before AI. I don't know what I would have done if there was AI during my PhD, but I've seen risk assessment that was entirely produced by ChatGPT recently. That was very interesting. If you are not trained, I don't think you would pick up a lot of the nuance. So ultimately, yes, it is affecting the pace and the information that is available, the pace at which we can do it and the information that is available for us to do it, but it is only as good as the user. So that is going to be a bigger challenge moving forward.
Yeah, maybe to complement on what Deepan just said, I think we need to be really careful with this technology. Don't get me wrong, I'm the first one to advocate for using it, but you need to build expertise on the specific topic to be able to evaluate the output. I mean, the hallucination of the AI is not a myth, it's reality. And for those of you who tested it on things for which you know the answer, you could see it. It depends on the prompt that you are putting, it depends on the data that you give to it, it depends if it's connected to the internet or not. But maybe to go from this maybe constructive part to a more positive part, there is a concept about risk negotiation that started to be, I don't know if you were exposed to it. We started looking at that with a group of people in a project called MicRisk, and I think that there generative AI can play a major role. So very briefly, the concept is that when you are going to take this risk management decision, you don't need to consider only the risk assessment part. So you will consider the risk assessment, you will consider also the legal implications, you will consider the economic implications, all sorts of inputs that need to be in the loop. And now there is a smart way to code for AI agents so that they can be the voice of these different stakeholders. This is based on game theory, and then you can have these agents communicate, but still have what we call a human-in-the-loop approach, so that you are, in fact, controlling the discussion, how it's going, so that if you see that the legal agent is saying something completely irrelevant, you can still correct it and improve the prompt so that this is not considered. So this is, I think, a positive development and could act as the next step for the risk analysis framework and maybe help us on the long term.
When it comes to data, maybe the Ferrero Group can help Dion for the data publicly. And got more questions for the three of them, I think. So I think it's coffee time. Once again, please give a round of applause to Dipon Sarkar, Mariam Luis, and Dion Honey. Okay, again, once again, that is the Mind the Gap, Bridging Science, Risk Assessment, and Decision Making in the Food Industry. Thank you so much, three of you, and we really have a good time. And please connect with them for your collaboration in the future. And once again, this is your 19th Dubai International Food Safety Conference, IAFP Symposium. Thank you so much, everybody.
Mr. Baker has authored or co-authored over 25 peer-reviewed publications and holds several patents. He has advanced degrees in microbiology, food science, and food technology. What's going to be fascinating about today's session is also that it's nostalgic in nature. Robert's going to take us on a journey through his career in the early days and talk about not just his personal experience, but also something that we can all relate to and take a look at the evolution of food safety and its impact in the world. Thank you for being with us today, Robert, and now I pass it over to you.
Yeah, thank you very much. And firstly, I'd like to thank the Dubai municipality and the organizers for the opportunity to share my perspective, my historical journey for food safety with you all. I feel privileged to be part of this great conference, and hopefully the information that I'll share will be useful and help maybe to guide some of you starting your careers in food safety. And to give a little bit of background, I've been, it's hard to say a food safety expert because I'm not sure really what an expert is. I guess I'm a professional and have been doing food safety for well over 35 years. Pretty much have done every possible role you can do in the area of food safety and quality, within supplier quality assurance, operational quality, distribution quality, setting up standards, setting up research platforms, pretty much you name it, I've done it. Also, I've had the opportunity to work with a diverse number of food products, ranging from confectionaries, low moisture confectionaries, pet food, ironically, also rice and frozen products, and also looking at other types of products for the humanitarian area. So been involved in that more recently. And if you think about some of the things that I've done, it's also been across pretty much every continent except for Antarctica. And I've either lived or actually worked in some of those different places across the developed and developing world. And, based on that, I'd really like to share some of my experiences and perspectives on that journey I've been on. And I'm still on that journey, and I'll continue on that journey for who knows how many more years. And let's see if the technology works. All right. So in terms of what I'm going to go through, and really with the theme of then and now, and what I'm going to do is my top 5. Why 5? Who knows? It could be top 10, but for me, these are the 5 areas that I've seen over my career that have been quite challenging, and really would like to share some of my perspectives on them. What can we learn from the past, and how do we then channel it into the future? What's interesting is it's interesting to be in Dubai. The first time I was in Dubai was in 1994. And even looking at Dubai from 1994 to now, it's amazing how much it's changed. And it's not just Dubai that's changed. The whole landscape of quality and food safety has as well. And I'm not sure it's changed as much as Dubai, but it's pretty interesting to say the least. So one thing to look at as well is myself. And sorry I couldn't be there. I'm not feeling well. I figure it's best to keep my viruses in my hotel room rather than share it in the conference room. So my apologies. And if anyone has any questions later on, please do send them to me through the Hoover app, and I'll do my best to answer them. So one thing that's interesting, and I know you're not seeing me, but this is the way I look today. And what's interesting is if you look at when I was a young, starting, eager food safety scientist, that's what I looked like. And it's interesting to see how much I've changed. And I also tell people that I'm not sure if I'm the poster child for a career in food safety, but lots happened over those years, with myself and in the world of food safety. So what I'm going to do, I'll go through my top 5, and it'll be interesting to see how these line up with your own top 5 or top 10. And what I'm going to do is I'm going to share some stories of what I've seen, albeit in factories, warehouses. It could be co-manufacturers, could be fulfillment centers, what have you. I've been in well over 2,000 facilities over my career and have a pretty good base to build my experience from. So my first area I have here is around food safety mindset and culture. And I know there's quite a bit being shared during the conference this week on food safety culture. And it's interesting, when I first started out many years ago, it wasn't even on the radar, in all fairness. And I still remember going to a co-manufacturing location, and on somebody's locker in the locker room was this sign: the beatings will continue until morale improves. And I'm not sure that's how we're going to get people's mindset culture in the right place. And but it was actually quite interesting, and that factory did have some challenges, let's put it that way, in the way that people were thinking and what they were doing. So if I look at years ago, and this is going back to the early part of my career, a lot of the things that were going on, if you look at it, there's a lot of inconsistent regulations. The quality and food safety standards, if they were existing, they tended to be more regional or local in nature. Some of the factories that were there, if you think about it, and this is a lot of this is looking at supplier base, they tended to be more lower cost factories with low overheads, and the conversion cost per ton really drove what the factories looked like and how they were designed. And back then, the internet really didn't exist, and social media definitely didn't exist. And I'm not sure if that's a good thing or not. Because we have our challenges from both. As much as they have their pluses, their positives, they also have their drawbacks as well. I've captured some quotes I've had over the years that deals with the mindset, and these are some that I used to hear walking through either factories, warehouses, what have you. And one of the things I would hear when I would talk to some operators, and first thing I would hear is, we've always done it that way, so why do you want to change what I do? Act now and ask forgiveness later, and no good deed goes unpunished. And another thing was, if it sews, it goes. And that was basically in a factory that did the sewed topped craft bags. So really saying that once it's sewed, doesn't matter, it's going to go out. And were quite interesting sort of things that have stuck with me for probably well over 30 years. If I look at now, and things have changed a lot. So if you think about it, there's increased regulations, and there's increased consistency. Many are global in nature. Codex has evolved quite a bit since my early days, and is actually provides a good global standard for others to emulate. Factory designs and overheads really is what's driven by the quality and food safety requirements. So it's not really based on having low overheads or MCC per ton, which is quite good. Today we have the internet, and it's great. We can get in, we can find things, and we can do things. I have question marks by social media. As much as it's okay, it can create some distractions and noise, where there could be things that are put out into social media that aren't accurate, and sometimes could put individuals or companies or what have you with the ghost hunts. And it's quite distracting in all fairness. What I'm seeing now is leading by example is a big thing, where the leadership in a factory really drives the culture of a factory. I remember early in my career, I had the honor to do factory audits with some of our senior leaders. And I do remember, as we would walk through, the senior leaders would walk in front of everyone. And if they saw things that weren't quite right, they would pick them up and they would hold on to them. And then by the end of the tour, they would pretty much share what they found. And I do remember people saying, I don't understand why they're doing that. And, the thing is, if a senior leader walks by something that's not right, it sets the new standard for quality. If they're not willing to stop, point it out, pick it up, what have you, it does set the standard for quality. So as we are quality and food safety professionals, as we see things, it's good to kind of make sure we're setting those right examples. And what I'm seeing more now is empowered workforces. So the workforces are able to point things out, voice their opinions, and do whatever they can to drive food safety and quality. The next area is around change management. And change management to me go hand in hand almost with culture. And it's really, if you think about it, how often do changes occur that people don't know about? And I remember many years ago that a supplier had changed one of their sub-suppliers, and it was for a mineral. And the mineral, the new supplier actually concentrated the mineral using a different process. And unfortunately, that process, not only did it get the mineral out, but it also concentrated cadmium. So the thing is really understanding the changes along the supply chain, albeit if it's little, big, or what have you, how do we get exposure to that? So if I think about years ago, a lot of the processes that were in place for change management, they tended to be informal, and they could have been implemented by anyone in the factory or along the supply chain. In many instances, they lacked formal validations, commissioning, or even governance to make sure that they were done right. And many times communication was on a need-to-know basis. And some of the quotes that I remember over the years is, "Oh my, where did that come from?" when you walk into a factory. So if you're ever saying that, you know something kind of slipped underneath the radar. And how long have you been doing that for? I mean, that could be more benign, but it also could be a sign of a change that's taken place that people weren't aware of. If I look today, there are some very structured and rigorous programs that are being used around change management, where there are clear steps that are followed, there are clear benefits, there's teams put together, there's sign-offs, which really is that governance process that's put in place. They are also tied into comprehensive business processes. And many companies have what's called commissioning, validation, and startup, which is a set process for implementing change, doing the right validation, and making sure when it starts up that all the, well, not all, but as many as we understand, the risks are managed and understood. And clearly there's a clear line of communication and built into the quality management processes of a factory. So if I think about those two areas, thinking about culture and also change management, you know, some of the key learnings I've had. So if I had the chance to go back and talk to me 30 years ago, some of the things I would make sure that I was aware of, and ironically, I would say over 80% of the critical incidents I've been involved with over my career were related to some form of a change management failure. And that's huge. And, you know, how do we make sure that, as I mentioned, that these things are being done appropriately, they're getting the right risk assessments, the right validations, the right understanding and governance. If you look about it, the importance of subject matter experts, and you're going to see that theme come up quite often. And one of the things that's interesting is, you know, really, what is a subject matter expert? I've had people in my team over the years, they would go to a 1-week training program and come back and tell me they were an expert. And wow, I wished I could go to a 1-week training program and be an expert on that area. So I think, you know, one area we need to think through is, what is a subject matter expert, and how do we actually denote what a subject matter expert is, and how their skills and competencies can be built into some of the things that we're talking about. Salmonella, the next one. And unfortunately, I've spent quite a bit of time looking and eradicating Salmonella over the years. And if you think about it, when I started, the science behind Salmonella was quite weak. It's gotten much better now, especially as it relates to low moisture, high fat systems, and the ability for it to survive, not necessarily grow, but survive for long periods of time. I've done some research and shown that it can last well over several years in different high fat matrices. And you can go back and you can isolate it pretty easily and it'll still be there. Even found it in some old, basically decommissioned pieces of equipment it was on this equipment 7 years earlier. And when I did some work, we even did gene sequencing on it. The sequence was within one SNP. So they just sat there for 7 years, which is pretty interesting. So if I think about the early days, inconsistent salmonella regulations, especially as it relates to pet foods, that's changed quite considerably now. Going through a number of different suppliers, when you get out there, a lot of the factories weren't designed to control salmonella. They relied on the downstream processes to control salmonella. And I mean, in some instances that may have some validity, but as far as I'm concerned, there needs to be something that's put in place that tries to minimize that level of contamination and the pressure that's put onto a factory as they get further down the supply chain. Number of factories or suppliers, non-validated, ineffective risk assessments and HACCP programs. But yet again, this was the early days of HACCP, and I think it's come a long way, in all fairness, but still back then it wasn't quite what it needed to be. And then the lack of science around the longevity of salmonella in low moisture foods. And it was funny because some of the things I used to hear and would be working out with third party co-mans or also suppliers. And some of the things I used to hear was, just convince me that salmonella is a problem with pet food. And we know today that it definitely is with zoonotic transfer, and it's something that needs to be controlled and understood. The other one was, why are you worried about it? Dogs eat roadkill and they lick their own asses. So why are you telling me to worry about salmonella? And yet again, it sets a different mindset. So if you look today, there's a lot more regulation out there, even including pet foods. Still a long way to go. I can't say it's consistent for everything, but things have evolved. The science has increased and has evolved. Understanding, how salmonella in products can pose risks and how those risks are manifested into, it could be animals or people. Factories tend to be more designed to manage that risk of contamination or at least minimize it, depending on what type of material is being produced. HACCP has come a long way, including risk assessments, how the risks are validated or the controls are validated, monitoring and training programs. But what I've been seeing now is there's a number of materials coming out, and I'll say the same around mycotoxins, to mitigate risks. And there's a number of different salmonellicides, pardon me, salmonellicides that are coming onto the market. And these tend to be either organic acids or in some forms could be formaldehyde. And I kind of struggle, why would I use a poison to kill a poison? So just something that needs to be looked at over the future and how they're used and how they should be used or not used. Let's put it that way. Some of the quotes I had there is, I just can't believe salmonella can survive on dry foods for years, and it definitely does. And that dogs can pass salmonella on to children, through zoonotic transfer. And actually the dogs don't necessarily get very sick, and it's hard to see. So key learnings that I would go back and talk to me many years ago, just really around leadership, around food safety culture and quality management and governance are key to food safety management. It's not just one entity. It's pretty much everything interconnected that actually helps drive the process and drives what's being done. Yet again, subject matter experts, and how do we understand the contributions, but also recognize what is a subject matter expert. Factories, laboratory monitoring processes need to be following the recognized and validated protocols. I've actually seen some facilities where they've taken it upon themselves to use different methods than those that have been approved, and things were missed, in all fairness. Water and water usage, and even today, most factories that are producing these high fat, low moisture products are managing water, but there's still some out there that do have it. And every time it's used, it increases risk. And every time it increases risk, there's a high probability it could get into products. Need to have a solid understanding of airflows in a factory, dew point, and hiding places. So one of the things that I used to do is I used to do intensive deep dives just really to go beyond the typical swabbing places. Because at the end of the day, you know, salmonella is not going to hide in the places where you see it. It's going to be the places you don't see it. And how do we actually go and look for those hiding places? The impact of maintenance activities, casual workers, and cleaning practices needs to be understood. And once again, this could be the weak link in factories or suppliers or what have you. And genomics is changing the game, especially in terms of source tracking, in terms of isolate comparison, in terms of really, you know, trying to understand what's going on with the spread or dispersion of salmonella. Mycotoxins. Now, mycotoxins are quite interesting. When I first started, they were kind of a black box, and people didn't really know a whole lot about them. You know, there was basically a lot done with the feed industry, but you know, they weren't regulated, and even, you know, up until just recently, there was certain commodities that, in all fairness, just are now starting to be regulated for aflatoxin. So, but if I think about years ago, a lot of the processes, the testing procedures, and that came from the feed industry, primarily focused on afla and DON, vomitoxin. I actually used blacklight screening, and I'll go through the future of the issues with blacklight screening. Sampling preparations were labor intensive. So just to actually go and do some testing took a lot of time, and there wasn't the methods and the rapids that exist today. And few labs had the expertise in this area. I have to say, in my early days, it was very hard to find labs that had expertise. And a lot of it we developed ourselves, I have to say. But some of the quotes I used to hear is that extrusion destroys mycotoxins. And it depends on which mycotoxin you're talking, but it doesn't really destroy it. It can reduce it for some of them, but you know, I wouldn't rely on extrusion to destroy mycotoxins. The other one is I used to hear, well, why do we reject loads? They're received, and then they just go around, and they're rejected, and they're just sent around the corner to somebody else. And you know, there's some ethical situations there, in all fairness. Today, a lot of what's being done around mycotoxins, it tends to be more risk-based. There's a lot more testing done around mycotoxins, a lot more awareness. So not just afla and DON, it's including fumonisin, T2H2, and some others, citrinin, patulin, what have you. Black light, I wouldn't recommend it because black light typically is used to detect kojic acid. And depending on where in the world you are, it can isomerize. And one of the isomers doesn't fluoresce under the black light. So there is a chance of getting false negatives. So one of the things, you know, definitely need to understand if you're using it, the implications of that. There's many steps that are standardized now, a lot of auto sampling, a lot of auto testing and preparation. The laboratory network is tends to be very capable, a lot more understanding, a lot more expertise. And as I mentioned with salmonella, there's a number of mitigation processes that are being looked at. When things fail in the fields with GAP, looking at binders, looking at enzymes or chemicals to break them down. I do worry a little bit there. So, you know, these materials are being broken down, but are the byproducts as toxic or less toxic than the parent compound? So some of the key learnings, you know, having a continued focus on mycotoxin management is critical. It's not one-off. So if you think about it, the risks of mycotoxins changes with every crop, with every growing location, supplier, or changes along the pipeline. It's something that needs to be evaluated constantly. And I spent time doing predictive modeling for mycotoxins, and it's not a simple thing. Let's put it that way. Effective sampling, validated test methods, trained personnel are required to verify compliance. As I mentioned, there's a number of mitigation strategies, but really need to understand where these are being applied, how they're being applied, and are they being used in lieu of prevention technologies or prevention efforts. And when the materials are actually being either sorted or what have you, and you have waste that's generated from actually mitigating the product, where do those waste materials go? Do they actually re-enter the supply chain? And I put here, be prepared for the unexpected. I have to say, mycotoxins, just when you think you know them, you may not. So, constantly look, constantly try to understand, constantly look at your supply chain. Then food fraud. I've had the unfortunate opportunity to be involved with a fairly significant food fraud issue involving melamine. And I have to say, I wouldn't wish that on anyone. And, if I think about what that's done to the industry, will melamine happen again? I don't know. Probably not. But what's the next melamine, I think, is the key here. So if I look at years ago, it's been around since the beginning of time. It was usually for some sort of an economic opportunity. Was typically a small scale, and this is years ago. I'm saying, when I first started, wasn't typically viewed as a food safety issue. It was usually looked at as impacting some spec parameter, could be protein, could be what have you, and in a way to kind of work through it, or moisture. Back then, there wasn't the tools to really understand the risks or proactively screen materials. And one of the quotes I used to hear many years ago is, we've become comfortably numb to things that don't look right. And if things don't look right, we need to question it. And because that could be the sign of something that's starting to change or go in the wrong direction. Where now, things are the same reason, primarily focused on economic reasons, but could be for malicious reasons as well. It's basically very sophisticated how some of these syndicates are actually driving food fraud, almost like organized crime. They can be food safety in nature, so it's not just benign. And today there are tools that are out there that can fingerprint raw materials and products. If you haven't done it, I'd probably suggest you do. And AI and horizon scanning are showing promise, but it's like I said, it's showing promise. I wouldn't just do that. You need to look and see what's happening along the supply chains. So key learnings: remain objective, avoid being drawn into what appears obvious, because sometimes things aren't what they appear. So clearly be objective. The importance of collaboration is really important in terms of food fraud. I saw Samuel Godefroy was there, and he's there with you guys this week. Sammy and I, we've done quite a bit in the area of food fraud, and I know Sammy and Chris Elliott, they do push the importance of collaboration and communicating things around food fraud. As I mentioned, developing these fingerprints of raw materials and finished products. Food fraud can be a food safety issue, and it should be considered as part of a HACCP or VASIP plan. Hindsight is always 20/20, but are we prepared for the next melamine? And as I said, it may not be melamine, but it may be something that's equally as impacting to the food supply chain. Horizon scanning AI can be helpful, but don't let that be the only thing. Experts do need to look at what's coming out of them, and yet again, be prepared for the unexpected. So what do we learn from the past to get better prepared for the future? And there's a big piece here around harmonized risk-based quality management processes. One of the things I've seen that's made a huge difference over the years is having harmonized approaches, and looking at how we put together standards, governance, but also continuous improvement around quality management. Even the best quality management process will fail without a clear and active food safety culture or culture of accountability. I think that's pretty self-explanatory. New technologies like AI will provide valuable insights at a scale much higher than ever before. But there has to be clarity on when human insights have to be brought into it. How do we ensure change management includes risk management and built into the business processes? Yet again, subject matter expert. What is a better understanding of what a subject matter expert is? And how do they become a subject matter expert? How are they trained? There's a lot of things going on in the areas of salmonella and mycotoxins. How do we ensure that the new science delivers what we're trying to do and it doesn't create other issues? And analytical methods now are becoming very sensitive, going from parts per billion to parts per trillion. And at what point does increased sensitivity impact food security without a significant impact on food safety? And then some closing remarks. Global challenges, food security, climate change may require radical transformation of food systems. We need to ensure that food safety actually becomes an enabler of food system transformation, not a blocker, which it can be if it's not done right. Move to risk or outcome-based food safety management. I think there's a lot being done in that area, but it's still not there. There's still a lot that's being done at limit of detection and things like that. And so where do we actually put risk into that? And food that goes hand in hand with the next one are becoming more risk-based. Once again, I'm not sure. New technologies offer promise to assist with food safety management, yes. The adaptable risk management framework will be key to enable real-time risk management and supply chain resilience. And the end, food safety challenges are complex and will require collaboration and cross-cutting efforts. It's not an easy area. It's as much as I can say, it's an area that is quite dynamic, but also things may not necessarily seem what they are. And with that, I'd like to say thank you for your attention. This is a picture of my little dog. She kind of sits right behind me when I do all my presentations. So I kind of gave her a little bit of credit because she kind of motivates me to do things. And my dog, her name is Pippa, and she thanks you for all you do every day. And with that, I say thank you. That's it.
Can you hear us okay, Robert?
Yeah, I can hear you.
Awesome. Thank you. And thank you for introducing us to Pippa. It was such a cute picture of Pippa in the background. And hearing you speak also took me in I want to say, nostalgic route as well, because it got me thinking about the first time I heard even the term mycotoxin and my journey through food safety as well. So it's interesting how it's come full circle, because we had a session earlier that was relating to education and media. And during the reflection session, there was a question that was asked to the group, which was, what would you tell your younger self when you started out?
That's interesting.
So, Robert, I think it's so ideal. If I were to pass the question over to you, what would you be telling your younger self if you had the chance?
I think for me is the big thing is make sure you seek to understand. Don't treat things as a given. Just because someone tells you something doesn't necessarily mean it's right. And how do we challenge the status quo? It's when we challenge the status quo that we make differences, we impact differences. I just see that that's probably the biggest thing I've seen over my journey, is being able to see things that weren't necessarily right. You mentioned mycotoxins. When I started on my journey around mycotoxins, there was very limited information. And, worked with a number of different people doing research, trying to understand sampling, trying to understand testing and the implications of it. Don't settle for where things are, and drive for things to be better. And I think that's the important thing.
Thanks for sharing, Robert. I'd like to invite members of the audience if there were any questions, or would you like Robert to dive deeper into something you heard today? Let's give Robert a sense of how present we are. Can I hear a round of applause for Robert, please? Robert, can you hear us? I think it needs to
No.
be louder.
I heard.
We have a question in the audience. Oh, a reflection. We have a microphone here. Feel free to introduce yourself to the audience. Thank you.
Hi, I am Paige Young. I work for the United Nations World Food Program. And going through this presentation, I just want to share a quick reflection. It's such an inspiration. And it really motivated me to challenge things as they are. When I started work for the World Food Program, I was a young food technologist, and I started working in Sudan. And I was given a lot of protocols as to how food safety should be implemented. I was full of questions. How do I take these protocols and implement them in these very specific real-world challenges? And I really like what, Bob, you said about what you said to your younger self. Really challenge the status quo, look at how can we best do that, and do not just follow necessarily the protocol itself without posing a question. I just want to thank you for sharing that. And yeah, just really thank you so much.
Thank you so much for sharing.
Thank you. I must also say, Julie, that Bob was supposed to join in person. He's not well, and he's taken all the effort to join us. Thank you so much, Rob, for joining us. Get well soon.
Yeah, and my apologies, but I figured I'll keep my virus to myself and at least share the word. So hopefully that's okay, and it did what we hoped it would do. So thank you.
Thank you very much, Bob. Appreciate it. And
Okay.
on a candid note, before I leave you, I love that you underscored subject matter expert. So now I have something to pass on to my mom and ask her, are you asking me as a subject matter expert or as my mother?
That's a good one. I like it. I like
That's
it.
my takeaway.
Okay, excellent.
Thank you very much, Bob.
All right, thank you.
A round of applause for Robert, everyone. Thank you.